why Mars changed so drastically. What they then actually discovered shows that Mars is still alive. What does this mean now exactly, also in view of the future settlement of the planet? And could Mars become a living world again through clever terraforming? Stay tuned, because we will now show you Mars from a completely unknown side. In 2018, the InSight Mars lander launched toward the Red Planet. InSight is short for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport. The lander was developed specifically to find out what exactly is going on inside the planet and how the core of Mars is structured. Now, you may think that this is not as exciting as exploring the surface and searching for traces of life or water. But the core has it in itself. It is only in the hitherto completely unknown center of Mars that researchers are finding the missing answers as to why Mars has developed into what it is today and why it has gone from being a possibly inhabited world to a dry wasteland. Using drills and special analysis equipment, the probe penetrates deep inside, taking seismic measurements and recording both the number and intensity of Martian quakes. In the strength of the quakes, researchers currently encountered a big surprise. How does the core of Mars differ from that of the Earth? To understand the explosive nature of InSight's findings, we must first look at the structure of our Earth's core. About 100 years ago, researchers first had the technology to scan Earth's interior in a very unique way. Scientists analyze seismic waves that travel through the Earth's interior. These waves are triggered by natural events, such as the movement of continental plates and even phenomena like earthquakes. As they travel through the Earth's interior, these waves encounter various materials. During the contact between material and wave, the wave takes on a very particular signature that scientists can later distinguish. Layers of rock alter the waves in a very different way than underground cavities or watercourses. Seismic waves occur mainly as P and S waves. P waves, or primary waves, are pressure waves that cause rocks to vibrate parallel to the direction of wave propagation. Because they are the fastest seismic waves, they are the first to arrive from the epicenter of the earthquake. S waves, or secondary waves, are shear waves that vibrate rocks perpendicular to the direction of wave propagation. They travel about 60% of the speed of P waves and arrive after the P wave has passed. In 1906, seismologists discovered that seismic waves travel much slower in the Earth's core than in other sections. Even more interesting was the observation that S waves did not penetrate the core, while P waves passed through it easily. Only at the boundary of the core did an interesting deflection occur. From these observations, the scientists were able to conclude that the inner core is solid, while the layer above it is liquid. The core of iron and nickel in the innermost becomes solid due to the high pressure. In 1936, researchers again found that seismic waves reflected off the inner core, indicating a transition from a liquid to a solid state. Thanks to these discoveries, we now know that Earth's core is composed of complex layers, and geologists have an advanced understanding of Earth's evolution. The connection between the Martian core and the magnetic field. Research on the structure of the Martian core revealed shocking connections between the planet's interior and the magnetosphere. Based on seismic data, the Martian core was found to have a liquid consistency throughout. In contrast, Earth's core consists of a solid inner core and a liquid outer core. The research suggests that the composition of the Martian core, particularly the presence of lighter elements, contributes to this phenomenon. While Earth has a strong magnetic field generated by geodynamo activity in the outer liquid core, Mars has a much weaker magnetic field. This relatively weak magnetic field of Mars has implications for the planet's ability to protect its atmosphere and minimize the harmful effects of charged particles from space. Earth is almost perfectly protected from the constant particle bombardment from the sun by its strong field, but Mars was hit with much greater harshness by solar winds over epochs. Unprotected, the particle streams from the sun were able to affect the outer atmosphere of Mars and even eroded over millions of years. Together with cosmic rays, the Martian atmosphere was so significantly depleted that the planet is now virtually unprotected. Mars's lower gravitational pull and lack of a sufficiently strong magnetic field has also allowed charged particles to penetrate the upper atmosphere and trigger chemical processes there. This led to the release of gas molecules, including lighter elements such as hydrogen and helium, into space. The changes in the atmosphere, in turn, had an impact on the surface of Mars. While liquid water may have existed on Mars in the past, it largely evaporated or escaped into space due to the loss of the atmosphere and protection from solar winds. Computer simulations show that erosion by particle flows very likely contributed to the formation of Mars's distinctive geologic features. Today, the surface of Mars is characterized by dusty and rocky expanses, dried-up riverbeds, and vast volcanic areas. In short, we could say that Mars slowly dried up, and if there ever was life on it, it disappeared with the water and with the increase in radiation. Our Earth, on the other hand, was able to support life to this day because of its robust magnetic field and dense atmosphere. Yet today, in the face of climate catastrophe, we naturally wonder if such a fate also awaits our planet. The parallels between the effects of solar winds on Mars and current changes on Earth are unmistakable. Our human activity has resulted in more and more greenhouse gases being released into the Earth's atmosphere. If nothing changes, we will destroy our atmosphere ourselves, and our homeland will also be more and more exposed to the influences of the sun and the cosmos. Already today, the fragile ecosystems and the general basis of life are threatened. The comparison with Mars shows how delicate planetary balances are and how important it is to protect the Earth and find sustainable solutions. So, far from just opening up a potential new home for humans, the exploration of Mars also serves to better understand what is going on our planet and what consequences we should expect. But let's move away from the dramas currently unfolding on our home planet and look further afield to Mars. Mars is not as lifeless as previously assumed. On the contrary, a force is currently awakening inside the planet that scientists do not yet really know what it means for the future of the planet. Unusual Mars quakes alarm scientists. During its 4-year active phase, InSight detected hundreds of Mars quakes. But it wasn't until 2021 that things got really interesting. That year, InSight documented 2 unusual quakes on the opposite side of the planet. One was a massive Mars quake, larger and more powerful than ever recorded before, while the other was the result of a meteorite impact. These events, on the opposite side of InSight, were a windfall for science. The lander was now able to analyze waves that not only traveled around Mars, but also passed through it, once again providing researchers with new data and details about the structure of the core. Exactly this data completed the picture in a way that we now know Mars has a liquid core. But the findings go much further. Thanks to the new data, scientists were able to analyze the elements inside in great detail for the first time. It turned out that the core of Mars has a high proportion of lighter elements. Large amounts of sulfur, followed by smaller amounts of oxygen, carbon, and hydrogen, make up nearly 1/5 of the planet's weight. Exploration of the interior of Mars continued to be exciting. On May 4th, 2022, InSight recorded the strongest Mars quake ever measured. The seismic shaking of the Martian subsurface reached magnitude 5 for the first time. A quake of this magnitude would also be clearly noticeable on Earth, but for Mars, this event is a true megaquake compared to all previous shaking. Strictly speaking, researchers did not even consider quakes of this magnitude possible on our planetary neighbor. Why Mars is now suddenly shaking with this strength is a mystery that scientists will continue to investigate. The activities in the interior and the flare-up of the quakes show that Mars is far from dead, even if it appears so at first glance. In fact, it's quite possible that the planet will continue to change as it evolves, possibly due to the influence of us humans as well. A revitalized world thanks to terraforming? Elon Musk, the visionary CEO of SpaceX, has the ambitious goal of making Mars a second Earth for humanity. Among the most fantastic plans of key technologies to make this goal possible is terraforming. Terraforming stands for a process by which the environmental conditions of a planet are altered to make them more Earth-like and thus habitable to humans. Musk's plans for terraforming on Mars include an artificial greenhouse effect that could be ushered in by 2 nuclear rockets detonated over the Martian poles. The carbon dioxide then released would, by pure calculation, create a greenhouse effect and raise temperatures on Mars. A warmer environment would release frozen water and further compress the atmosphere, which in turn could further drive temperatures. In addition to the nuclear option, Musk has proposed placing advanced solar sails or mirrors in orbit around Mars to direct more sunlight to the surface and accelerate warming. Terraforming, despite these already detailed prospects, is a complicated process that could take centuries and involves many unknowns. The latest findings about Mars's weak magnetic field and liquid core may now present more unexpected obstacles to Elon Musk's plans. Experts fear that despite all efforts, Mars would lose liquefied water so quickly that no significant atmosphere and climate with a closed water cycle can develop. But how do you see the current developments on Mars? Do you think goals like terraforming are feasible and even important for us humans? Or do you rather think we should leave Mars as it is and take care of our own planet?
Mars and Venus are our closest neighbors in the solar system. If Mars is in a particularly favorable position, it's only 55.6 million kilometers away from us on its elliptical orbit. Then we see it as bright red with the naked eye standing in the night sky. Astronomers observed strange processes on Mars as early as the 17th century. Due to the change in color and Earth-like surface structures, it was soon assumed that life existed on Mars. Mars is a rocky planet, just like the Earth, Venus, and Mercury. Only the outer planets that follow Mars are gas giants. With an equatorial diameter of 6,800 kilometers, Mars is only about half the size of Earth, which has a diameter of 12,800 kilometers. In terms of composition, Mars actually resembles Earth. However, the gases on Mars are currently distributed quite differently. The atmosphere of the red planet is very thin, and oxygen is only present in small amounts. The thin atmosphere allows a great deal of unfiltered cosmic radiation to reach Mars. Nevertheless, Mars has other amazing similarities to our planet. A Martian day is 24 hours, 39 minutes, and 35.244 seconds long, almost the same as an Earth day. On Mars, there are seasons in which the climate and the thickness of the poles change. However, the seasons on Mars last twice as long. This is simply because the Martian year is 687 days, almost twice as long as an Earth year. Mars therefore needs twice as long to complete its orbit around the Sun once. Space probes that have visited Mars. Only the Moon has been better explored than Mars. International space projects have already sent about 50 space probes to Mars. The first successful probes were Viking 1 and 2 of NASA. This double probe was launched in 1976. Viking 1 was successfully operated until 1982. Viking 2 transmitted data from Mars to Earth until 1980. The first Mars robot to land on the surface was the Mars Pathfinder in the 1990s. Most recently, the Mars Rover Opportunity from 2004 to 2019 and the Mars Rover Curiosity from 2004 to 2010 were on a research mission to our neighbor. First indications of life on Mars. Since Mars is very easy to observe when it is close to the Earth, the earliest astrologers noticed the Martian spots. Today, we know that these are seasonal changes in the environment of the Mars poles. When the sun warms the ice layers of the polar caps with the onset of spring on Mars, geysers of carbon dioxide and dark, coarse-grained dust are formed there. These clouds first shoot up into the sky and soon afterwards settle again on the surface of Mars. This results in altered spots and fan-like structures. When the telescopes were considerably improved in the 19th century, astronomers saw the phenomenon even more clearly. At that time, the color structures were thought to be signs of changing vegetation zones. In people's minds, the growing idea arose that life on Mars was Earth-like. In 1854, the astronomer William Whewell published theories according to which there were oceans, land, and possible life forms on Mars. In 1877, the Italian astronomer Giovanni Schiaparelli recognized the Martian troughs, or canali, Italian for trough. Schiaparelli assumed that these were structures formed by water. Due to a translation error, the gullies became the Martian channels. As a result, the idea of humans on Mars continued to grow among the population. Some people were also inspired by the idea of living on Mars. Others became afraid of so-called Martians. The hysteria increased when the British author H.G. Wells published the world bestseller The War of the Worlds in 1897. The story tells of an invasion of Martians invading the Earth. Since then, the beliefs and superstitions surrounding life on Mars and the Martians themselves have become engraved in our minds. Reconnaissance through space probes. About 80 years later, mankind was already able to send the first unknown space probes to Mars. Of course, the people on Earth were curious if any of the ideas about the living Mars would come true. Before that, scientists had already tried to establish radio contact with possible relatives on Mars. However, no answer ever came. Finally, in July 1976, the Viking 1 mission transmitted the first images from the orbit of Mars. Over the course of the exploration, the image of a dry desert planet became more apparent than a world full of water and life. However, the probe also sent pictures back to Earth, which provided food for thought. Highlight number 1 was the face of Mars. The rock structure in the Cydonia region of Mars actually resembled a human face. Other bizarre shapes that the orbiter was able to photograph were pyramids and rectangular structures that scientists compared to the appearance of an Inca city. The evidence of artificially created buildings and monuments on Mars was reason enough for NASA to send the Mars Global Surveyor to Mars for closer examination in 1996. Almost 2 years later came the big disillusionment for all ufologists and alien friends. The new high-resolution photographs showed the Mars face from different perspectives. It was clearly recognizable that the face is in reality a shapeless rock formation. Only the angle of the view and the incidence of light created the optical illusion of a face in the first images. The other phenomena could also be explained by similar effects and the consequences of natural erosion. Nevertheless, the Mars Global Surveyor was the first space probe ever sent into space to investigate extraterrestrial life. The search for the Martian continues. Although images such as the face of Mars have repeatedly proved to be optical illusions, ufologists never tire of trying to detect signs of aliens on Mars. The internet is full of images that also come from the newer space probes. Sometimes paraforcers claim to have recognized the bones of a giant on Mars, and from time to time, new Martians and Martian faces appear. Is there water on Mars? But let's get back to results from renowned science. The question of whether or not there is water on Mars occupied researchers, as did the question of clarifying the apparent structures. It seemed to be clear that the Martian atmosphere is too thin to allow surface water to form. The air pressure is too low, but it was suspected that water could exist in deeper layers of rock in the form of underground lakes or oceans. In 2010, a student accidentally found evidence of seasonally occurring trickles of liquid salt water in the Hale crater of Mars. Where this came from and why it only appears at certain times remains a mystery. It's possible that Mars pushes liquid from the interior upwards when its surface is heated. So, you could also say that Mars is sweating. Thanks to the European Mars mission Mars Express, the existence of liquid water on Mars could finally be proven in 2018. Using georadar, a lake of about 20 kilometers wide at the south pole of Mars was discovered. The liquid and probably salty water is hidden under a 0.5 kilometer thick layer of ice. Using the data provided by Mars Express, astronomers constructed a completely new picture of Mars's past. At least 3.6 billion years ago, the red planet is said to have had a warm and humid climate with numerous lakes and waterways. This could explain the leaching of the Martian troughs and other surface structures. Only later did the atmosphere disappear and Mars finally dried up. Indications of organic life. Already, Viking 1 delivered pictures in the 1970s that pointed to residues of organic structures. However, laboratory tests showed that such structures can also be produced purely chemically. Of course, it has long been clear that neither humanoid beings nor other more complex life forms can exist on Mars. Currently, researchers are looking for microorganisms, such as unicellular organisms, primitive algae, or bacteria. After all, these life forms once formed the basis for life we know today on Earth. New hope was provided by a rock from Mars. This reached the Earth in the form of a Mars meteorite. The rock with the name ALH 84001 was found in Antarctica in 1984. It was not until 1996 that U.S. researchers thought they had found traces of fossil bacteria on the boulder. Later, however, it could be proven that similar structures can also be created chemically. During its 6-year mission, the Mars rover Curiosity proved the existence of so-called thiophenes on Mars. These are complex organic hydrocarbons, which are almost always of organic origin, at least on Earth. On Earth, the ring-shaped compounds are found in coal tar and petroleum. Both are clearly degradation products of organic substances. A team from the Technical University of Berlin worked for years on researching possible pathways for the formation of thiophenes. To date, the researchers can still only make assumptions. The organic formation is admittedly more probable because it's much more frequent and easier. So the traces could really have been remnants of the earlier, more life-friendly conditions on Mars. However, a single chemical path of origin is also conceivable. Thiophenes are also formed when substances containing sulfate are heated to over 120 degrees. Another possibility would be the contamination of the Martian surface with thiophenes by a meteorite impact. So in the end, we can only proclaim again, we don't know anything specific. However, there is growing evidence that Mars may once have been an overgrown and inhabited planet. It is conceivable that several million years later, nothing more than rock, sand, and deserts have remained on the surface. If we look at the forecast for our Earth, scientists draw a very similar picture in the distant future. Apart from stones and desert, not much will be left of our former culture. Will we by then have moved to another planet? Who knows? If the sun has heated up the Earth so much that it becomes uninhabitable, Mars or another planet could be an alternative for us. While the exploration of the Martian surface has already revealed some breathtaking discoveries, the exact composition of the planet's interior has long been an unsolved mystery. Thanks to cutting-edge technology, NASA recently succeeded in getting one step closer to deciphering this galactic mystery. Equipped with a seismometer and a heat flow probe, the InSight lander has been investigating the deeper rock layers of the red planet for almost 3 years. InSight is not only intended to keep an eye on the current composition of Mars, but also to investigate the earliest development processes that gave the celestial body its characteristic shape. Just what information the InSight lander has already been able to provide in this regard, and what questions still need to be answered in the future, we'll reveal to you now. The InSight lander. In May 2014, NASA presented the public with its ambitious plans. At that time, the renowned space agency announced that it was working on building the InSight lander. This Mars mission was meant to answer a number of burning controversies that had been dividing experts into different camps for many years. The data transmitted by the technical equipment should not only help to fathom the nature of Mars, but also decipher the mysteries of all rocky planets of the solar system. That categorization of celestial bodies, to which our Earth also belongs, shares a common origin. Specifically, the origin of the planets is based on a process called accretion in the ranks of astronomers. During this process, a cosmic object collects matter by its gravity and the effects of tidal forces. As the terrestrial body grows in size, its interior begins to heat up. This process, in turn, is accompanied by a drastic reshaping, at the end of which a core, a mantle, and a crust are formed. The remaining rocky planets in our solar system, in contrast to the Earth, were reshaped later by a process called differentiation.
This process, which describes the formation of different materials from a once homogeneous mass, is still one of the great mysteries of modern research. Experts hope that InSight's in-depth investigation of Mars will provide new clues about the earliest evolutionary processes of such celestial bodies. After the originally planned launch was postponed by more than 2 years due to a leak in the seismometer, the time finally came on May 5, 2018. InSight left our blue home planet and set off for the fabled red planet. On November 26 of the same year, InSight touched down as planned on the surface of the celestial body, which is covered in iron oxide dust. In order to perform its work profitably, the lander was equipped with various measuring instruments. The so-called seismic experiment for interior structure is used to make precise seismic measurements on the red planet. By investigating such activities, important insights into the history of the planet can also be gained. The heat flow and physical properties package instrument serve the purpose of determining the heat flow in the Martian sediment. A 15-inch long and approximately 2-inch thick RAM probe was used for this purpose. In the run-up to the mission, the Warsaw-built device had the goal of penetrating about 16 feet into the Martian soil. The plan was for the RAM probe to stop about every 2.5 feet in order to then carry out special heat measurements. This was to be done by calling up a preset heat output in each case. With the aid of the temperature sensors located on the head of the probe, the heating of the drill head and the rate at which the heat was spreading would then be measured. In the course of this procedure, the experts hoped to learn more about the physical properties of the Martian soil. However, the deployment of the equipment was not to be. In the spring of 2019, the RAM probe got stuck in the ground at a depth of about 1 foot. In fact, the friction between the heat flow probe and the Martian soil was much lower than the scientists had expected. After the RAM probe was freed by a robotic arm and able to resume its task, it was not long before the next problems arose. The instrument had once again become wedged in the ground. However, since this time it was not possible to free the RAM probe from its awkward position, the earthly scientists had no choice but to end the experiment at the beginning of the year 2021. However, this doesn't mean that the InSight mission has been a failure. In truth, the seismometer has already provided some important information that gives us a previously unknown insight into the interior of the celestial body. The interior of the red planet. Thanks to the successful InSight mission, terrestrial scientists were privileged to record another galactic milestone. With its complex measuring instruments, the lander succeeded in registering more than 700 Mars quakes. With the help of the recorded data, researchers managed to make the first direct measurement of an alien planet's interior. Although more in-depth research is needed in the future to fully understand the tectonic makeup of the red planet, the information gathered so far provides important clues as to what lies beneath the red, rust-covered surface of Mars. On the one hand, the knowledge gathered in this regard helps us to better understand the current structure of the red planet. In addition, this information can also be used to reconstruct how the celestial body was formed in the past. The seismological measurements carried out at the landing site of the InSight lander made it possible for the first time to constrain the thickness of the Martian crust in the corresponding region. Furthermore, taking gravity and topography into account, it's even possible to map the crust thickness of the entire celestial body. Since experts have been waiting for several decades to unravel this cosmic mystery, the successful completion of this endeavor was tantamount to a galactic blockbuster. The data that InSight has so far transmitted to terrestrial scientists supports two different models. On the one hand, it's conceivable that the Martian crust is relatively thin and composed of two layers. The higher, porous layer may have been chemically altered over the millennia. According to researchers, however, the underlying layer is likely to still have its almost unchanged original composition. In contrast to this is the thesis that the crust of the red planet is not composed of two, but rather 3 layers. If the first case is correct, the top layer would have a thickness of about 12 miles. This would make it much thinner than the experts had expected. If the Martian crust has 3 layers, the first layer would be twice as thick. The planetary core. Currently, researchers assume that the planet's entire crust is between 15 and 45 miles thick. In addition, Some evidence suggests that Mars' natural shell is enriched with radioactive elements. These would strongly heat the crust layers at the expense of the planet's interior. Another interesting fact is that Mars has an extremely thick lithosphere. This outermost crustal layer is about twice as thick as the lithosphere of our blue home planet. This natural composition could ultimately explain why there have been no plate tectonic processes on Mars. If we go further into the interior of the celestial body, we come across the mantle. This structure, which encloses the planet's core, consists of silicates and is composed of a single layer. The core of the red planet is apparently much larger than the experts predicted. For example, the data collected by InSight brought the realization that the heart of Mars has a radius of about 1,100 miles. In addition, the information also confirmed a thesis that had long been considered probable among scientists. The Martian core is liquid. Furthermore, the information obtained indicates that the chemical composition of the innermost region of the planet holds some surprises. Since the corresponding areas are less massive than expected, it's reasonable to conclude that lighter elements are also present within the molten nickel and iron, which ultimately reduce the density. On the basis of these circumstances, insightful conclusions can be drawn about the development of the planet itself. For example, so that the red planet could accumulate the appropriate light elements, for example hydrogen, oxygen, carbon, and sulfur in its core, it must have formed very early on. It's possible that Mars was already formed when the solar nebula still existed, the interstellar molecular cloud from which our solar system ultimately formed. Consequently, Mars was possibly formed much earlier than our blue home planet. However, the important findings already recorded during the InSight mission are only the prelude to an even more detailed investigation of the planet's interior. One of the tasks that the lander will have to complete by the end of its mission in December 2022 is to answer an overriding question. What is the cause of the numerous Mars quakes that have been recorded in the Cerberus fossae trenches? In order to plumb this topic, experts hope that further quakes will occur on the red planet in the future, which will be different from the previous ones. The hope of the scientists lies not least in an increased intensity of tremors. The Mars quakes registered so far were so weak that we would probably not even have felt them on Earth. Stronger quakes and the accompanying measurement of the seismic waves would help the researchers to fathom the interior of our galactic neighbor even more comprehensively.
The InSight Mars lander touched the surface of Mars for the first time on November 26, 2018. In the course of the nearly 4-year mission, NASA finally discovered what scientists had been looking for on Mars for so long. But what is it that researchers have wanted to know about Mars for so long? And what will this discovery change now? Are you curious? Then follow us now on this journey to the last secrets of the red planet. InSight's launch to a mission of the century. Mars probes and rovers have been many in the history of planetary exploration to date, but InSight was different. The unusual lander was designed and equipped like no probe before it. Scientists involved in the project eagerly watched the launch of the Atlas V rocket that would carry InSight into space. On May 5, 2018, the time had come, and the spacecraft lifted off from the Vandenberg Air Force Base and set out on its journey. At NASA, the launch of the mission was viewed with mixed emotions. At that point, more than half of the planned Mars missions had failed. Either they had never launched, or they had failed when they arrived on Mars. Millions were lost as a result, and no one knew what InSight's fate would be. InSight also began with a problem. A previous launch attempt was delayed for several months due to a vacuum leak in the size instrument. But all went well. In Earth orbit, InSight slowly detached from the rocket stages and then floated freely in space. The lander was in space for 6.5 months. The technical device covered 484 million kilometers until it entered the thin atmosphere of Mars, 125 kilometers above the surface on November 26, 2018. The probe, which weighed just 700 kilograms, hurtled through the atmosphere at almost 20,000 kilometers per hour, having to withstand temperatures of around 1,500 degrees Celsius.
To ensure that the fine measuring instruments on board the probe and all the other expensive gimmicks could withstand this extreme stress, InSight was securely packed in a kind of protective cover. The probe covered the last few meters hanging from a parachute, and its own small rocket engines provided the necessary counter-thrust to let the probe land safely and softly on the Martian soil. As soon as it arrived, InSight began deploying its solar panels and taking initial measurements. Thus began some 4 years of exciting Mars exploration. Past Mars missions. InSight was the first high-power seismic measurement station on Mars. NASA had previously sent 2 other main missions to Mars equipped with seismometers. However, the technology of Viking 1 and Viking 2, which were launched in the 1970s, cannot be compared to the technical capabilities of InSight. Moreover, the Viking missions were quite a bust. The seismometer of Viking 1 did not work properly during the landing and could not be used at all. Viking 2 was able to take measurements, but the instruments were so poorly calibrated after landing that it has always remained unclear whether the probe's measurements were due to seismic activity or wind. InSight's mission and challenges. InSight was intended to make up for this failure of the Viking missions after many years. The probe's main objective was clearly to survey and explore the interior of Mars. For this purpose, the lander, which was about 1 meter high and 6 meters long, was equipped with a seismometer, a windscreen, and a highly mobile robotic arm. The necessary power was provided by the 2 solar panels that gave this probe its distinctive appearance. In addition to the seismic instruments, InSight had a complete small weather station on board and a robotic arm called the Mole, which the probe would use to dig deep into the Martian soil to take temperature measurements in the upper layers of rock. First data fascinated. Even during the landing approach, and with the solar panels still folded in, InSight began collecting data. At NASA, scientists and technicians alike were beside themselves. The lander picked up vibrations from Martian winds and, for the first time, filmed clouds of water ice passing directly overhead. Tapes of the sound of Mars have been thrilling millions of people on the web since the mission launch. The secret of seismic activity. Seismic signals are any vibrations or intrinsic sounds that a planet experiences or produces. Like Earth, Mars is not silent inside. Or at least we know that now, and thanks to InSight. Before, it was not so clear to scientists just how alive and active Mars still is inside. Today, the planet appears to be a desolate, rocky world with stunning rock formations, sweeping mountains and deep canyons, but traces of life or vegetation are completely absent, as is evidence of liquid water. There are several references to dried-up lakes and even entire oceans and river courses. But where has all the water gone if Mars was once a mild water world? In addition to monitoring seismic activity such as Mars quakes, InSight was designed to scan the interior of Mars. Over the months, a perfect map of the Martian interior emerged thanks to the recording of internal waves. On these interior maps, researchers hoped there should also be evidence of underground lakes or water deposits. But first, the scientists' main interest was the activity of the Martian quakes. InSight has recorded about 450 seismic tremors. These Mars quakes are usually very fine and uniform. The strongest of them have magnitudes of 4.0 to 5.0, although the vast majority of quakes stayed well below that. The sound of Mars's interior was surprising, as researchers detected tremors with a repetition frequency similar to the human heartbeat. It almost seemed as if Mars was more alive inside than scientists had previously thought. Each of these tremors also tells a unique story about Mars's geological activity and its ongoing evolution. As the fine waves travel through the Martian subsurface, they encounter different layers of rock, cavities, and strata within. Each of these layers interacts with the quake waves through its own vibrational patterns. Based on the changes that the frequency patterns undergo as they travel through the planet, researchers can find out details about the planet's internal composition and makeup. Lucky meteorite impact. The questions scientists have long sought answers to were whether Mars still has an active core in its interior, and why it evolved to become dust-dry and desolate today. By a lucky coincidence, both of these questions were answered. On the other side of Mars, a meteorite had hit and had caused vibrations, which went at once across the planet. These waves measured Mars virtually once in its entire cross-section, and thus finally provided scientists with the answer to the question of the core. Researchers were able to perceive for the first time that Mars does indeed have an active core. The surprise was that this core, which is about 1,830 kilometers wide, must be liquid throughout. Our Earth has a core of nearly solid iron, surrounded by liquid materials and a crust, creating an optimal, stable magnetic field that protects us from influences from the cosmos. Mars's weak magnetic field was almost certainly responsible for leaving the planet almost defenseless against the bombardment of solar particles and cosmic rays. The magnetic field specifically protects us from radiation from the sun. The magnetic field lines catch the myriads of particles that hit our planet daily from the sun and guide them along their course lines into a kind of protective bag. On Mars, this protection may never have been as well developed as it is here. Solar winds and radiation from space hit our neighboring planet much harder. The atmosphere probably became thinner and thinner, water escaped into space, retreated underground, or froze. If Mars really once was a world similar to Earth, it became desolate because of the lack of protection. In the course of the InSight mission, evidence actually also grew that Mars really was once a world with water, a mild climate, and perhaps plants or simple living things. Deep beneath the dusty surface of Mars, the Mars lander found evidence to support these theories. Measurements there showed another magnetic field 10 times stronger than scientists had previously thought. This ancient magnetic field, trapped in the rocks of Mars, provided evidence of a time when Mars had a denser atmosphere and possibly liquid water on its surface. The Song of Mars. While InSight was unraveling the seismic mysteries of Mars, the spacecraft encountered another unexpected sound inside. The mysterious hum that sounded almost like a ditty. After the heartbeats of Mars and the gentle whistling of the wind, it was now almost as if Mars was casually humming away. Astrogeologists describe this humming like a melody of Mars waiting to be understood by us. Compared to the barren and rocky surface, which has so far held few surprises except for endless landscapes and lots of rock, the sounds of the planet are a veritable treasure chest of new discoveries. No plates, but a crust. During its 4-year observing period, InSight's seismic experiment for interior structure surveyed nearly the entire interior of Mars. Like X-rays, the seismic waves ran through the planet and revealed, among other things, that Mars has no continental plates like Earth. Rather, the surface appears to resemble a single solid crust. Planetary scientists had long suspected this, and thanks to InSight, confirmation finally came. The crust turned out to be much thinner than expected, but regionally, it has 2 or even 3 sublayers. The thickness of the simple crust is usually around 20 kilometers. Where there are 2 or 3 sublayers, it is up to 37 kilometers thick. In addition to all these discoveries, InSight has studied Mars's volatile atmosphere, recorded hurricanes and real tornadoes, and collected thousands of data on wind speed and direction. Thanks to this information, scientists now have a comprehensive picture of the weather and climate on Mars. This data will, of course, be of paramount importance in preparing manned missions to Mars. Dwellings for humans, who will one day study Mars on the ground, must be optimally adapted to the weather conditions. No human being can survive on the planet for long outside a protected shelter. The harsh Martian climate was also felt by InSight. After surviving numerous sandstorms, so many deposits had formed that the solar panels were increasingly failing. After 4 successful mission years, the end came for InSight. The power supply was simply no longer sufficient. In December 2022, NASA announced the official end of the mission. What do you have to say? Despite its demise by sand, do you consider this probe a full success? And what do you think about Mars and its past now? Do you think the planet was once similar to Earth?
For as long as mankind has been observing the heavens, We have been fascinated by the possibility that other worlds, much like Earth, might contain living organisms. While our visits to the moon have taught us that it is completely barren and uninhabited, other planets in our solar system show much potential. Venus, for example, could harbor life in its cloud layer. Europa and Enceladus could be teeming with life in a subsurface ocean of liquid water. Even Titan's liquid hydrocarbon lakes are a fascinating place to search for exotic microbes. Life on the red planet? By far, the most intriguing possibility is the red planet, Mars. This smaller, colder, and more distant cousin of Earth certainly had a humid past, with liquid water flowing on its surface for more than 1 billion years. Various lines of evidence point to the plausibility of life on Mars, not only in the prehistoric past, but possibly today as well. With the information we have received from various orbiters, landers, and rovers, we have made a number of fascinating discoveries on Mars. We see dried riverbeds and evidence of ancient glaciers on the Martian surface. Tiny hematite spheres have been found on Mars, as well as ample evidence of sedimentary rocks that form on Earth only in watery environments. In addition, the Mars rover has observed solid subsurface ice, snow, and even frozen surface water on Mars in real time. It has even been shown that saline surface water is likely actively flowing down the walls of craters, although this finding is still highly controversial. All the factors necessary for life on Earth were also abundant on early Mars, including a dense atmosphere and liquid water on its surface. Although Mars does not look like it is teeming with life today, there are 3 pieces of evidence that earlier, or even present-day life may be possible and cannot be dismissed out of hand. Evidence number 1. The first convincing evidence came from instruments aboard NASA's Viking lander in 1976, which conducted 3 biological experiments: a gas exchange experiment, a labeled release experiment, and a pyrolytic release experiment, followed by a gas chromatograph mass spectrometer experiment. The labeled release experiment returned a positive result when performed on both Viking landers, but only the first time. All other experiments came back negative. The test results imply that Mars had an atmosphere similar to Earth. Evidence number 2. The second piece of evidence came when a fragment of a Martian meteorite, Allen Hills 84001, was recovered on December 27, 1984. As it turned out, about 3% of all meteorites that fall to Earth come from Mars. But this one was particularly large, weighing almost 4 pounds. It originally formed on Mars about 4 billion years ago and landed on Earth only about 13,000 years ago. A 1996 look inside revealed material that could be the remains of fossilized organic life forms, although they could also have been formed by inorganic processes. Evidence number 3. Finally, the third piece of evidence was provided by NASA's newest Mars rover, Curiosity. As the seasons changed on Mars, Curiosity detected burps of methane emanating from specific subsurface locations, but only at the end of the Martian winter and with the onset of the Martian spring. Again, this is an ambiguous signal at best, as inorganic geochemical processes could be seasonal and lead to the release of methane. But organic, biological processes could also cause this. 5 possibilities for life on Mars. If we look at all the evidence, there are 5 possibilities for the history of life on the red planet. Mars could have always been a barren world, or it could have been a world where life thrived for a time and then became extinct. Another possibility is that life could still exist on it even today, which would be truly stunning news for all of humanity. The following scenarios are quite possible. 1. There never was life on Mars. Although it has the same raw materials as early Earth and similar water conditions, the necessary circumstances to allow life to form simply never occurred on Mars. all the geological and chemical processes that occur inorganically did take place, but no organic activity. Then, a little over 3 billion years ago, the Martian atmosphere was stripped by the sun, drying up any liquid surface water and leading to the present appearance of Mars. This is the most conservative viewpoint and would require that all 3 alleged positive tests have either inorganic or impurity-based resolution. This is entirely possible and remains, in the minds of many, the default assumption. Until very convincing evidence emerges that clearly points to past or present life on Mars, this is likely to remain the leading hypothesis. But seasonally frozen lakes do appear everywhere on Mars, indicating a water-rich past. 2. There was early life on Mars, but it died out. In many ways, this scenario is just as possible as the previous one. It's very easy to imagine that a world with a dense atmosphere similar to early Earth, with stable liquid water on its surface, continents rich in geological diversity, volcanoes, a magnetic field, a day similar in length to ours, and temperatures only slightly cooler than those of today's Earth, could lead to the flourishing of life. However, the loss of Mars's atmosphere had profound effects on the planet and may have led to the extinction of all life on Mars. Drilling into the sedimentary rocks of Mars and searching for fossilized life forms, or even metamorphosed carbon-rich inclusions, could potentially provide the evidence necessary to confirm this scenario. 3. Mars harbored early life, and it still persists in a mostly dormant form beneath the surface. This is the most optimistic, but still scientifically defensible, view of life on Mars. Perhaps there was life early on, and when Mars lost its atmosphere, a few extremophiles remained in a kind of frozen limbo. If the right conditions emerged, perhaps underground, where liquid water can flow, that life could reawaken and resume its critical biological functions. If that is the case, then there are still organisms beneath the Martian surface, perhaps in the shallow sand just a few feet or even inches below the Mars rover. It's likely to be only single-celled life, perhaps not even reaching the complexity of a eukaryotic cell, but life on a world other than Earth would still be a revolution for science. NASA's Perseverance rover, successfully launched on July 30th, 2020, will collect important soil samples to test this hypothetical scenario. 4. There was no life on Mars until pieces of the Earth hit it. 65 million years ago, a very large, fast-moving body slammed into Earth, creating the Chicxulub crater and throwing up enough material to envelop the planet in a cloud of debris, resulting in the 5th major mass extinction in Earth's history. And as with many massive impacts, this one likely sent small pieces of the Earth into space, just as impacts on the Moon or Mars sent meteorites through the solar system, some of which eventually landed on Earth. The impacts sent material from Earth to other worlds, including Mars. It's extremely plausible that organisms from Earth got to Mars and began to reproduce, whether they thrived or not. Perhaps someday we will be able to explore the entire history of life on Mars and find out if possible life on Mars is descended from existing life on Earth. This is an intriguing possibility that cannot be easily dismissed. 5. Our modern space program spread Earth-based life to Mars. After all, Mars was a barren, lifeless planet for a long time, at least for billions of years, until the dawn of the space age. Eventually, material from space that was not 100% decontaminated or sterilized landed on the Martian surface, bringing with it modern terrestrial organisms in the form of stowaways.
There is a region on Mars, roughly the size of Australia, that rises high above the surface of the planet. 3 of the largest volcanoes in the solar system line up to guard its western flank. To the east, a vast canyon, 6 to 7 times deeper than the Grand Canyon, cuts into the barren Martian plain. This strange region, once so baffling to scientists, recalls the planet's violent past. A time long ago when the planet's core erupted, pushing molten rock to the surface. It's part of a larger story, a planetary tragedy, in which Mars began its descent into the cold, dry, and lifeless state that we see today. We are now scouring its surprisingly complex surface for clues to the events that long ago doomed the red planet Mars. Since the early 1960s, we've tried 46 times to send spacecraft to Mars. Across the 55 million kilometers of its closest approach to Earth. Over half failed at launch or upon arrival. The rest flew around the planet, snapping pictures, recording data. Or they landed to test its soil and rocks, and crawl around its canyons and craters. These probes may one day pave the way for human explorers, who will dig deeper still in search of answers to our most pressing question. Did Mars, at some point long ago, develop far enough for life to arise? If so, does anything still live within Mars' dusty plains, beneath its ice caps, or somewhere underground? Mars does not give up its secrets easily. Over the years, that has led observers on this planet to jump to all sorts of conclusions. In the year 1877, the Italian astronomer Giovanni Schiaparelli noted markings on Mars' surface, a latticework of lines. He called them canali in Italian, meaning channels in English. Schiaparelli began to sketch them and name them, connecting them in a vast global network. Over a 15-year period, beginning in 1894, the American astronomer Percival Lowell closely examined these features. He saw a remarkable drama unfolding on our neighboring planet. In his view, Schiaparelli's channels were artificial canals, designed perhaps to carry melting snow from the poles to the dry interior. After all, on Earth, the Suez Canal had been open since 1869. Construction on the Panama Canal had just gotten underway. The Martian canals, Lowell surmised, had been built by a sophisticated society confronting an environmental catastrophe on the grandest of scales. Its inhabitants faced an urgent choice: move water across vast arid regions, or perish on an increasingly dry planet. In a series of 3 best-selling books, Lowell took his case to the public. The public responded, with some ideas of their own. With the means to remake an entire planet, perhaps these Martians were more advanced than humans. Some of us began offering schemes for making contact. Giant mirrors to flash greetings. Light beams. Mental telepathy. Lowell's vision fell by the wayside in 1964. The Mariner 4 spacecraft flew by Mars and got a good look. What it saw looked more like the Moon than the Earth. 3 more Mariners followed. These missions documented a heavily cratered landscape, pocked with huge dormant volcanoes, and cut with the deepest and longest canyon in the solar system. They saw no traces of life, present or past. Then, in the mid-1970s, 2 lander-orbiter robot teams, named Viking, went in for an even closer look. The landers tested the soil for the chemical residues of life. All the evidence from Viking told us Mars is dead and extremely harsh. The mission recorded Martian surface temperatures from minus 17 degrees Celsius down to minus 107. We now know it can get even colder than that at the poles. The atmosphere is 95% carbon dioxide, with only traces of oxygen. And it's extremely thin, with less than 1% of the surface pressure of Earth's atmosphere. And it's bone dry. In fact, the Sahara Desert is a rainforest compared to Mars, where water vapor is a trace gas in the atmosphere. On Earth, impact craters erode over time from wind and water, and even volcanic activity. On Mars, they can linger for billions of years. Earth's surface is shaped and reshaped by the horizontal movement of plates that make up its crust, driven by heat welling up from the planet's hot interior. At half the width and only 11% the mass of Earth, Mars doesn't generate enough heat to support wide-scale plate tectonics. Nor does it have the gravity to hold a thick atmosphere needed to store enough heat at the surface to allow liquid water to flow. Nonetheless, some areas that looked to Viking-era scientists like craters and volcanic areas were later shown to be riverbeds, lake bottoms, and ocean shorelines. If water once flowed on Mars' surface, where did it all go? This was the scene at NASA's Jet Propulsion Lab in 2004. The twin rovers Spirit and Opportunity had just bounced down on the red planet. When the excitement died down, the rovers were set off on one of the most remarkable journeys in the history of planetary exploration. Opportunity had come to rest in a small crater near the equator, at a spot called Meridiani Planum. Here in plain view, on a nearby crater wall, its camera revealed exposed bedrock, the first ever seen on Mars. Not far away, the rover found layered rocks on the face of a cliff. On Earth, they typically form as sedimentary layers at the bottom of oceans. And at every turn, Opportunity rolled across tiny, smooth, round pellets. They became known as blueberries because they appeared purplish-brown against Mars' rust-colored surface. Initially thought to be volcanic in origin, they turned out to be iron-rich spherules of the type that form within cavities in the mud at the bottom of an ocean. Drilling into rocks, the rover inserted a spectrometer to read the mineral content. The readings showed significant amounts of sulfate salt, a tracer for standing water. That wasn't all. Spirit's broken wheel dragging behind it exposed soils saturated in salt. Clearly, there was once water on Mars' surface. But how long ago? And if there's anything left, where would you find it? One possible answer: the North Pole. From orbit, this region seemed to be covered in frozen CO2, what we call dry ice. But was there water ice below the surface? Enter Phoenix, a lander that touched down near the North Pole in early 2008. Radar readings from orbit, taken by the Mars Express mission, hinted at the presence of ice just below the surface. The Phoenix lander's descent thrusters blew away the top layer of soil, allowing its camera to snap pictures of what looked like ice. Scientists instructed the robot to conduct a simple experiment. Reach out and dig a trench. Then watch what happens. As expected, clumps of white stuff appeared. A couple of days later, it was gone, vaporized. That means it can't be salt or frozen CO2, which is stable in the cold, dry temperatures of the Martian pole. So it had to be water, the first ever directly seen on Mars. There are indications that the North Pole was actually warm enough in the recent past for water ice to become liquid. The Mars Reconnaissance Orbiter, or MRO, used radar pulses to peer beneath the surface of the ice cap. These data revealed that the ice, just over a mile thick, formed in a succession of layers as the climate alternated between warm and cold. Our planet avoids mood swings like this, in part because its spin is stabilized by a massive moon. Mars' spin is not, so it can really wobble, with the pole tilting toward the sun for long periods. New observations by the MRO spacecraft show that these wobbles can lead to dramatic releases of CO2 and warming periods due to an increase in the greenhouse effect. The ice now detected below Mars' surface is a remnant of a much earlier time. The thinking is that not long after its birth, the planet's molten interior would have spewed out enough gas to form an atmosphere. Carbon dioxide and water vapor began to trap heat from sunlight. Temperatures rose high enough to allow liquid water to flow on the surface, creating myriad rivers, ponds, lakes, and oceans. Evidence of this thicker atmosphere landed literally in Opportunity's backyard. The rover spied a strange bluish rock, a nickel-iron meteorite named Block Island. Streaking through a thin atmosphere, this massive chunk of metal should have been obliterated on contact. Instead, its fall was likely slowed and its impact softened by a much thicker atmosphere. What then caused the atmosphere and the water to disappear, and the planet to grow cold and dry? The answer comes from data recorded by the Mars Global Surveyor just after it went into orbit in 1997. Its instruments detected the presence of a weak magnetic field emanating from the planet, a reading that scientists eagerly compared to that of Earth. Our planet's magnetic field is generated by molten rock deep in its core that rises and falls into a vast region below the outer crust called the mantle. The rising and sinking motion within, combined with the spinning motion of the planet, generates a strong magnetic field. You can trace this field back to Earth's early years, when large amounts of heavy elements such as iron sank into its core. Radioactive decay began to generate heat, and the planet's mass is large enough to hold it in. Earth's magnetic field extends far enough out into space to deflect the wind of high-energy solar particles. Without a similar electromagnetic deflector shield on Mars, solar radiation lashed the planet, gradually stripping it of its atmosphere. What water Mars had would have vaporized into space, or frozen underground. However, there is evidence that at one time, Mars did have a robust magnetic field. Rocks in some of the older craters bear a strong imprint of this field, while newer craters indicate a much weaker field. What happened to it? The answer lies deep in Mars' past. in events so powerful they are still written on the landscape. This is a simple elevation map of Mars' surface from data gathered by the Mars Odyssey spacecraft. The South Pole, colored in red and orange, is piled high with ice. Moving off these southern highlands, we make our way north. The landscape is pocked with craters. The largest and oldest ones have faded, their edges softened by wind-blown dust. Moving up along the equator, we pass into a region called Tharsis, based on a biblical name for the western edge of the known world. On the edge of this vast high-altitude plateau is a series of enormous volcanoes. Ascraeus Mons, 18 kilometers high. Arsia Mons, 16 kilometers. Pavonis Mons, 14 kilometers. Just beyond is the largest volcano in our solar system, Olympus Mons, 25 kilometers in elevation. The thinking is that the Tharsis region bulged out when a giant dome of magma pushed up from the planet's core. The volcanoes grew large because Mars lacks the constant shifting of crustal plates that on Earth leads to chains of smaller volcanoes, like the Hawaiian Islands. Just to the east is the great Valles Marineris, named for the Mariner 9 mission that found this vast gash in the Martian landscape. It's about 4,000 kilometers long and up to 200 kilometers wide. On Earth, Valles Marineris would stretch from Los Angeles all the way to the Atlantic coast. If you went to Valles Marineris, you'd see dust devils sweeping along the plains above it, and dust blowing up the canyon walls. Here's a realistic rendering of data captured by spacecraft. Giant landslides have caused the walls to slump off and pile onto the valley floor. Feeding into the valley, a maze of side channels. Scientists think these and other tributary features were formed when underground water flowed into the main basin and the land above collapsed. Wider parts of the canyon are regarded as possible landing sites for a manned mission. They offer flat surfaces and possible access to liquid water that may remain below the surface. The theory is that Valles Marineris formed when the planet began to cool. Its sides were pulled apart as the Tharsis Plateau just to the west began to rise up. That chain of events is now being linked to a much larger planetary event. What one scientist called the defining moment in Mars history. Travel north down the slopes of Mars' great volcanoes. The elevation drops as we move across what appears to be an immense ocean, colored here in blue. With this so-called Borealis Basin in the north and the high elevations of the south, Mars is a lopsided planet. In fact, there is a difference of about 30 kilometers in the thickness of the crust in these two regions. Here's the reason. Early on, when the solar system was young, Mars was hit by at least 15 large asteroids. Scientists have linked these events to a time around 3.9 billion years ago, known as the Late Heavy Bombardment, when rock samples from the Apollo landings show that our own moon was seriously pummeled. One theory holds that these impacts heated the outer subsurface layer of the planet, Mars' mantle. That prevented molten rock in its core from rising up and caused the crust to thicken. This had the effect of shutting off Mars' magnetic field, exposing the planet to damaging solar winds, and over time, turning it into a wasteland. There are other theories that explain the disappearance of Mars' magnetic field and its atmosphere. What's certain is that at some point early in its history, the red planet grew increasingly desolate. The Martian landscape we see today is replete with coded signals from these early times. Ancient riverbeds and lake bottoms, floodplains, and volcanic cones, as well as the battering it received from impacts. But is Mars a dead world? Maybe, maybe not. An infrared telescope on Hawaii's Mauna Kea volcano was trained on Mars over several years. Astronomers used a spectrometer to split the light into its individual wavelengths to identify chemical fingerprints in the atmosphere. They found the signature of methane gas in amounts that change from place to place. Because methane should disappear quickly in Mars' atmosphere, there must be some source that constantly replenishes it. That source could amount to nothing more than the chemical reactions in Mars' crust. Or it could be biological in nature, perhaps microbes alive and well in heated pools underground. So far, neither the satellites flying over Mars nor the robots on the ground have turned up anything close to clear proof of life. It may take the searching eyes, flexible minds, and nimble fingers of human explorers to find that buried treasure, if it exists. In the meantime, we are finding that even if Mars is dead, it's certainly not dull. Mars has nowhere near the dynamism of Earth. With its oceans, atmosphere, volcanism, and shifting continents. But it does do some fascinating things. If you take an atmosphere, however tenuous, add heat from the sun, you get the renowned dust devils of Mars. With no trees to hold the soil down, landslides are common. The Mars Reconnaissance Orbiter has returned images showing that Mars is actively remaking its surface. Not in canals built by the Martian engineers of Percival Lowell's imagination, but in sand dunes shaped by the wind, and in landscapes molded by a gradually changing climate. Some scientists have even turned up hints of low-level plate tectonics. Whether or not we ever find life forms on Mars, we can still marvel at the beauty of our neighboring planet. Its surface subtly sculpted over eons of time. On a world that never was.
But God evolved into something more to him than a vengeful deity needing appeasement. Kepler conceived God as the cosmic force responsible for its creation. The young boy overcame his anxiety by embracing his natural curiosity. He dared to ponder God's thoughts and wanted to learn more about the eschatology of the world. These terrifying visions, which at first only existed as memories, eventually became a lifelong obsession for the person. The egotistical goals of a young student at a seminary were to lead Europe away from the intellectual cloister of the Middle Ages. It had been more than 1,000 years since the sciences of classical antiquity were last practiced. But in the late Middle Ages, some faint echoes of those voices, which had been preserved by Arab scholars, began to make their way into the educational curriculum of Europe. While he was in Malbronn, Kepler was able to hear their reverberations while studying, among other things, theology, Greek, Latin, music, and mathematics. He believed he had seen an image of perfection and cosmic glory in Euclid's geometry. In later writings, he stated, "Geometry existed before the creation." Geometry is co-eternal with the mind of God. The model for creation that God used was provided by geometry. The essence of God can be found in geometry. Amid Kepler's mathematical raptures, and even though he lived a sequestered life, the imperfections of the outside world must also have molded his character. Superstition was a widely available nostrum for people powerless against the miseries of famine, pestilence, and deadly doctrinal conflict. For many, the only certainty was the stars, and the ancient astrological conceit prospered in the courtyards and taverns. In 1589, Kepler left Malbronn to study for the clergy at the great university in Tübingen, and found it a liberation. Confronted by the most vital intellectual currents of the time, his teachers immediately recognized his genius. One of his teachers introduced the young man to the dangerous mysteries of the Copernican hypothesis. A heliocentric universe resonated with Kepler's religious sense, and he embraced it with fervor. The sun was a metaphor for God. Kepler was a brilliant thinker and a lucid writer, but he was a disaster as a classroom teacher. He mumbled, he digressed. He was, at times, utterly incomprehensible. He drew only a handful of students his first year at Graz. The next year, there were none. He was distracted by an incessant interior clamor of associations and speculations vying for his attention. Only 6 planets were known in Kepler's time: Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Kepler wondered why only 6? Why not 20 or 100? Why did they have the spacing between their orbits that Copernicus had deduced? No one had ever asked such questions before. There were known to be 5 regular or platonic solids whose sides were regular polygons, as known to the ancient Greek mathematicians after the time of Pythagoras. Kepler thought the two numbers were connected, that there were only 6 planets because there were only 5 regular solids, and that these solids, inscribed or nested one within another, would specify the distances of the planets from the Sun. In these perfect forms, he believed he had recognized the invisible supporting structures for the spheres of the 6 planets. He called his revelation the cosmic mystery. The connection between the solids of Pythagoras and the disposition of the planets could admit only one explanation: the hand of God, the geometer. Kepler was astonished that he, a sinner according to his own perceptions, should have been divinely chosen to make such a significant discovery. In his proposal for a research grant to the Duke of Württemberg, he offered to supervise the construction of his nested solids as a 3-dimensional model so that others could see the beauty of the holy geometry. He did this so that others could see the beauty of the holy geometry. He said it was possibly crafted from silver and precious stones and functioning as a ducal chalice. The proposal was rejected with the kindly advice that he first construct a less expensive version out of paper, which he promptly attempted to do. The intense pleasure I have received from this discovery can never be told in words. I shunned any calculation, no matter how difficult. Days and nights I spent in mathematical labors until I could see whether my hypothesis would agree with the orbits of Copernicus, or whether my joy was to vanish into thin air. But no matter how hard he tried, the solid elegance and grandeur of the theory persuaded him that the observations must be in error, a conclusion drawn when the observations are unobliging by many other theorists in the history of science. There was then only one man in the world who had access to more accurate observations of apparent planetary positions, a self-exiled Danish nobleman who had accepted the post of imperial mathematician in the court of the Holy Roman Emperor, Rudolf II. That man was Tycho Brahe. By chance, at Rudolf's suggestion, he had just invited Kepler, whose mathematical fame was growing, to join him in Prague. The local Catholic archduke, steadfast in dogmatic certainty, vowed to make a desert of the country than rule over heretics. Protestants were excluded from economic and political power. Kepler's school was burned down. In 1598, one of the many premonitory tremors of the coming 30 Years' War engulfed him. Kepler was a provincial schoolteacher of humble origins and unknown to only a few mathematicians. After departing from Graz, Kepler, his wife, and his stepdaughter began the challenging journey to Prague. Their marriage did not have a lot of joy. Chronically ill and having recently lost 2 young children, his wife was described as stupid, sulking, lonely, and melancholy. She had no understanding of her husband's work, and having been raised among the minor rural gentry, she despised his impecunious profession. He, for his part, alternately reprimanded and ignored her. For my studies sometimes made me thoughtless, but I learned my lesson. I learned to have patience with her. When I saw that she took my words to heart, I would rather have bit my own finger than to give her further offence. However, Kepler remained preoccupied with his work and did not acknowledge his wife's reaction. He envisioned Tycho's domain as a refuge from the evils of the time and the place where his cosmic mystery would be confirmed. He aspired to become a colleague of the great Tycho Brahe, who for 35 years had devoted himself before the invention of the telescope to the measurement of a clockwork universe, ordered and precise. Kepler's expectations needed to be fulfilled. Impatient to see Tycho's astronomical data, Kepler would be thrown only a few scraps at a time. Tycho gave me no opportunity to share his experiences. He would only, in the course of a meal and in between other matters, mention, as if in passing, today the figure of the apogee of one planet, tomorrow the nodes of another. Tycho possesses the best observations. He also has collaborators. He needs more than the architect who would put all this to use. Tycho was the greatest observational genius of the age, and Kepler was the greatest theoretician. Each knew that he would be unable to synthesize an accurate and coherent world system, which they both felt was imminent. But Tycho was not about to make a gift of his life's work to a much younger potential rival. Joint authorship of the results, if any, of the collaboration was, for some reason, unacceptable. The birth of modern science, the offspring of theory and observation, teetered on the precipice of their mutual mistrust. In the remaining 18 months that Tycho was to live, the two quarreled and were reconciled repeatedly. Tycho, having robustly drunk much wine at a dinner given by the Baron of Rosenberg, Tycho, having robustly drunk much wine, placed civility ahead of health, and resisted his body's urgings to leave, even briefly, before the Baron. The resulting urinary tract infection worsened when Tycho steadfastly disregarded advice to moderate his consumption of food and drink. On his deathbed, Tycho bequeathed Kepler his observations, and on the last night of his gentle delirium he repeated over and over again these words like someone composing a poem: "Let me not seem to have lived in vain. Let me not seem to have lived in vain." After Tycho's passing, Kepler, who was by this time the new imperial mathematician, could coax the observations out of Tycho's family, who were resistant. His hypothesis, which proposes that the orbits of the planets are circumscribed by the 5 Platonic solids, is not supported by Tycho's or Copernicus's data in the slightest. His cosmic mystery was completely debunked by the much later discoveries of the planets Uranus, Neptune, and Pluto, because no Platonic solids could determine the distances between the Sun and the planets. In addition, The nested Pythagorean solids did not account for the Moon's presence in our solar system, and Galileo's observation that Jupiter has 4 significant moons was, rather than becoming depressed, Kepler wanted to find more satellites, and was curious about the average number of satellites each planet should have. He sent the following letter to Galileo. I immediately began to think how there could be any addition to the number of the planets without overturning my Mysterium Cosmographicum, according to which Euclid's 5 regular solids do not allow more than 6 planets around the Sun. I am so far from disbelieving the existence of the 4 circumjovial planets that I long for a telescope to anticipate you in discovering 2 around Mars. Tycho's observations of the apparent motion of Mars and other planets through the constellations were made over many years. These data from the last few decades before the telescope was invented were the most accurate that had yet to be obtained. Kepler worked passionately to understand them. What real motion of the Earth and Mars about the Sun could explain, to the precision of measurement, the apparent motion of Mars in the sky, including it moving through the constellations. Pythagoras in the 6th century BC, Plato, Ptolemy, and all of the Christian astronomers before Kepler assumed that the planets moved in circular paths. The circle was thought to be a perfect geometrical shape, and the planets placed high in the heavens, away from earthly corruption, were also thought to be, in some mystical sense, perfect. In the beginning, Kepler attempted to explain the observations by imagining that the Earth and Mars moved in circular orbits around the Sun. This was because Galileo, Tycho, and Copernicus were all committed to uniform circular planetary motion. Copernicus specifically stated that the mind shudders at the alternative because it would be unworthy to suppose such a thing in a creation constituted in the best possible way. After 3 years of calculation, he believed he had found the correct values for a Martian circular orbit, which matched 10 of Tycho's observations within 2 minutes of the arc. There are 60 minutes of arc in an angular degree and 90 degrees, a right angle, from the horizon to the zenith. Therefore, a few minutes of arc is a very small quantity to measure, especially without a telescope. The difference between a circular and true orbit could only be distinguished through precise measurement and a courageous acceptance of the facts. The universe is stamped with the adornment of harmonic proportions, but harmonies must accommodate experience. Kepler was shaken when compelled to abandon a circular orbit and question his faith in the divine geometer. As Copernicus had said, the Earth was a planet, and it was obvious to Kepler that it, racked by wars, pestilence, famine, and unhappiness, fell short of perfection. Kepler was one of the first people since antiquity to propose that the planets were material objects made of imperfect stuff like the Earth. And if planets themselves were imperfect, why not their orbits? Oh, what a silly bird I have been in the past. Kepler discovered that Mars moves around the Sun in a circle and an ellipse. The other planets have orbits much less elliptical than Mars, and if Tycho had urged him to study the motion of, say, Venus, Kepler might have yet to discover the true orbits of the planets. In such an orbit, the Sun is not at the center but is offset at the focus of the ellipse. In a uniform circular motion, an equal angle or fraction of the arc of a circle is covered in equal parts. So, for example, it takes twice as long to go 2/3 of the way around a circle as it does 1/3 of the way around. Kepler found something different for elliptical orbits. As the planet moves along its orbit, it sweeps out a wedge-shaped area within the ellipse. When it is close to the Sun, it traces out a large arc in its orbit in a given period. But the area represented by that arc is small because the planet is then near the Sun. When the planet is far from the Sun, it covers a much smaller arc in the same period, but it corresponds to a bigger area because the Sun is now more distant. Kepler found that these two areas were precisely the same no matter how elliptical the orbit. The long, skinny area, corresponding to the planet far from the Sun, and the shorter, squatter area when the planet is close to the Sun, are exactly equal. This was Kepler's second law of planetary motion. Planets sweep out equal areas at equal times. We may dismiss these laws as mere mathematical tinkering, something removed from everyday life. However, these are the laws that our planet obeys as we, glued by gravity to the surface of the Earth, hurtle through interplanetary space. We move following the third and final law of planetary motion many years later. This law relates the motion of various planets to one another and correctly lays out the clockwork of the solar system. He described this law in a book titled The Harmonies of the World. Kepler understood many things by the word harmony, including the order and beauty of planetary motion, mathematical laws explaining that motion, an idea that goes back to Pythagoras, and even harmony in the microbial world. Compared to the orbits of Mercury and Mars, the orbits of the other planets deviate from circularity to such a small degree that even an extremely accurate diagram cannot show us their true shapes. Our moving platform, the Earth, from which we observe the motion of the other planets against the background of far-off constellations, is the Milky Way galaxy. The inner planets travel through their orbits faster, which is why Mercury is given the name it does. Mercury was the messenger of the gods. The orbital speeds of Venus, Earth, and Mars become progressively slower as they move away from the Sun. As befits their status as kings of the gods, the outer planets, such as Jupiter and Saturn, move stately and slowly. Kepler's third or harmonic law states that the squares of the periods of the planets, the times for them to complete one orbit, are proportional to the cubes of their average distance from the Sun. The more distant the planet, the more slowly it moves. But according to a precise mathematical law, P2 on A3, where P represents the period of revolution of the planet about the Sun measured in years, and An is the distance from the Sun measured in astronomical units. In other words, a similar line of reasoning can be applied to every planet, asteroid, and comet in the solar system. What number, when multiplied by itself, equals 125? 11 is pretty close. Jupiter makes one revolution around the Sun every 11 years. Not content to have merely extracted the laws of planetary motion from nature, Kepler endeavored to find some still more fundamental underlying cause, some influence of the Sun on the kinematics of worlds. The planets sped up on approaching the Sun and slowed down on retreating from it. Somehow, the distant planets sensed the Sun's presence. Magnetism was also an influence felt at a distance, and in stunning anticipation of the idea of universal gravitation, Kepler's fundamental innovation in this area is breathtaking. He proposed that quantitative physical laws that apply to the Earth are also the underpinnings of quantitative physical laws that govern the heavens. This was the first non-mystical explanation of motion in the heavens, making the Earth a province of the cosmos. Magnetism is not the same as gravity, but Kepler's fundamental innovation in this area is breathtaking. He said, "Astronomy is a part of physics." Kepler's place in history is significant because he was the first astrophysicist and the last scientific astrologer. Kepler, who was not known for his modesty or quiet understatement, summarized his findings as follows. Kepler believed that within the symphony of voices, the speed of each planet corresponds to certain notes in the Latinate musical scale that was popular in his day. These notes include do, re, mi, fa, sol, la, ti, and do. He asserted that in the harmony of the spheres, the tones of Earth are fa and mi, that the Earth is perpetually humming fa and mi, and that these tones are a direct translation of the Latin word for famine. He also claimed that the Earth is constantly humming these tones. He argued, not without some success, that the Earth could be summed up in a single gloomy word. In Prague, the event that sparked the 30 Years' War outbreak occurred precisely 8 days after Kepler announced the discovery of the third law that bears his name. The upheavals caused by the war shattered the lives of millions of people, including Kepler. He was excommunicated by the Lutheran Church for his unyielding individualism on matters of doctrine, for which he was responsible for the deposition of his royal patron and for the loss of his wife and son to an epidemic carried by the soldiery. Once more, Kepler was forced to flee his home. Catholics and Protestants portrayed the conflict as a holy war. However, it was more of an exploitation of religious fanaticism by those hungry for land and power. In days gone by, conflicts were typically settled when the warring princes ran out of available resources to fight with. But now, organized pillage was introduced as a means of keeping armies in the field. The barbaric people in Europe watched helplessly as tools like plowshares and pruning hooks were transformed into swords and spears by being literally beaten into shape. Rumor and paranoia spread like wildfire across the countryside, engulfing those without control over the situation. Older women who lived alone were some of the many people targeted to serve as scapegoats. They were accused of practicing witchcraft. In the middle of the night, Kepler's mother was stolen away in a chest of drawers from the laundry room. Between 1615 and 1629, approximately 3 women were persecuted and put to death in the town of Weil der Stadt, which was Kepler's hometown. They were accused of practicing witchcraft. Katharina Kepler was an older woman who lived a stodgy life. She got involved in arguments that irked the local nobility, and she sold drugs that were possibly hallucinogenic and soporific, just like Mexican curanderas do today. Kepler, the poor man, was under the impression that he was responsible for her apprehension. Kepler is credited with writing one of the earliest works of science fiction, intended to explain and popularize scientific concepts. This led to the discovery. It was called the Somnium, Latin for the dream. He imagined a journey to the moon, with the space travelers standing on the lunar surface and observing the lovely planet Earth rotating slowly in the sky above them. By changing our perspective, we can figure out how the world works. One of the primary objections to the idea that the Earth turns was that people do not feel the motion. I want to be one of the many who support this cause. Because of this, I make it a point to explain it to as many people as possible. On another occasion, he wrote in a letter, "Do not sentence me completely to the treadmill of mathematical calculations. Leave me time for philosophical speculations, my sole delight." What Kepler referred to as lunar geography was made possible by the invention of the telescope. In the Somnium, he described the moon as being filled with mountains and valleys, and as being porous, as though dug through with hollows and continuous caves. This referenced the lunar craters Galileo had recently discovered with the first astronomical telescope. Kepler also imagined that the moon had inhabitants well adapted to the harsh conditions of the local environment. Because of the lunar day and night length, Kepler described the great intemperateness of climate and the most violent alternation of extreme heat and cold on the moon, which is entirely accurate. Of course, he did not get everything right. For instance, he believed a substantial lunar atmosphere, oceans, and inhabitants existed. Most curious is his view of the origin of the lunar craters, which make the moon not dissimilar to the face of a boy dripping with blood. He successfully argued that the craters should be depressions rather than mounds. His observations led him to notice the ramparts that surrounded many of the craters and the centrally located peaks. On the other hand, he believed that because of their regular circular shape, which suggested a high degree of order, the only thing that could explain them was intelligent life. He was unaware that large rocks crashing to the surface from space would cause a local explosion that would be perfectly symmetric in all directions and carve out a circular cavity. This mechanism is responsible for forming most of the craters on the Moon and the other terrestrial planets. Instead, he deduced the existence of some race rationally capable of constructing those hollows on the Moon's surface. He reasoned that this race must consist of many individuals so that one group can utilize one hollow while another group constructs another. Kepler offered as counterexamples the pyramids of Egypt and the Great Wall of China, both of which can in fact be seen today from Earth's orbit, refuting the view that such enormous construction projects were unlikely. Kepler's entire life revolved around the concept that the order revealed by geometry points to an underlying intelligence. His argument regarding the craters on the Moon provides an unmistakable preview of the debate regarding the canals on Mars. It is fascinating to consider that the observational search for extraterrestrial life began in the same generation as the invention of the telescope and with the most prominent theoretician of the time. Several parts of the Somnium were very obviously autobiographical. For instance, the protagonist pays a visit to Tycho Brahe. His parents are involved in the drug trade, His mother is known to have associations with ghosts and demons, and it is eventually one of these entities that provides... At the time of the 30 Years' War, science fiction was a novel concept, and Kepler's book was used as evidence that his mother was a witch. However, the Somnium makes it clear to us, even though it did not to all of Kepler's contemporaries, that, in a dream, one must be allowed the liberty of occasionally imagining that which never existed in the world of sense perception. Amid other serious personal problems, Kepler rushed to Württemberg to find his mother, who was 74 years old, chained in a Protestant secular dungeon and threatened, like Galileo in a Catholic dungeon, with torture. He immediately set about, as a scientist naturally would, to find natural explanations for the various events that had precipitated the accusations of witchcraft, including minor physical ailments that the burghers of Württemberg had. He spent his final years in a Silesian town controlled by Wallenstein and called Sagan, and his epitaph, which he composed, was as follows: "I measured the skies, now the shadows I measure. Sky-bound was the mind, earth-bound was the body, but the 30 Years' War obliterated his grave." If a marker were to be erected today, it might read, as a homage to his scientific courage, "He preferred the hard truth to his dearest illusions." Johannes Kepler had the vision that one day there would be celestial ships with sails adapted to the winds of heaven, sailing through the sky, filled with explorers, who would not fear the vastness of space. Today, those human and robot explorers employ as unerring guides on their voyages through the vastness of space the 3 laws of planetary motion that Kepler discovered during a lifetime of personal struggle and ecstatic discovery. Isaac Newton was born on Christmas Day, 1642, so tiny that, as his mother told him years later, he would have fit into a quart mug. Despite being sickly, feeling abandoned by his parents, quarrelsome, unsociable, and a virgin to the day he died, Isaac Newton was perhaps the greatest scientific genius who ever lived. Kepler's lifelong quest to understand the motions of the planets and seek harmony in the heavens culminated in the work of Isaac Newton. Even as a young man, Newton was impatient with questions that lacked substance, such as whether light was a substance or an accident, or how gravitation could act over an intervening vacuum. He was also impatient with people who questioned his theories. Early on, he concluded that the traditional Christian understanding of the Trinity was based on a misunderstanding of the biblical text. His biographer, John Maynard Keynes, says the following about him: "He adhered more to the monotheistic approach of the Maimonidean school of Judaism. He arrived at this verdict not based on anything that could be considered rational or skeptical, but solely on the interpretation of ancient authority. He was convinced that the revealed documents did not support the Trinitarian doctrines, which resulted from late forgeries, and that this was due to the revelations. The God who was revealed was a singular deity. But this was a terrible secret that Newton had spent his entire life doing everything he could to keep hidden. He was not immune to the superstitions of his day, and had many encounters with mysticism. He was similar to Kepler in this regard. In fact, a significant portion of Isaac Newton's intellectual growth can be traced back to the conflict between rationalism and mysticism. At the Stourbridge Fair in 1663, at age 20, he purchased a book on astrology out of a curiosity to see what was in it. He read it until he came to an illustration that he could not understand because he was ignorant of trigonometry. So he purchased a book on trigonometry, but soon found himself unable to follow the geometrical arguments. So he found a copy of Euclid's Elements of Geometry and began to read. 2 years later, he invented differential calculus. Newton, a student at the time, was mesmerized by light and hypnotized by the sun. As a result, he engaged in the potentially fatal practice of staring at the reflection of the sun in a looking glass. I had brought my eyes to such a state in a matter of hours that I was unable to look upon any bright object with either eye. But I saw the sun before me so that I could neither write nor read. But to regain the use of my eyes, I shut myself up in my chamber, made 3 dark days together, and used every means possible to divert my imagination from the sun. If I thought of him, I immediately saw his picture. Newton was an undergraduate at Cambridge University in 1666, when a plague outbreak forced him to spend a year in idleness in the isolated village of Woolsthorpe, where he had been born. During this time, Newton invented differential and integral calculus, made fundamental discoveries on the nature of light, and laid the foundation for the theory of universal gravitation. The only other year in the history of physics that was comparable to Newton's was Einstein's. Isaac Barrow, Newton's mathematics professor at Cambridge, stepped down from the chair he held in favor of Newton 5 years after the young student had returned to the university. Newton's work was considered to be of such great significance. The following is how Newton, who was in the middle of his 40s at the time, was described by his servant. I never knew him to take any recreation or pastime either in riding out to take the air, walking, bowling, or any other exercise whatever, thinking all hours lost that were not spent in his studies, to which he kept so close that he seldom left his chamber unless to lecture, at term time, where so few went to hear him and fewer understood him that oft times he did in a manner, for want of hearers, read to the walls. Students who studied under Kepler and those who studied under Newton were never aware of what they were missing out on. Newton is credited with discovering the law of inertia, which states that an object in motion tends to continue moving in a straight line unless influenced by something that causes it to deviate from its path. It appeared to Newton that the moon would fly off in a straight line, tangential to its orbit unless there was some other force constantly diverting the path into a near circle and pulling it in the direction of the Earth. If this other force did not exist, the moon would fly off in a straight line, tangential to its orbit. Newton coined the term gravity to describe this force, and he believed that it operated at a distance. There is no actual connection between the Earth and the moon on a physical level. Despite this, the pull of the Earth's gravitational pull on the moon never stops. Newton mathematically deduced the using Kepler's third law as his starting point. The fundamental characteristics of the gravitational force. He demonstrated that the same force that causes an apple to fall to the ground is also responsible for keeping the moon in its orbit around the Earth, and for accounting for the revolutions of the then recently discovered moons of Jupiter in their orbits around that faraway planet. Ever since the beginning of time, things had been going from bad to worse. Since the beginning of human history, people have believed that the moon followed a path around the Earth. Newton was the first to discover that both occurrences could be traced back to the same driving force. This is what is meant when we use the term universal in Newton's theory of gravitation. The law of gravity is universal and applies in every part of the universe. This is under the law of the inverse square. The force decreases at a rate proportional to the square of the distance. When two objects are separated by a distance that is twice as great, the gravitational force that pulls them towards one another is only 1/4 as strong. If they are more than 10 times further apart, then the gravity is 10 squared, 10 to the power of 2, which equals 100 times less. It is abundantly clear that the force must be inverse in some sense. That is, it must decrease with increasing distance. If the force was direct and increased with distance, then the most powerful force would work on the most remote objects, and I imagine that all of the matter in the universe would end up clumping into a single cosmic mass. No, gravity can't increase with distance. This is why a comet or a planet moves slowly when it is far from the sun and quickly when it is close to the sun. The gravity that they experience is weaker the further they are from the sun. From Newtonian principles, it is possible to derive all three of Kepler's laws regarding the motion of planets. The empirical observations made by Tycho Brahe served as the foundation for Kepler's laws, which were developed later. Newton's laws were theoretical, rather straightforward mathematical abstractions, and they were ultimately the starting point from which all of Tycho's measurements could be derived. As a direct result of these laws, Newton wrote with undisguised pride in the Principia, "I now demonstrate the frame of the system of the world." Newton spent the latter part of his life serving as the Master of the Mint and as the President of the Royal Society. As President of the Royal Society, he focused on combating counterfeit coinage. Some spread rumors that he had experienced the 17th century equivalent of a nervous breakdown. However, Newton continued his lifelong experiments on the border between alchemy and chemistry, and some recent evidence suggests that what he was suffering from may not have been a nervous breakdown at all. His natural moodiness and reclusively grew. He abandoned those scientific endeavors that brought him into quarrelsome disputes with other scientists, primarily on priority issues. His moodiness and wreck, nevertheless, his prodigious intellectual powers persisted unabated. In 1696, the Swiss mathematician Johann Bernoulli challenged his colleagues to solve an unresolved issue called the brachistochrone problem, specifying the curve connecting 2 points displaced from each other laterally, along which a body, acted upon only by gravity, would fall in the shortest time. Bernoulli originally specified a deadline of 6 months, but extended it to a year and a half at the request of Leibniz, one of the leading scholars of the time and the man who, independently of Newton, invented differential and integral calculus. The challenge was delivered to Newton at 4 p.m. on January 29, 1697. Before leaving for work the next morning, he had invented an entirely new branch of mathematics called the calculus of variations, used it to solve the brachistochrone problem, and sent off the solution, published anonymously at Newton's request. But the work's brilliance and originality betrayed its author's identity. When Bernoulli saw the solution, he commented, "We recognize the lion by his claw." Newton had just turned 55 years old at the time. The concordance and calibration of the chronologies of ancient civilizations was the major intellectual pursuit he focused on during his final years. He did this in a manner that was very much in the tradition of the ancient historians Manetho, Strabo, and Eratosthenes. In his final posthumous work, The Chronology of Ancient Kingdoms Amended, we find repeated astronomical calibrations of historical events, an architectural reconstruction of the Temple of Solomon, a provocative claim that all of the Northern Hemisphere constellations are named after the personages, artifacts, and events in the Greek story of Jason and the Argonauts, and the consistent assumption that the gods of all civilizations, with the sole exception of Newton's own, were essentially the same. Kepler and Newton represent an important turning point in human history. This turning point is the realization that relatively straightforward mathematical laws govern all aspects of nature, that the same rules apply on Earth as they do in the heavens, and that there is a resonance between how humans think and how the world functions. They were unwavering in their commitment to the reliability of the observational data, and the accuracy of their forecasts regarding the movement of the planets provided compelling evidence that humans can comprehend the universe on an unexpectedly profound level. Their insights have significantly impacted our contemporary global civilization, our perspective of the world, and our ongoing investigation of the universe. Newton was secretive about his findings and cutthroatly competitive with his contemporaries in the scientific community. He didn't give a second thought to the fact that the inverse square law wouldn't be published for another decade or two after it was discovered. But in the face of the majesty and complexity of nature, he was, like Ptolemy and Kepler, both exhilarated and disarmingly modest. A few months before he passed away, he penned the following words: "I do not know what I may appear to the world, but to myself I seem to have been only like a boy, playing on the seashore and diverting myself now and then in finding a smoother pebbly or a prettier shell than ordinary, while the great ocean of truth lay all undiscovered before me. The earth is a beautiful and, for the most part, tranquil location. Things are shifting, but only gradually. We can live our entire lives without ever coming into direct contact with a natural disaster that is more severe than a storm. As a result, we start to feel comfortable, relaxed, and careless about the situation. But the record is crystal clear regarding the history of nature. The entire planet has been annihilated. Even we humans have attained the technically dubious distinction of being able to cause our own catastrophes, whether on purpose or dubious distinction. There is abundant evidence of major catastrophes on the landscapes of other planets where past records have been preserved. These are the landscapes. It is just a matter of time at this point. In 100 million years from now, something that is inconceivable happening in the next 100 years may be unavoidable. There have been strange natural occurrences on Earth and even in our own century. On June 30th, 1908, early in the morning, people in the central region of Siberia reported seeing a massive fireball traveling very quickly across the sky. An enormous explosion occurred exactly where it had made contact with the horizon. Near the point of impact, it started a flash fire that consumed thousands of trees and leveled approximately 2,000 square kilometers of forest land. It resulted in the production of an atmospheric shockwave that went around the planet twice. After that, there was such a high concentration of fine dust in the air for the next 2 days that people walking the streets of London, which is more than 6,000 miles away, could see well enough to read a newspaper by the light scattered by the dust. Because it had taken place in such a remote location among the backward Tungus people of Siberia, the government of Russia during the time of the Tsars was not interested in investigating such a meaningless event. After 10 years since the revolution, an expedition finally arrived to investigate the area and question the eyewitnesses. The following is a selection of the reports they brought back. The tent, along with its occupants, was lifted into the air at an early hour in the morning while everyone inside was still sound asleep. The impact of their fall caused everyone in the family to sustain some minor cuts and bruises. But Akulina and Ivan actually lost consciousness. As soon as they came to, they heard a great deal of noise and saw that the forest was on fire all around them, with a significant portion of it destroyed. At breakfast time, I was lounging on the porch of the house that served as the trading station in Vanovara and looking towards the direction of the north. I had just brought my axe up to my shoulder in preparation to hoop a cask when suddenly the sky appeared to be cut in half and high above the treetops. The entire northern portion of the sky gave the impression that it was on fire. At that precise instant, I had the impression that my shirt was on fire. I was about to take off my shirt and toss it when there was a loud explosion overhead, followed by the sound of something crashing to the ground with great force. I was knocked unconscious for a brief period of time after being thrown to the ground approximately 3 sageens away from the porch. My wife ran outside and brought me back inside on her back. Immediately after the impact, a sound sounded like stones falling from the sky or guns firing. When I lay down on the ground, I drew a blanket over my head out of nervousness that I would be struck by falling rocks. The earth was shaking. At that precise instant, when the clouds parted, a sweltering wind, like it had been fired from a cannon, blew past the huts coming from the direction of the north. The terrain bore the imprint of its passage. I was eating breakfast next to my plough when I heard loud bangs that sounded like they were coming from a gun. My horse was brought to its knees by this. A fire started on the northern slope, quickly spreading across the forest's canopy. After that, I noticed that the fir trees in the forest had been blown over, and I immediately thought of a hurricane. I reached out and grabbed hold of my plough with both hands to ensure it would not be lost. The hurricane caused a wall of water to be driven up the Angara, and the wind was so powerful that it carried away some of the soil on the ground surface. Because my land was on a hillside, I could see everything clearly. The horses were so frightened by the roar that some ran away in a frenzy, dragging the ploughs in various directions while others became incapacitated and collapsed. The carpenters had crossed themselves in a stupor after the first and second explosions, and when the third explosion resounded, they fell backwards from the building onto the chips of wood below. I needed to reassure them and bring some back to composure because they were startled and terrified. There, we all quit our large groups of local residents were seen congregating in the streets in fear and talking about the phenomenon that had occurred there. I was out in the countryside. I had just begun to attach another horse to the harrow when all of a sudden I heard what sounded like a single loud shot coming from the right. I had just finished harnessing one horse to the harrow. Instantaneously, I turned around and saw an elongated object that was ablaze and flying through the sky. Its color resembled fire during the daytime, and the front portion was significantly broader than the back portion of the creature. It was so much fainter compared to the sun that people could look at it with their bare eyes, even though it was much larger than the sun. Something that looked like dust was trailing behind the flames. It was encircled by a ring of little puffs, and the flames had left behind blue streamers as they died out. As soon as the flame went out, Bangs that were even louder than the shots from a gun could be heard, the ground could be felt to shake, and the window panes in the cabin shattered. I was sitting on the bank of the River Can, washing wool at the time. Suddenly a sound that sounded like the frantic flapping of wings by a scared bird came into the room, and the river began to experience some swell. Following this, a single severe bang was so loud that one of the workers was knocked into the water. The remarkable occurrence in Tunguska is known as the Tunguska event. Some researchers believe that it was caused by a piece of antimatter that hurtled through space and made contact with the ordinary matter of the Earth. As a result, the antimatter was destroyed and vanished in a burst of gamma rays. This explanation, however, is not supported by the fact that there was no radioactivity at the site of the impact. Others hypothesize that a miniature black hole exited the other side of the Earth in Siberia after passing through the planet. However, there is no indication of an object that boomed out of the North Atlantic later that day in the records of atmospheric shock waves. It's possible that it was a spaceship from an extraterrestrial civilization that was so technologically advanced that it crashed into an inaccessible part of an unknown planet due to a catastrophic mechanical failure. However, no indication of such a vessel having been present at the point of impact exists. Every one of these suggestions has been made, some of them in a more serious light than others. There is not a single one of them that the evidence strongly supports. The Tunguska event is best understood because there was an enormous explosion, a significant shockwave, and a massive forest fire. However, there is no evidence of an impact crater at the location. It would appear that there is only one explanation that can make sense of all of the facts. In 1908, a piece of a comet collided with the Earth. In the vast voids between the planets, there are a great number of objects, some of which are made of rock, some of which are made of metal, some of which are made of ice, and some of which are composed of organic molecules. They can be as small as individual dust particles or as large as erratic blocks the size of Nicaragua or Bhutan. And every once in a while, it just so happens that there is a planet in the way. An ice fragment of a comet measuring approximately 100 meters in diameter, or the size of a football pitch, weighing approximately 1 million tons and moving at approximately 30 kilometers per second, or 70,000 miles per hour, is believed to have been the cause of the Tunguska event. In this day and age, if such a collision were to occur, it is possible to be misunderstood as a nuclear explosion, especially given the hysteria that would ensue. The cometary impact and fireball would simulate all of the effects of a 1 megaton nuclear burst, including the mushroom cloud, with the following two exceptions. There would be no gamma radiation and no radioactive fallout. Could a natural but extremely unlikely occurrence, such as the collision of a sizable cometary fragment, set off a nuclear war? Imagine this bizarre scenario. The Earth is struck by a comet, one of the millions that have done so in the past, and in response our society decides to immediately destroy itself. It is possible that it would be beneficial for us to better understand comets, collisions, and disasters than we currently do. On September 22, 1979, a US Vela satellite picked up on a particularly bright and brief double flash of light coming from somewhere in the early theories suggested that either Israel or South Africa had conducted a covert nuclear test using a weapon with a low yield, 2 kilotons or approximately a sixth of the energy of the Hiroshima bomb. The political repercussions were regarded as having significant gravity across the globe. But what if the flashes were caused by the collision of a comet fragment or a small asteroid instead? This is a real possibility, and it highlights the dangers of not monitoring impacts from space better than we do in an age when nuclear weapons exist, as airborne overflakes in the vicinity of the flashes showed no trace of unusual radioactivity in the air. The majority of a comet is composed of ice, specifically water, H2O ice, along with a small amount of methane, CH4 ice, and some ammonia, NH3 ice. When it collided with the atmosphere of Earth, even a small fragment of a comet would cause an enormous radiant fireball and a powerful blast wave. This wave would cause trees and forests to be leveled and could be heard all over the world. However, it is possible that it will not leave much of a crater in the ground. The entrance would result in the complete melting of the ice. Very few pieces of the comet could be recognized, possibly just a scattering of small grains originating from the cometary nucleus's non-icy parts. Recent research by the Soviet scientist E. Sobotovich discovered a significant quantity of incredibly minute diamonds scattered across the Tunguska site. It is already well established that such diamonds exist in meteorites that have withstood the force of impact, and that these meteorites may ultimately have originated from comets. If you wait patiently and look up at the sky on a clear night, you will see a single meteor blazing briefly overhead. This will happen on many nights. A meteor shower is a natural fireworks display on the same few days yearly. It is also known as an entertainment show in the heavens. These meteors are composed of extremely minute grains, each of which is no bigger than a mustard seed. They are more like falling fluff than exploding shooting stars. When they enter the atmosphere of the Earth, they have a brief moment of brilliance before being heated and destroyed by friction at a height of approximately 100 kilometers. Comets break up into pieces that eventually become meteors. Comets that have been around for a long time tend to disintegrate and evaporate as a result of repeated encounters with the sun's heat. The debris grows and eventually fills up the entire cometary orbit. At the point where the path of that orbit crosses the path of the Earth's orbit, there is a cloud of meteors waiting for us. Because some portion of the swarm is always at the same position in the Earth's orbit, the meteor shower is always observed on the same day of the year. This ensures that the shower can be reliably predicted. The Beta Taurid meteor shower occurred on June 30, 1908, and was associated with the orbit of Comet Encke. A piece of Comet Encke was responsible for the Tunguska event. This piece of the comet was significantly larger than the minuscule fragments responsible for the dazzling but harmless meteor showers. Fear, awe, and superstition have always been associated with comets. The concept of an unchangeable and divinely ordered cosmos was questioned when they made occasional appearances, which was unsettling. It seemed inconceivable that a magnificent swath of milk-white flame, which rose and set with the stars night after night, was not present for a purpose, and did not hold some significance for the affairs of humankind. As a result, the concept emerged that comets were portents of doom, indications of the wrath of a higher power, and that they predicted the demise of princes and the dissolution of kingdoms. The Babylonians believed that comets were the beards of the gods in the heavens. The Greeks envisioned long, flowing hair, while the Arabs envisioned swords on fire. Comets were meticulously categorized during the time of Ptolemy as beams, trumpets, jars, and so on, according to their shapes. Ptolemy believed that comets caused wars, hot weather, and disturbed conditions. Some depictions of comets from the Middle Ages look like unidentified flying crucifixes. Andreas Calicius, a Lutheran superintendent or bishop of Magdeburg, published in 1578 a work titled Theological Reminder of the New Comet, in which he presented the inspired view that a comet is the thick smoke of human sins, rising every day, every hour, every moment, full of stench and horror before the face of God, and becoming gradually so thick as to form a comet. The oldest record of an apparition of Halley's or any other comet appears in the Chinese book of Prince Huainan, attendant to the march of King Wu against Zhou of Yin. The year was 1057 BC. The approach to Earth of Halley's comet in the year 66 is the probable explanation of the account by Josephus of a sword that hung over Jerusalem for a whole year. In 1066, the Normans witnessed another return of Halley's comet, since it must, they thought, presage the fall of some kingdom. The comet encouraged, in some sense precipitating, the invasion of England by William the Conqueror. The comet was duly noted in the newspaper of the time, the Bayeux Tapestry. In 1301, Giotto, one of the founders of modern realistic painting, witnessed another apparition of Comet Halley and inserted it into a nativity scene. The Great Comet of 1466, yet another return of Halley's comet, panicked Christian Europe. The Christians feared that God, who sends comets, might be on the side of the Turks, who had just captured Constantinople. The leading astronomers of the 16th and 17th centuries were fascinated by comets, and even Newton became a little giddy over them. Kepler described comets as darting through space, as the fishes in the sea, but being dissipated by sunlight, as the cometary tail always points away from the sun. David Hume, in many cases an uncompromising rationalist, at least toyed with the notion that comets were the reproductive cells, the eggs or sperm, of planetary systems, and that planets are produced by a kind of interstellar sex. As an undergraduate, before he invented the reflecting telescope, Newton spent many consecutive sleepless nights searching the sky for comets with his naked eye, pursuing them with such fervor that he felt ill from exhaustion. Following Tycho and Kepler, Newton concluded that the comets seen from Earth do not move within our atmosphere as Aristotle and others had thought, but rather are more distant than the Moon, although closer than Saturn. Comets shine, as the planets do, by reflected sunlight. And they are much mistaken who remove them almost as far as the fixed stars. For if it were so, the comets could receive no more light from our sun than our planets do from the fixed stars. This demystification, this prediction of regular cometary orbits, led his friend Edmund Halley in 1707 to calculate that the comets of 1531, 1607, and 1682 were apparitions at 76-year intervals of the same comet, and predict its return in 1758. The comet duly arrived and was named for him posthumously. Comet Halley has played an interesting role in the solar system's history. Planetary scientists of today sometimes argue that the impact of a comet on a planet might significantly contribute to the planetary atmosphere. For instance, all of the water in the atmosphere of Mars today might be accounted for by the recent impact of a small comet. Newton observed that the matter in the tails of comets is lost to the comet and gradually attracted gravitationally to nearby planets. If they are not supplied from outside, the fluids must be in a continual decline and completely run out in the end, if there is no external supply. Newton appears to have believed that the oceans on Earth originated from comets, and that the only reason life can exist on Earth is because cometary material falls to the planet's surface. He went on to say this in a mystical musing, "I suspect, moreover, that it is chiefly from the comets that spirit comes," which is indeed the smallest but the most subtle and useful part of our air, and so much required to sustain the life of all things with us. This was said in the context of his belief that comets were the primary source of spirit. Huggins had found organic matter in the comets. In subsequent years, cyanogen, CN, consisting of a carbon and a nitrogen atom, the molecular fragment that makes cyanides, was identified in the tails of comets. Many people panicked when the Earth was about to pass through the tail of Halley's comet in 1910. Huggins found an identity between some features in the spectrum of a comet and the spectrum of natural, or olefiant, gas. But that didn't put anyone's mind at ease. For instance, on May 15, 1910, the San Francisco Chronicle featured headlines such as "Comet Camera as Big as a House," "Comet Comes and Husband Reforms," and "Comet Parties Now Fad in New York." In 1910, there were parties making merry before the world ended due to cyanogen pollution. Entrepreneurs hawked anti-comet pills and gas masks, the latter being an eerie. The Los Angeles Examiner adopted a light mood. "Say, has that comet cyanogened you yet? Entire human race. Due for free gaseous bath. Expect high jinx." In 1957, I was a graduate student at the Yerkes Observatory at the University of Chicago. Alone in the observatory late one night, I heard the telephone ring repeatedly. When I answered, a voice, betraying a well-advanced state of intoxication, said, "Let's talk to a strainer. Can I help you?" "Well, see, we're having this garden party out here in Wilmette, and there's something in the sky. The funny part is that if you look straight at it, it goes away. But if you don't look at it, there it is. The most sensitive part of the retina is not at the center of the field of view. You can see faint stars and other objects by averting your vision slightly." I knew that a newly discovered comet called Arend-Roland was barely visible in the sky at this time, so I told him that he was probably looking at a comet. There was a long pause, followed by the query, "What is a comet?" "A comet," I replied, "is a snowball 1 mile across." After an extended pause, the caller asked, Let's talk to a real strainer." And the conversation continued there. When Halley's Comet made its next appearance in 1986, I couldn't help but wonder which political leaders would be shaken by the event, and what other foolishness would befall us at that time. Even though the planets travel in elliptical orbits around the Sun, the ellipses in which they travel are not very elliptical. At first glance, it is difficult to tell them apart from circles because they are nearly identical in appearance. It is the comets, and more specifically the comets with long periods, that have extremely elliptical orbits. The comets are the newcomers to the inner solar system, while the planets have been around for a long time. Why are the orbits of the planets almost perfectly circular? And why are they so well separated from one another? Because if planets traveled in extremely elliptical orbits, their paths would eventually cross one another, which would inevitably lead to a collision. There were most likely a great number of planets that were still in the process of forming in the early days of the solar system. Those with orbits that crossed each other in an elliptical pattern were more likely to crash into each other and destroy themselves. Those with more circular orbits were more likely to thrive and endure. The current orbits of the planets were established by the planets that managed to survive the collisional natural selection that occurred during the stable middle age of a solar system dominated by early catastrophic impacts. A vast spherical cloud of 1 trillion cometary nuclei orbits the Sun at a speed comparable to that of a racing car at the Indianapolis 500. This cloud is located far beyond the planets in the most distant part of the solar system. A fairly typical comet would resemble a giant snowball that is rolling around about 1 kilometer in diameter. The majority of them are never able to cross the boundary that is denoted by Pluto's orbit. However, on rare occasions, a passing star will cause a gravitational flurry and commotion in the cometary cloud. As a result, a group of comets will find themselves in highly elliptical orbits and begin their descent towards the Sun. After having its trajectory altered even further by the gravitational pull of Jupiter or Saturn, the comet has a habit of, on average, speeding towards the inner solar system once every century or so. It would start heating up and evaporating somewhere between the orbits of Jupiter and Mars. Fragments of dust and ice are carried back behind the comet by the solar wind, which is matter blown outwards from the Sun's atmosphere. This is the beginning of the comet's tail. If Jupiter were only 1 meter across, our comet would be no bigger than a speck of dust. However, once it reached its full potential, the comet's tail would be as long as the distance between the worlds. Each of its orbits around the Sun would cause people living on Earth to behave in superstition whenever they could catch a glimpse of the planet. But in time, they would realize that it did not live in their atmosphere, but rather among the other planets in the galaxy. They would figure out the trajectory of its orbit. And who knows, maybe in the not-too-distant future, they will send a rudimentary spacecraft hurtling through space, specifically designed to investigate this traveler from the realm of the stars. Comets and planets are The Earth and its satellite, the Moon, must endure constant barrages from comets and other minor asteroids, remnants from the process of assembling the solar system. There should be more impacts caused by smaller objects than by larger ones because there are more small objects than large ones. An impact of a small cometary fragment with the Earth, such as the one at Tunguska, should occur approximately once every 1,000 years. On the other hand, a collision with a large comet like Halley's Comet, whose nucleus is possibly 20 kilometers across, should only occur about once every billion years. It's possible that a small, icy object won't leave a significant scar on a planet or moon if it has a collision with one of those bodies. But if the object impacting is either more massive or primarily composed of rock, there will be an explosion that will carve out a bowl-shaped depression known as an impact crater. And if there is no process that smooths out the crater or fills it in, it may remain there for billions of years. When we examine the surface of the Moon, we find that it is covered with impact craters, many more than can be accounted for by the sparse population of cometary and asteroid debris that now fills the inner solar system. This is because almost no erosion takes place on the Moon. And when we do examine its surface, we find that it is almost entirely made up of impact craters The lunar surface provides eloquent testimony of a previous age in which the destruction of worlds occurred, which has now been gone for billions of years. There are impact craters all over the solar system, not just on the Moon. They are found throughout the inner solar system, from Mercury, the planet closest to the Sun, to Venus, which is covered in clouds, to Mars and its two very small moons, Phobos and Deimos. These are the planets in our solar system's family of worlds known as the terrestrial planets. They are the planets that are most comparable to Earth. They have solid surfaces, rock and iron interiors, and atmospheres ranging from almost a complete vacuum to pressures that are 90 times higher than the pressure on Earth. They congregate around the Sun, providing light and warmth like campers do around a fire. About 4.6 billion years have passed since the planets formed. They all provide evidence, just like the Moon does, that the solar system's early history was marked by catastrophic impact. After we pass Mars, we enter a very different regime, the realm of Jupiter and the other giant or Jovian planets. This is where we will spend the rest of our time. These are enormous worlds predominantly made up of hydrogen and helium, along with smaller amounts of other hydrogen-rich gases and liquids like methane, ammonia, and water. Here, all we can see is the atmosphere and various cloud types. No solid surfaces can be seen. These are significant planets, not insignificant worldlets like our own planet Earth. Jupiter's interior has enough room to accommodate 1,000 Earths. If a comet or an asteroid were to enter Jupiter's atmosphere, we would not anticipate the formation of a visible crater. Rather, we would anticipate a momentary break in the clouds. Despite this, we know there has been a history of collisions in the solar system's outer reaches dating back many billions of years. This is because Jupiter has a vast system consisting of more than a dozen moons, 5 of which were investigated in greater detail by the Voyager spacecraft. Once more, we discover evidence of past catastrophic events here. When the entirety of the solar system has been explored, we will likely find evidence of an impact catastrophe on each of the 9 planets, ranging from Mercury to Pluto, as well as on all of the smaller moons, comets, and asteroids. On the side of the Moon that is closest to Earth and can be viewed through telescopes here on Earth, there are approximately 10,000 craters. Most of them are in the ancient lunar highlands and date back to when the Moon was formed, from the last accretion of material from space debris. In the Maria, Latin for seas, which are lowland regions that were flooded, possibly by lava, shortly after the Moon's formation, covering the pre-existing craters. There are approximately 1,000 craters larger than a kilometer across. Therefore, craters on the Moon should be formed today at approximately 109 years per 104 craters, 105 years per crater, or 100,000 years between cratering events. This estimate, we may have to wait even longer than 100,000 years before we see a crater form on the Moon, because there may have been more interplanetary debris a few billion years ago than there is today. If this is the case, we will need to be patient. As a result of the Earth's larger surface area compared to that of the Moon, we may have to wait somewhere in the neighborhood of 10,000 years between collisions that would create craters on our planet that are as large as a kilometer across. Considering that the age of the meteor crater in Arizona, an impact crater approximately 1 kilometer in diameter, has been determined to be between 20 and 30,000 years old. The observations made on Earth agree with such crude calculations. The actual collision of a small comet or asteroid with the Moon could produce a momentary explosion that is bright enough to be seen from Earth. We can imagine our ancestors gazing up into the night sky on some night 100,000 years ago and noticing a peculiar cloud rising from the portion of the Moon that was not illuminated by the Sun when it was suddenly struck by the Sun's rays. This cloud was known as the lunar eclipse. But we would not have anticipated that such a thing would have occurred during historical times. The likelihood of that happening is probably less than 1 in 100 at this point. On the evening of June 25th, 1178, 5 British monks reported something extraordinary, which was later recorded in the Chronicle of Gervase of Canterbury, who was generally considered a reliable reporter on the political and cultural events of his time, after he had interviewed the eyewitnesses who asserted, under oath, the truth of their story. This is how the chronicle goes. There was a brilliant new moon, and as is customary for the moon when it is in that phase, its horns were angled in the direction of the east. The upper horn separated into two pieces all of a sudden. A torch that was ablaze and emitting flames, sparks, and hot coals suddenly emerged from the point in the middle of the division. Astronomers Daryl Mulholland and Odile Calamé have calculated that a lunar impact would produce a dust cloud rising off the moon's surface, with an appearance that corresponds rather closely to the report of the Canterbury monks. This finding was possible because a lunar impact would produce a dust cloud rising off the moon's surface. If such a collision occurred 800 years ago, the crater should still be visible today. Even relatively young craters on the moon, ranging from a few billion to tens of billions of years, have retained a high degree of their original structure. This is because there is neither air nor water on the moon. Using the description recorded by Gervais, it is possible to zero in on the moon region to which the observations refer. The explosion creates rays and linear trails of fine powder spewed out, and the impacts produce these rays and trails. These rays are connected to the youngest craters on the moon, such as the ones named after Aristarchus, Copernicus, and Kepler. On the moon, the craters may withstand the effects of erosion, but the moon's extremely thin rays do not. Even the arrival of micrometeorites, tiny dust particles that originate in space, can stir up and cover up the rays, eventually leading to their disappearance. Consequently, rays are the telltale sign of a recent impact. Jack Hartung, a meteoriticist, has pointed out that the moon region referred to by the Canterbury monks contains an extremely recent, very fresh-looking small crater with a prominent ray system. Hartung also noted that this crater has a prominent ray system. It was given the name Giordano Bruno in honor of the Roman Catholic scholar Giordano Bruno, who lived in the 16th century and proposed that there is an infinite number of worlds, many inhabited. In 1600, he was killed by being skewered and burned at the stake for these and other offences. Calamé and Mulholland have provided yet another line of evidence that can be interpreted consistently with this interpretation. A moon struck by an object travelling at high speed causes the moon to tremble ever so slightly. The vibrations will stop occurring at some point in the future, but this will not happen within the next 800 years. The techniques of laser reflection allow for the study of this quivering. Laser retroreflectors are specialized mirrors that the Apollo astronauts placed across the laser beam emanating from Earth hits a mirror and then bounces back. It is possible to measure the round-trip travel time with extraordinary accuracy. This time, multiplied by the speed of light, estimates the distance to the moon at that precise moment. The accuracy of this estimate is truly remarkable. Such measurements, carried out over several years, reveal that the moon is librating or quivering, with a period, approximately 3 years, and an amplitude, approximately 3 meters. This finding is consistent with the hypothesis that the crater Giordano Bruno was excavated in the last 1,000 years. This entire body of evidence is inferential and circumstantial. As I've mentioned, the chances of such an occurrence occurring in historical times are extremely low. However, there is at least some evidence that points in that direction. The Tunguska event and the meteor crater in Arizona serve as reminders that the early history of the solar system was not the only period in which catastrophic impacts occurred. Even on the moon, some erosion occurs because only a few lunar craters have extensive ray systems. This fact, however, serves as a reminder that erosion takes place. We can reconstruct the sequence of impact and flooding events on the moon by paying attention to which craters overlap, which others and other signs of lunar stratigraphy. The formation of the crater Bruno is perhaps the most recent example of this event. On this page, you will find an attempt to visualize the processes that resulted in the surface of the lunar hemisphere that is visible from Earth. The distance between the Earth and the Moon is not great. If the Moon is covered in craters to such a severe extent, how has the Earth managed to avoid them? What are the odds of coming across a meteor crater? Do comets and asteroids believe colliding with a planet with people on it would be dangerous? This kind of indulgence is highly improbable. The only explanation that makes sense is that impact craters are formed at similar rates on Earth and the Moon. However, because there is no air or water on the Moon, the craters can remain intact for extremely long periods, whereas on Earth, slow erosion causes the craters to disappear or become filled in. The processes of running water, sand being blown by the wind, and the formation of mountains all take a very long time. However, they can completely remove even the most significant impact scars throughout millions or even billions of years. There will be fast, catastrophic events such as volcanic explosions and processes of excruciating slowness, such as the pitting of a surface by tiny airborne sand grains. These processes will occur on the surface of any moon or planet. It is impossible to provide a definitive response to the question of which processes predominate. Those that take place on the outside or those that take place on the inside. Extraordinary but infrequent occurrences, or everyday but unremarkable ones. On the Moon, catastrophic events reign supreme, whereas slow processes rule the day on Earth. Mars is a case that falls somewhere in the middle. Numerous asteroids, essentially miniature terrestrial planets, can be found in the region between the orbits of Mars and Jupiter. The largest ones have a diameter of a few hundred kilometers. Many of them tumble through space and have shapes that resemble long rectangles. It would appear that at least 2 asteroids are traveling in close orbit around one another in certain instances. A meteorite is a rock created when an object in space, known as an asteroid, collides with another asteroid and breaks apart, sending fragments hurtling through space before hitting the surface of the Earth. Fragments of other worlds can be displayed as artifacts and art in our museums. The asteroid belt is like a giant grinding mill, producing ever-increasingly smaller pieces down to dust particles. The more substantial chunks of asteroids and comets are primarily to blame for the recent craters that have appeared on the surfaces of planets. The asteroid belt may be the shattered remnants of a planet that blew itself up, or it may have been a location in the past, where the gravitational tides of the nearby giant Jupiter prevented the formation of a planet at that location. Both of these possibilities are possible. This seems unlikely because no scientist on Earth knows a mechanism by which a planet could destroy itself, which is probably for the best. The rings of Saturn have been compared to the asteroid belt because of the vast number of extremely small the remains of a moon that strayed too close to Saturn and was ripped apart by the gravitational tides. Or they could be debris that was prevented by Saturn's gravity from accreting into a nearby moon. Either way, they could be interesting. Alternately, they may result from a stable equilibrium between the material that is ejected from one of Saturn's moons, such as Titan, and the material that falls into the planet's atmosphere. The ring systems of Jupiter and Uranus were discovered not too long ago, and are so distant from Earth that we can barely see them. The question of whether or not Neptune possesses a ring is very important to planetary scientists. There is a possibility that planets of the Jupiter type all over the cosmos will have rings surrounding them. An influential book titled Worlds in Collision was written by a psychiatrist named Emanuel Velikovsky and first released in 1950. The book claims that major recent collisions have occurred between Saturn and Venus. He hypothesized that the Jupiter system was responsible for forming an object with the mass of a planet that he referred to as a comet. Around 3,500 years ago, it careened in towards the inner solar system and made repeated encounters with the Earth and Mars. As a result of these encounters, the Red Sea parted, Moses and the Israelites were able to flee from Pharaoh, and Joshua was able to stop the Earth from rotating on command. All of these events are considered to be coincidental events. According to him, it was also the cause of widespread volcanism and flooding. Velikovsky imagined that after a difficult game of interplanetary billiards, the comet would eventually settle down into a stable, nearly circular orbit, eventually becoming the planet Venus, which he claimed had never existed before that time. These ideas are almost certainly incorrect, as I have discussed in some other places in greater detail. Astronomers do not take issue with the concept of major collisions. Rather, they take issue with major collisions that have occurred recently. Because of this, no solar system model can show the planets' sizes on the same scale as their orbits. If this were done, the planets would be so small that they would be difficult to see. If the planets were shown to scale as dust grains, it would be easy to see that the probability of a specific comet colliding with Earth within the next few thousand years is extremely low. This would be the case because the planets would be shown to scale as dust grains. In addition, Venus is a rocky and metallic planet with very little hydrogen, whereas Jupiter, where Velikovsky believed it originated, is almost entirely composed of hydrogen. There are no sources of energy for Jupiter to use in its process of ejecting comets or planets from its system. If one were to pass by the Earth, one would not be able to stop the rotation of the Earth, much less begin it again at the appropriate rate of 24 hours per day. No evidence from geology supports the idea that there was an unusually high frequency of volcanic activity or floods 3,500 years ago. Inscriptions found in Mesopotamia that reference Venus date back to a time before Velikovsky's contention that Venus transitioned from the status of a comet to that of a planet. It is improbable that an object that was previously traveling in a highly elliptical orbit could have been rapidly moved into the nearly perfectly circular orbit of modern-day Venus. And this goes on. It turns out that many hypotheses, both those put forward by scientists and those put forward by non-scientists, are incorrect. However, the scientific method is capable of correcting its own errors. To be considered, novel concepts need to conform to stringent evidence requirements. The most upsetting aspect of the Velikovsky affair is not that his hypotheses were incorrect or ran counter to well-established facts. Rather, the most upsetting aspect is that some individuals who called themselves scientists attempted to suppress Velikovsky's work. The scientific method is based on the principle of free inquiry, which holds that every hypothesis should be evaluated based on its merits regardless of how outlandish it may seem. Suppressing unsettling ideas may be a common practice in religion and politics, but it is not the way to knowledge and has no place in pursuing scientific knowledge. There is no way to predict who will come up. Venus is almost identical to the Earth in terms of its mass, size, and density. Since it is the planet closest to Earth, people have considered it as Earth's sister for centuries. What is the nature of the planet that is our sister? It may enjoy a balmy summer climate, slightly warmer than Earth due to its proximity to the Sun. Does it still have impact craters, or have they been completely worn away by erosion? Is there a volcano nearby? Surely, you jest. The oceans, life. In 1609, Galileo was the first to look through a telescope and observe Venus. He saw a disk that had no distinguishing characteristics whatsoever. We are sometimes looking mostly at the night side of Venus and sometimes at the day side, a finding that incidentally reinforced the view that the Earth went around the Sun, and not vice versa. Galileo observed that it went through phases, similar to the Moon, from a thin crescent to a full disk, and for the same reason we are sometimes looking mostly at the night side of Venus, and sometimes mostly at the day side. As optical telescopes grew in size and resolution, their capacity to differentiate between fine details increased. Scientists began systematically pointing them in the direction of Venus. However, their results were not any more accurate than Galileo's. At first glance, Venus appeared shrouded in a thick blanket of opaque clouds. When we look at the planet during the early morning or late evening hours, we see the sunlight reflected off Venus's clouds. However, despite their discovery hundreds of years ago, the makeup of those clouds remained a complete mystery for centuries. As a result of the dearth of visible features on Venus, several researchers came to the intriguing conclusion that the planet's surface was a swamp, just like it was during the Carboniferous period on Earth. If we may use such a word to describe what transpired, the debate went something like this. I can't see anything on Venus. Why is that? Because there is a complete blanket of clouds over it. What exactly is it that clouds are made of? Water, of course, she replied. If this is the case, why are the clouds on Venus so much thicker than those on Earth? The answer is that there is more water on Venus. However, if there is more water in the clouds, more water must be on the surface. What kinds of ground are considered to be very wet? Wetlands, swamps. And if there are swamps, why not cycads, dragonflies, and even dinosaurs on Venus? The featureless clouds of Venus reflected our own predispositions. We are alive, and we resonate with the idea of life elsewhere. However, only careful accumulation and assessment of the evidence can tell us whether or not a given world is inhabited. The first real clue to the nature of Venus came from work with a prism made of glass or a flat surface, called a diffraction grating, covered with fine, regularly spaced, ruled lines. When an intense beam of ordinary white light passes through a narrow slit and then through a prism or grating, it is spread into a rainbow of colors called a spectrum. The spectrum runs from high frequencies of visible light to low ones: violet, blue, green, yellow, orange, and red. Since we see these colors, it is called the visible light spectrum. But we can see far more light than the small spectrum segment. At higher frequencies, beyond the violet, is a part of the spectrum called the ultraviolet, a perfectly real kind of light that carries death to the microbes. It is invisible to us but readily detectable by bumblebees and photoelectric cells. There is much more to the world than we can see. Beyond the ultraviolet is the X-ray part of the spectrum, and beyond the X-rays are the gamma rays. At lower frequencies on the other side of red is the infrared part of the spectrum. It was first discovered by placing a sensitive thermometer in what, to our eyes, is the dark beyond the red. The temperature rose. The light was falling on the thermometer, even though it was invisible to our eyes. Rattlesnakes and doped semiconductors detect infrared radiation perfectly well. Beyond the infrared is the vast spectral region of radio waves. From gamma rays to radio waves, all are equally respectable light brands. All are useful in astronomy. But because of the limitations of our eyes, we have a prejudice, a bias, towards that tiny rainbow band we call the spectrum of visible light. In 1844, the philosopher Auguste Comte searched for an composition of distant stars and planets. He thought we would never physically visit them, and with no sample in hand, it seemed we would forever be denied knowledge of their composition. But only 3 years after Comte's death, it was discovered that a spectrum could be used to determine the chemistry of distant objects. Different molecules and chemical elements absorb different frequencies or colors of light, sometimes in the visible spectrum and elsewhere. In the spectrum of a planetary atmosphere, a single dark line represents an image of the slit in which light is missing, the absorption of sunlight during its brief passage through the air of another world. Each such line is made of a particular kind of molecule or atom. Every substance has its own characteristic spectral signature. The gases on Venus can be identified from the Earth 60 million kilometers away. We can divine the composition of the Sun, in which helium, named after the Greek sun god Helios, was first found. Of magnetic stars rich in europium, and of distant galaxies through the collective light of 100 billion constituent stars. Astronomical spectroscopy is an almost magical technique. It still amazes me. Auguste Comte picked a particularly unfortunate example. If Venus were soaking wet, it should be easy to see the water vapor lines in its spectrum. But the first spectroscopic searches attempted at Mount Wilson Observatory around 1920 found no hint or trace of water vapor above the clouds of Venus, suggesting an arid, desert-like surface surmounted by clouds of fine, drifting silicate dust. Further study revealed enormous quantities of carbon dioxide in the atmosphere, implying to some scientists that all the water on the planet had combined with hydrocarbons to form carbon dioxide, and that, therefore, the surface of Venus was a global oil field, a planet-wide sea of petroleum. Others concluded that there was no water vapor above the clouds because the clouds were very cold, and all the water had condensed out into water droplets, which do not have the same pattern of spectral lines as water vapor. They suggested that the planet was covered with water, except perhaps for an occasional limestone-encrusted island, like the cliffs of Dover. But because of the vast quantities of carbon dioxide in the atmosphere, the sea could not be ordinary water. Physical chemistry required carbonated water. Venus, they proposed, had a vast ocean of seltzer. The first hint of the true situation came not from spectroscopic studies in the visible or near-infrared parts of the spectrum, but rather from the radio region. A radio telescope works more like a light meter than a camera. You point it towards some fairly broad region of the sky, and it records how much energy at a particular radio frequency is coming down to Earth. We are used to radio signals transmitted by some varieties of intelligent life, namely, those who run radio and television stations. But there are many other reasons for natural objects to give off radio waves. One is that they are hot. And when, in 1956, an early radio telescope was turned towards Venus, it was discovered to be emitting radio waves as if it were at an extremely high temperature. But the real demonstration that the surface of Venus is astonishingly hot came when the Soviet spacecraft of the Venera series first penetrated the obscuring clouds and landed on the mysterious and inaccessible surface of the nearest planet. Venus, it turns out, is broiling hot. There are no swamps, no oil fields, and no seltzer oceans. With insufficient data, it is easy to go wrong. When I greet a friend, I see her in reflected visible light generated by the sun or an incandescent lamp. The light rays bounce off my friend and into my eye. But the ancients, including no less a figure than Euclid, believed that we see by rays somehow emitted by the eye and tangibly actively contacting the object observed. This is a natural notion and can still be encountered, although it does not account for the invisibility of objects in a darkened room. Today, we combine a laser and a photocell, or a radar transmitter and a radio telescope. In this way, we make active contact by light with distant objects. In radar astronomy, radio waves are transmitted by a telescope on Earth. Strike, say, that hemisphere of Venus that happens to be facing the Earth, and bounce back. At many wavelengths, the clouds and atmosphere of Venus are entirely surface will absorb them, or, if very rough, will scatter them sideways, appearing dark to radio waves. By following the surface features moving with Venus as it rotates, it was possible for the first time to reliably determine the length of its day, how long it takes Venus to spin once on its axis. It turns out that, concerning the stars, Venus turns once every 243 Earth days, but backwards, in the opposite direction from all other planets in the inner solar system. As a result, the sun rises in the west and sets in the east, taking 118 Earth days from sunrise to sunset. Moreover, it presents almost exactly the same face to the Earth each time it is closest to our planet. However, since the Earth's gravity has managed to nudge Venus into this Earth-locked rotation rate, it cannot have happened rapidly. Venus could not be a mere few thousand years old. Rather, it must be as old as all the other objects in the inner solar system. There are just as many craters, not too big or too small, on Venus as in the lunar highlands, so many that Venus is again telling us that it is very old. However, the craters of Venus are remarkably shallow, almost as if the high surface temperatures have resulted in the formation of lava flows rather than craters. This suggests that Venus may have been formed by a collision between two smaller bodies. The surface temperatures on Venus are approximately 400 meton or 900 Celsius, which is hotter than the hottest household oven. The corresponding surface pressure is 90 atmospheres, which is 90 times the pressure we feel from the Earth's atmosphere, and is equivalent to the weight of water 1 kilometer below the surface of the oceans. To survive for an extended period on Venus, a space vehicle would need to be refrigerated and built like a pressure cooker. Let us follow in the footsteps of these pioneering missions and travel to another world. Roughly a dozen spacecraft from the United States and the Soviet Union have broken through the clouds and entered the dense atmosphere of Venus. Some of these spacecraft have survived for up to an hour or so on the surface of Venus. 2 spacecraft from the Soviet Venera series have taken pictures down there. If the cameras look in the ultraviolet, however, we see a graceful, complex, swirling weather system in the high atmosphere. Where the winds are around 100 meters per second, or about 220 miles per hour. The atmosphere of Venus is composed of 96% carbon dioxide. Small traces of nitrogen, water vapor, argon, and helium exist. Galileo was the first person to note that the clouds of Venus show virtually no features at all. In the lower atmosphere, the odorous gas sulfur dioxide, SSO2, is present in trace amounts. It is circulated above the clouds, broken down by ultraviolet light from the sun, and recycled. At about 70 kilometers of altitude, there is a continuous haze of small particles. At 60 kilometers, we plunge into the clouds and find ourselves surrounded by droplets of concentrated sulfuric acid. There is no dust, no clouds, just an atmosphere getting palpably denser. The sulfur-colored M-mist extends downward to some 45 kilometers above the surface of Venus, where we emerge into a dense but crystal-clear atmosphere. However, the atmospheric pressure is so high that we cannot see the surface of Venus. With sweltering temperatures, crushing pressures, toxic gases, and everything bathed in an eerie, reddish glow, Venus seems less like the goddess of love and more like the incarnation of hell. The hostile, barren landscape is relieved only here and there by the eroded remnants of a derelict spacecraft from a distant planet, which are completely invisible through the thick, cloudy, poisonous atmosphere. Venus is a kind of planet-wide catastrophe. It is now reasonably clear that the high surface temperature is brought about by a massive greenhouse effect. Sunlight passes through the atmosphere and clouds of Venus, which are semi-transparent to visible light, and reaches the surface. Spectrum. However, the carbon dioxide and water vapor in the atmosphere of Venus are almost perfectly opaque to infrared radiation. As a result, the sun's heat is effectively trapped, and the surface temperature rises. This continues until the small amount of infrared radiation that trickles out of this massive atmosphere balances the amount of sunlight absorbed in the lower atmosphere and on the surface. Many mythical heroes in Greek and Norse mythology made celebrated efforts to visit hell. A great deal can also be learned about our planet, which is a comparative heaven, by comparing it to hell. However, we will return to Venus because it is fascinating. Half human and half lion, was built over 5,500 years ago. Its face was once crisp and cleanly rendered. It is now softer and blurrier due to thousands of years of sandblasting in the Egyptian desert and occasional rains. There is an obelisk in New York City called Cleopatra's Needle, which originated in Egypt. In only about 100 years in that city's Central Park, its inscriptions have perhaps 100,000, and large-scale human artifacts only a few thousand. In addition to such slow and uniform erosion, destruction can also occur through large and small catastrophes. The Sphinx is missing a nose because someone shot it off in a moment of idle desecration. Some say it was Mameluke Turks, and others say it was Napoleonic soldiers. On Venus, on Earth, and elsewhere in the solar system, there is evidence for catastrophic destruction, tempered or overwhelmed by slower, more uniform processes. On the Earth, for example, rainfall coursing into rivulets, streams, and rivers of running water, creating huge alluvial basins. On Mars, the remnants of ancient rivers, perhaps arising from beneath the ground. On Io, a moon of Jupiter, what seem to be broad channels made by flowing liquid sulfur. There are mighty weather systems on the Earth, in the high atmosphere of Venus and on Jupiter. There are sandstorms on Earth and Mars, and lightning on Jupiter, Venus, and Earth. Volcanoes inject debris into the atmospheres of the Earth and Jupiter. Internal geological processes slowly deform the surfaces of Venus, Mars, Ganymede, Europa, and Earth. Glaciers, proverbial for their slowness, produce major reworkings of landscapes on Earth and probably also on Mars. These processes need not be constant over time. Most of Europe was once covered with ice. A few million years ago, the present site of the city of Chicago was buried under 3 kilometers of frost. On Mars and elsewhere in the solar system, we see features that could not be produced today. Landscapes carved hundreds of millions or billions of years ago when the planetary climate was probably very different. An additional factor that can alter Earth's landscape and climate is that intelligent life can make major environmental changes. Like Venus, the Earth has a greenhouse effect due to its carbon dioxide and water vapor. Earth's global temperature would be below the freezing point of water if not for the greenhouse effect. It keeps the oceans liquid and life possible. A little greenhouse is a good thing. Like Venus, the Earth also has about 90 atmospheric carbon dioxide, but it resides in the crust as limestone and other carbonates, not in the atmosphere. If the Earth were moved only a little closer to the Sun, the temperature would increase slightly. This would drive some of the CO2 out of the surface rocks, generating a stronger greenhouse effect which would, in turn, incrementally heat the surface further. A hotter surface would vaporize still more carbonates into CO2, and there would be the possibility of a runaway greenhouse effect at very high temperatures. This is just what we think happened in the early history of Venus because of Venus's proximity to the Sun. The surface environment of Venus is a warning. Something disastrous can happen to a planet rather than our own. The so-called fossil fuels are the primary energy sources for our modern industrial civilization. When we burn wood, oil, coal, and natural gas, we release waste gases, primarily carbon dioxide, into the air. As a result, the amount of carbon dioxide in the Earth's atmosphere is dramatically increasing. The possibility of a runaway greenhouse effect suggests we must be cautious. Even a 1 or 2 degree rise in the global temperature can have catastrophic consequences. But we have also been oppositely changing the climate. Humans have been torching and cutting down forests and encouraging domestic animals to graze on and destroy grasslands for thousands of years. Today, slash-and-burn agriculture, industrial tropical deforestation and overgrazing are commonplace. However, forests are darker than grasslands, and grasslands are darker than deserts. As a result, the amount of sunlight absorbed by the ground has increased. Our lovely blue planet, the Earth, is the only home we know. Venus is too hot, Mars is too cold, but the Earth is just right, a heaven for humans. After all, we evolved here. But our congenial climate may be unstable. We are perturbing our poor planet in serious and contradictory ways. We humans now represent a new and perhaps decisive factor. Our intelligence and technology have given us the power to affect the climate. How will we use this power? Are we willing to tolerate ignorance and complacency in matters that affect the entire human family? Do we value short-term gains over long-term sustainability? The cosmos is all there is. Everything that has ever been and will ever be. The cosmos is all there is, everything that has ever been and will ever be. Even our most feeble attempts to contemplate the cosmos are enough to make us feel a tingling in the spine, a catch in the voice, and a faint sensation, almost as if it were a distant memory of falling from a great height. We know that we are getting closer to solving the most perplexing puzzles. The age of the universe and the magnitude of its age are both incomprehensible to the average human being. Our tiny planetary home is probably misplaced between space's vastness and time's eternity. Most human concerns appear insignificant and even trivial from the cosmos perspective. Despite this, our species is still young, full of wonder and bravery, and possesses great potential. Over the past few millennia, we have made some of the most astounding and unanticipated discoveries about the cosmos and our place within it. These discoveries are exhilarating explorations to consider. They serve as a reminder that humans have an innate capacity for wonder, that understanding something brings joy, and that knowledge is essential to survival. I believe our future will be determined by how well we understand this vast universe in which we float around like a speck of dust in the morning sky. These kinds of investigations required a healthy dose of skepticism and creative thinking. Imagination can frequently transport us to worlds that never actually existed. But we won't get very far if we don't have it. We can differentiate fantasy from reality and put our hypotheses to the test when we exercise skepticism. The universe possesses an immeasurable amount of richness, which can be broken down into three categories: exquisite interrelationships, exquisite facts, and the subtle machinery of awe. The shoreline of the infinite cosmic ocean is found on the surface of the Earth. The vast majority of our knowledge came from our experiences with it. Over the past few days, we have ventured out into the ocean just far enough to get our toes, or, at the very most, our ankles wet. It looks like a refreshing place to swim. The call of the ocean. Some component of our being is aware that this is where we originated. We can't wait to get back there. These aspirations are not disrespectful, even though they may upset existing gods, because the dimensions of the cosmos are so vast, utilizing standard units of distance, such as meters or miles, that were chosen for their applicability on Earth would not make much sense. Instead, we use the speed of light as our unit of measurement for distance. A single second is long enough for a beam of light to travel 186,000 miles, close to 300,000 kilometers, and equivalent to 7 times around the Earth. It will arrive at its destination on Earth 8 minutes after leaving the Sun. We can say that the Sun will be visible in 8 minutes. In just 1 year, it travels a distance equivalent to approximately 6 trillion miles or nearly 10 trillion kilometers through the intervening space. A light year is a unit of length that measures the distance light travels in 1 year. It does not measure time, but rather distances, extremely large distances. The planet Earth is a location. It is not even close to being the only location. Even by today's standards, it is not a typical place, because most of space in the universe is devoid of matter. There is no such thing as a typical planet, star, or galaxy. Planets, stars, and galaxies appear heartbreakingly rare and beautiful compared to the vast freezing vacuum of the universal space that makes up intergalactic space. This is the only place to be described as normal and the only place in the universe. The probability of our discovering life elsewhere in the universe, if we were to be hurled into space at random, the likelihood of us being on or near another planet, is less than 1 in a billion trillion trillion, 10 to the power of 33, which is a 1 followed by 33 zeros. In normal conversation, the odds at this level are called compelling. There is great value in the world. From a perspective that spans galaxies, we can see an infinite number of flimsy, wispy light tendrils dispersed throughout space like sea foam on the surface of the waves. These are the galaxies in the universe. Some are lone explorers, but most live in communal clusters, huddling together while drifting aimlessly through the vast cosmic darkness. In front of us is the cosmic on the largest scale we are familiar with. We are 8 billion light-years away from Earth, in the region of the nebulae. And our galaxy is made up of gas, dust, and stars, with billions and billions of stars making up its composition. Someone, somewhere, could view any star as their sun. A galaxy contains not only stars and worlds, but also, it's possible, an abundance of living things, intelligent beings, and spacefaring civilizations. However, when viewed from a great distance, a galaxy brings to mind more of a collection of lovely objects that have been found, perhaps seashells or corals, which are the results of nature's labor over aeons of time in the cosmic ocean. There are approximately 100 billion galaxies, and each galaxy contains approximately 100 billion stars on average. There may be as many planets in the universe as stars. 10 to the power of 11 times 10 to the power of 11 equals 10 to the power of 22, which is 10 billion trillion. In the face of such overwhelming numbers, how likely is it that there is only one typical star, the Sun, accompanied by an ordinary planet that people live on? Why should we, tucked away in some obscure part of the universe, be so lucky? There seems to be much more likely to be life throughout the universe. However, we as humans do not yet have this knowledge. The exploration that we are conducting has just started. Even the cluster in which our Milky Way galaxy is embedded is difficult to find from this distance, much less the Sun or Earth. This distance is equivalent to 8 billion light-years. At this great distance, the only planet we can be certain that life exists is a tiny speck of rock and metal that glimmers feebly in the sunlight reflected off it. But for the time being, our travels have brought us to what astronomers here on Earth call the neighborhood group of galaxies. It spans a distance of several million light-years and comprises approximately 20 galaxies that make up its component parts. It is a dispersed, obscure, and unassuming collection of objects. M31 is one of these galaxies, and it can be found in the Andromeda constellation when viewed from Earth. Like other spiral galaxies, it comprises stars, gas, and dust in a pinwheel-like pattern. M31 has two smaller satellites that are dwarf elliptical galaxies that are gravitationally bound to it. This same law of physics tends to keep me seated in my chair. The natural laws do not change no matter where you go in the universe. We are currently 2 million light-years away from home at this point. In the region beyond M31 is another galaxy that is very comparable to our own. The spiral arms of this galaxy turn very slowly, once every 250 million years. Now, after traveling 40,000 light-years away from our home, we find that we are moving closer and closer to the immense center of the Milky Way. But if we want to find Earth, we must change our course to the galaxy's far reaches, to an obscure location close to the edge of a faraway spiral arm. Only then will we be able to locate the planet. Even in the middle of the spiral arms, the overwhelming sensation is of stars moving past us. These stars come in all shapes and sizes. Some are as flimsy as a soap bubble, but are so large that they could contain 10,000 suns or 1 trillion Earths. Others are the size of a small town, but are 100 trillion times denser than lead. Some stars, like the Sun, are on their own. The vast majority are accompanied. Double star systems are quite common and consist of 2 stars orbiting each other. However, there is a gradual progression from triple star systems to loose clusters of a few dozen stars to enormous globular clusters, resplendent, with 1 million suns. This progression can be seen as a continuous gradation. Some binary stars are so close to one another that their surfaces touch, allowing material from both stars to flow between them. Most are located at a distance comparable to Jupiter's from the Sun. While some stars known as supernovae shine brighter than the entire galaxy in which they are located, others, known as black holes, are so dark that they cannot even be seen from a distance of a few kilometers. Some have a steady, bright glow, while others flicker erratically or blink in a steady, predictable pattern. Some turn with stately elegance, while others spin with such ferocity that they become oblate due to their distorted shape. Most radiate most of their light in the visible and infrared spectrums, while others are brilliant sources of X-rays or radio waves. If a star is blue, it is energetic and young. If it is yellow, it is average and in the middle of its life. If it is red, it is likely old and on its deathbed. And if it is white or black, about 400 billion stars of varying types are contained within the Milky Way, which moves in a complex yet graceful order. The people who live on Earth are only aware of one of the myriad stars in the universe. Each star system occupies its distinct space region, separated from its surrounding regions by light years. I can picture life forms evolving into glimmers of knowledge on an infinite number of worlds, with each of those life forms at first supposing that their meager planet and its few suns are the only things in the universe. We have a very solitary upbringing. We are only just beginning to educate ourselves about the cosmos. There is a possibility that some stars are surrounded by millions of lifeless and rocky worlds. These worlds are planetary systems, frozen at an early stage in their evolution. Many stars may have planetary systems very similar to ours. At the periphery, large gaseous planets with rings and icy moons, and closer to the center, small, warm, blue-white worlds covered in cloud cover. Intelligent life may have developed on some planets, and as part of their massive engineering projects, they may have reworked the planet's surface. These are our planetary kin and the other inhabitants of the cosmos. Are there significant differences between us and them? Which of the following best describes their mode of expression? Biochemistry, neurobiology, history, politics, science, technology, art, music, religion, or philosophy. Perhaps one day we will be able to call them friends. 1 light-year away from Earth, we finally arrived at our backyard. The cometary nuclei are a spherical swarm of giant snowballs composed of ice, rock, and organic molecules. They orbit our sun. One of them obligingly careens into the inner solar system occasionally in response to a small gravitational tug given by a passing star. There, the sun's warmth melts the ice, which in turn causes the formation of a beautiful cometary tail. When we think of the planets in our solar system, we think of them as large worlds dominated by the sun that are gravitationally forced to travel in nearly circular orbits and get their heat primarily from the sun. Pluto is illuminated by a distant sun, which appears as nothing more than a bright point of light in an otherwise pitch-black sky. Pluto is covered with methane ice and accompanied by its lone giant moon, Charon. Jupiter, Neptune, Uranus, and Saturn, considered the crown jewel of the solar system, all have a retinue of icy moons orbiting around them. The gassy planets and orbiting icebergs are located on the region's periphery, containing the inner solar system's warm, rocky provinces. There is, for instance, the red planet Mars, known for its towering volcanoes, enormous rift valleys, massive sandstorms covering the entire planet, and the remote possibility that it harbors some simple forms of life. The Sun is the closest star to our solar system. It is an immense ball of hydrogen and helium gas that is constantly undergoing thermonuclear reactions, which is what causes it to be the brightest object in our solar system. At last, after all of our wanderings, we return to our puny, fragile blue-white world, which is adrift in a vast cosmic ocean beyond our most audacious imaginations. It is one world among an infinite number of others that exist. It's possible that no one else cares about it but us. Our home and mother, the Earth, are here on this planet. This is the place where our kind of life began and where it developed. The human species is maturing in this part of the world. It was on this planet that we first discovered our enthusiasm for traveling throughout the cosmos, and it is still that we are figuring out our fate, even though it causes us some discomfort and offers no assurances. We want to take this opportunity to welcome you to Earth, a world positively teeming with life, with its blue nitrogen skies, oceans of liquid water, cool forests, and soft meadows. I have already mentioned that it is heartbreakingly beautiful and exceedingly uncommon. However, at this very moment, it is also one of a kind in the cosmos. It is the only world we have visited during our travels through space and time that has provided us with definitive evidence that the inanimate matter of the cosmos has developed consciousness and become alive. There must be many such worlds strewn across space, but our search for them begins here, with the accumulated knowledge of the males and females of our species, which was acquired at a great cost over 1 million years. We are extremely fortunate to live in a time and place that values the pursuit of knowledge, and to do so among exceptionally intelligent human race, which was ultimately created in the cosmos but is temporarily residing on a planet known as Earth, has started its long journey back to its origins. The discovery that the Earth is a miniature world was made, like so many other significant discoveries made by humans, in the ancient Near East, in a time that some humans call the 3rd century BC, in the greatest metropolis of the age, the Egyptian city of Alexandria. This discovery was made in the ancient Near East, as were so many other significant discoveries made by humans. A man who went by the name Eratosthenes lived in this location. One of his contemporaries, who was green with envy, referred to him as Beta, the second letter of the Greek alphabet, because he believed that Eratosthenes was the second best of everything in the world. Eratosthenes was an astronomer, historian, geographer, philosopher, poet, theatre critic, and mathematician. The titles of the books he wrote range from astronomy to On Freedom from Pain. He was also the director of the Great Library of Alexandria, where one day he read in a papyrus book that in the southern frontier outpost of Syene, near the first cataract of the Nile at noon on June 21st, vertical sticks cast a shadow on the ground. Eratosthenes was a scientist, and his musings on these commonplaces changed the world. In a way, they made it. It was an observation that someone else might have easily ignored. Sticks, shadows, reflections in wells, and the position of the sun. What possible importance could such simple, everyday matters be? But Eratosthenes was a scientist, and his musings on these commonplaces changed the world. In a way, they made the Eratosthenes puzzled over how, at the same moment, a stick in Syene could cast no shadow, while a stick in Alexandria, far to the north, could cast a pronounced shadow. Imagine a map of ancient Egypt with two vertical sticks of equal length, one stuck in Alexandria and the other in Syene. Suppose that, at a certain moment, each stick casts no shadow at all. This is easy to understand if the Earth is flat, because the sun would be directly overhead. Because the sun is so far away, its rays are parallel when they reach the Earth. Sticks placed at different angles to the sun's rays cast shadows of different lengths. To account for the observed difference in the lengths of the shadows, the distance between Alexandria and Syene would have to be approximately 7 degrees along the Earth's surface. This is the correct response. Eratosthenes' only tools were sticks, eyes, feet, and brains, in addition to a taste for experimentation. With them, he deduced the circumference of the Earth with an error of only a few percent, which was a remarkable achievement for 2,200 years ago. He was the first person to accurately measure the size of a planet. At that time, the Mediterranean world was renowned for its seafaring, and Alexandria was considered the greatest seaport on the planet. Once you knew the Earth to be a sphere of modest diameter, would you not be tempted to make voyages of exploration, to seek out undiscovered lands, perhaps even to attempt to sail around the planet? Africa had already been circumnavigated by a Phoenician fleet in the employ of the Egyptian pharaoh Necho, 400 years before Erato. After Eratosthenes' discovery, many brave and enterprising sailors attempted many voyages. Their ships were tiny. They had only rudimentary navigational instruments. They used dead reckoning and followed coastlines as far as they could. In an unknown ocean, they could determine their latitude, but not their longitude, by observing, night after night, the position of the constellations concerning the horizon. The familiar constellations must have been reassuring to them. In the time of Eratosthenes, globes were created that depicted the Earth as seen from space. These globes were accurate to a large extent in the well-explored Mediterranean region, but they became increasingly inaccurate the further away they traveled from home. Our current understanding of the cosmos also possesses this frustrating but unavoidable characteristic. Humans' exploration of other worlds began taking place in almost every significant sense. The subsequent exploration of the Earth was a worldwide endeavor that included voyages from... The culmination of this exploration was the discovery of America by Christopher Columbus, and the journeys of the subsequent few centuries, which completed the geographical exploration of the Earth. Columbus had been an itinerant peddler of old maps and an assiduous reader of the books by and about the ancient geographers, including Eratosthenes, Strabo, and Ptolemy. However, for the enterprise of the Indies to work and for ships and crews to survive the long voyage, the Earth had to be smaller than Eratosthenes had said. The Earth has been thoroughly explored and no longer holds the promise of any new continents or lost lands. However, the same technology that allowed us to explore and inhabit the most remote regions of the Earth now enables us to leave our planet, venture into space, and explore other worlds. It was in Alexandria during the 600 years beginning around 300 BC that human beings, in an important sense, began the intellectual adventure that has led us to the shores of space. However, nothing of the look and feel of that glorious marble city remains. Oppression and the fear of learning have obliterated almost all memory of ancient Alexandria. Its population was a marvelously diverse mix of Macedonian and later Roman soldiers, Egyptian priests, Greek aristocrats, and Pharaoh Alexander the Great established the city, and one of his former bodyguards was responsible for its construction. Alexander was known for promoting an open-minded attitude towards learning and respect for foreign cultures. According to legend, and it does not matter much whether it really happened, He descended beneath the Red Sea in the world's first diving bell. He encouraged his generals and soldiers to marry Persian and Indian women. He respected the gods of other nations. He collected exotic life forms, including crocodiles. But the greatest marvel of Alexandria was the library and its associated museum, literally an institution devoted to the specialities of the 9 muses. Of that legendary library, the most that survives today is a dank and forgotten cellar of the Serapeum, the library annex, once a temple and later reconsecrated to knowledge. A few mouldering shelves may be the only physical remains. Yet this place was once the brain and glory of the greatest city on the planet, the first true research institute in the history of the world. The scholars of the library studied the entire cosmos. Cosmos is a Greek word for the order of the universe. It is, in a way, the opposite of chaos. It implies the deep interconnectedness of all things. It conveys awe for the intricate and subtle way the universe is assembled. Here was a community of scholars exploring physics, literature, medicine, astronomy, geography, philosophy, mathematics, biology, and engineering. Science and scholarship had come of age. Genius flourished there. The Alexandrian Library is where we humans first collected, seriously and systematically, world knowledge. In addition to Eratosthenes, there was the astronomer Hipparchus, who mapped the constellations and estimated the brightness of the stars. Euclid, who brilliantly systematized geometry and told his king, struggling over a difficult mathematical problem, there is no royal road to geometry. Dionysius of Thrace, the man who defined the parts of speech and did for the study of language what Euclid did for geometry. Herophilus, the physiologist who firmly established that the brain, rather than the heart, is the seat of intelligence. Heron of Alexandria, inventor of gear trains and steam engines and the author of Automata, the first book on robots. Apollonius of Perga, the mathematician who demonstrated the forms of the conic sections. Ellipse, parabola, and hyperbola. The curves, as we now know, followed in their orbits by the planets, the comets, and the stars. Archimedes, the greatest mechanical genius until Leonardo da Vinci. And the astronomer and geographer Ptolemy, who compiled much of what is today the pseudoscience of astrology. His Earth-centered universe held sway for 2,500 years, a reminder that intellectual capacity is no guarantee against being dead wrong. And among those great men was a great woman, Hypatia, mathematician and astronomer, the last light of the library, whose martyrdom was bound up with the destruction of the library 7 centuries after its founding, a story to which we will return. The Greek kings of Egypt who succeeded Alexander were serious about learning. For centuries they supported research and maintained in the library a working environment. The library contained 10 large research halls, each devoted to a separate subject. It also contained fountains and colonnades, botanical gardens, a zoo, dissecting rooms, an observatory, and a great dining hall where, at leisure, the critical discussion of ideas was conducted. The heart of the library was its collection of books. The organizers combed through all the cultures and languages of the world. They sent agents abroad to buy up libraries. Commercial ships docking in Alexandria were searched by the police, not for contraband but for books. The scrolls were borrowed, copied, and then returned to their owners. Accurate numbers are difficult to estimate, but it seems probable that the library contained 500,000 volumes, each a handwritten papyrus scroll. What happened to all those books? The classical civilization that created them disintegrated, and the library was deliberately destroyed. Only a small fraction of its works and a few scattered fragments survived. And how tantalizing those bits and pieces are. We know, for example, that there was on the library shelves a book by the astronomer Aristarchus of Samos, who argued that the Earth is one of the planets, which, like them, orbit the Sun, and that the stars are enormously far away. These conclusions are correct, but we had to wait nearly 2,000 years for their rediscovery. If we multiply by 100,000 our sense of loss for this work of Aristarchus, we begin to appreciate the grandeur of the achievement of classical civilization and the tragedy of its destruction. We have far surpassed the science known to the ancient world. But there are irreparable gaps in our historical knowledge. Imagine what mysteries about our past could be solved with a borrower's card to the Alexandrian library. We know of a 3-volume history of the world, now lost, by a Babylonian priest named Berossus. The first volume dealt with the interval from creation to the flood, a period he took to be 432,000 years, or about 100 times longer than the Old Testament chronology. I wonder what was in it. We now know that the universe is much older than the ancients ever imagined. We have looked at the universe from space and seen that we live on a mote of dust circling a humdrum star in the remotest corner of an obscure galaxy. And if we are a speck in the immensity of space, we also occupy an instant in the expanse of the ages. And until we find more intelligent beings elsewhere, we are the most spectacular of all the transformations. We are the distant descendants of the Big Bang, and are dedicated to understanding and further transforming the cosmos, where we spring from. For the entirety of my life, I have been curious about whether or not there is life on other planets. What kind of an experience would it be? What would it be composed of exactly? Organic molecules, which are intricate microscopic structures held together by the carbon atom, are the building blocks of everything living on this planet. Before life existed on Earth, the planet was sterile and devoid of civilization. The world we live in is currently teeming with life. What was the reason behind it? How did carbon-based organic molecules come when there was no life to create them? How did the first organisms come into existence? How did life evolve to produce beings as elaborate and complex as us, capable of investigating the mystery of our origins? And finally, if there are infinite planets that orbit other suns, does life exist on any of them? If life exists elsewhere in the universe, does it consist of the same kinds of organic molecules as life here on Earth? Do the inhabitants of other worlds resemble the life on Earth in any significant way? Or are they astonishingly distinct, representing other adaptations that have evolved in response to other environments? What other possibilities are there? The investigation into the origins of life on Earth and the search for life in other worlds are two facets of the same question. The investigation into the nature of who we are. There are clouds of gas, dust, and organic matter that are located in the vast darkness that exists between the stars. Radio telescopes have discovered dozens of organic molecules in that region. The prevalence of these molecules provides evidence that the components necessary for life can be found anywhere. If enough time passes, life's beginnings and subsequent development may be a cosmic inevitability. There won't ever be life on some of the billions of planets that make up the Milky Way galaxy. It might appear briefly on other worlds before vanishing or never progressing beyond its basic forms. Additionally, on a relatively small percentage of worlds, there might be civilizations and intelligence that one will occasionally remark about how fortunate it is that the Earth has conditions ideal for life, such as temperatures that are just right, water that can be liquidized, an oxygen-rich atmosphere, and so on. But here we have a case of confusing the cause with the effect, at least in part. Because we evolved on this planet, we are extraordinarily well suited to the natural conditions that we find ourselves in. Earlier forms of life that were not well adapted to their environments perished. We are descended from organisms that were successful in their environments. There is no doubt that organisms that evolve in very different worlds will also sing praises to this world. There is a connection between all forms of life on Earth. Both our organic chemistry and our evolutionary history are shared between all of us. Consequently, the scope of our biologists' work could be more robust. They only focus on one branch of biology, like focusing on one note in an otherwise complex piece of music. Is this ethereal and breathy melody the only sound for thousands of light years? Or could there be something akin to a cosmic fugue, complete with recurring motifs and counterpoints, dissonances and harmonies, and a billion distinct voices, all contributing to the life music of the galaxy? Please permit me to regale you with a tale concerning a tinier phrase from the song that is life on Earth. In 1185, the Emperor of Japan was a young boy named Antoku. He was only 7 years old. He was the de facto leader of a samurai clan known as the Heike, who were at war with another samurai clan known as the Genji. This conflict lasted for a long time and was very bloody. Each one argued that they had a more legitimate ancestral right to the throne of the imperial empire. On April 24, 1185, their decisive naval encounter occurred at Dano-ura in the Japanese Inland Sea. The emperor was present on board one of the ships during the conflict. The Heikes were outmatched in terms of both numbers and strategic ability. Many people lost their lives. In large numbers, the survivors committed their own demise by jumping into the water and drowning themselves. Lady Ni, the emperor's grandmother, decided that she and Antoku would not be taken prisoner by the hostile forces. The following events are described in detail in the Tale of the Heike. In that year, the emperor was only 7 but appeared much older. He was so attractive that he gave off the impression of radiating a brilliant light, and his long black hair was styled in a way that allowed it to hang loosely all the way down his back. The question, "Where are you going to take me?" was posed to Lady Ni by the man, who wore a confused and anxious expression. She turned her attention to the young monarch with tears streaming down her cheeks, and consoled him while tying his long hair up in the robe that was the colour of a dove. The tears had clouded the child sovereign's vision, and he clasped his adorable little hands together. He began by facing east to bid farewell to the god of ice, and then he faced west to recite the Nembutsu, a prayer addressed to the Amida Buddha. After cradling him tightly in her arms, Lady Ni uttered, "In the depths of the ocean is our capital," and then dove beneath the water's surface with him. The entire battle fleet belonging to the Heike was wiped out. Only 43 women managed to make it out alive. These ladies-in-waiting of the imperial court were coerced into selling flowers and other favors to the fishermen in the area that was immediately surrounding the battlefield. The Heike came dangerously close to being forgotten by history. However, a ragtag group of the former ladies-in-waiting and their offspring among the fisherfolk established a festival to commemorate the battle. This festival was held in the fisherfolk community. April 24th comes around like clockwork every year to mark the occasion. Fishermen who are descendants of the Heike put on black hemp clothing and headgear and make their way to the Akama shrine. This shrine is home to the mausoleum of the emperor who was drowned. They watch a play that depicts the events after the Battle of Dano-ura while they are there. People believed they could see the ghosts of samurai armies attempting in vain to clean the sea of blood, defeat, and humiliation for centuries after the battle. According to the fishermen, the Heike samurai can still be found prowling the bottoms of the inland sea, but this time they are in the form of crabs. Crabs in this area have peculiar markings on their backs, including patterns and indentations that eerily resemble the face of a samurai. In remembrance of the tragic events at Dano-ura, these crabs are not consumed after they are caught. This rather presents a very interesting conundrum. How did it come to be that a crab's carapace has a warrior's face carved into it? Humans were responsible for creating the face. The patterns that appear on a crab's shell result from inheritance, but there are a lot of different hereditary lines among crabs, just like there are among people. Imagine that among the crab's remote ancestors, one evolved with a pattern that vaguely resembled a human face. This would be a remarkable coincidence. Even before the Battle of Dano-ura, it's possible that fishermen were hesitant to eat such a crab because of its reputation. They kicked off a chain of events that would eventually lead to evolution by doing so. If you are a crab, and your carapace is not extraordinary, humans will eat you. Your family tree will have a smaller number of descendants. If your carapace has even the slightest resemblance to a face, they will not let you pass. You will have more descendants than other people. The crabs put a lot of effort into designing the patterns found in their carapaces. There was eventually produced not just a human face, not just a Japanese face, but the visage of a fierce and scowling samurai, because as the generations of crabs and fishermen passed, the crabs with patterns that most resembled a samurai face survived preferentially. This continued until there was eventually produced not just a human face, not just a Japanese face. This whole thing has nothing to do with what the crabs seek. Selection is a process that is imposed from without. Your chances of surviving exponentially increase if you give the impression that you are a samurai. There will inevitably be a great number of samurai crabs in the future. The process in question is referred to as artificial selection. When it came to the Heike crab, the process was carried out more or less unconsciously by the fishermen, and the crabs themselves did not appear to give it any significant thought. However, for thousands of years, humans have deliberately chosen which species of plants and animals will survive and which will perish. From birth, we are surrounded by the sights and smells of commonplace farm and domestic animals, fruits, trees, and vegetables. Where do they get their supplies? Were they once able to live as they pleased in the wild, but later convinced to move to a more manageable environment on a farm? In contrast, the reality is very different. The vast majority of them were produced by our team. No dairy cows, ferret hounds, or large ears of corn existed 10,000 years ago. We were able to exercise parental authority over these plants and animals by controlling their reproduction after we had domesticated their ancestors, which often resembled very different creatures. We made it a point to prioritize the reproduction of certain varieties because they possessed qualities that we regarded as being desirable. When we decided that we needed a dog to assist us in taking care of our sheep, we chose breeds that were both intelligent and obedient, as well as those that possessed some natural ability to herd, as this ability is useful for animals that hunt in packs. Because of the increased demand for milk and cheese among humans, the udders of dairy cattle have ballooned to enormous proportions. Our maize, also known as maize, has been bred for 10,000 generations to make it tastier and more nutritious than its puny ancestors. In fact, it has been changed so drastically that it cannot reproduce on its own without the assistance of humans. This is the heart of what is known as artificial selection, whether for a Heike crab, a dog, a cow, or an ear of corn. There is a strong genetic component to both the outward appearance and the behavior of plants and animals. They always produce the same results. For whatever reason, humans promote the reproduction of certain varieties of plants and animals, while working to suppress the reproduction of others. The variety selected for preferential reproduction will eventually become abundant, whereas the variety selected against will become rare and possibly extinct. But if humans can create new species of plants and animals, shouldn't nature be able to do the same? Natural selection is the name given to this connected process. The modifications humans have made to animals and plants during the relatively short period that they have existed on Earth, as well as the fossil evidence, make it abundantly clear that life has undergone profound transformations throughout aeons. The fossil record provides unmistakable evidence of extinct species that were once abundant but have completely disappeared from the Earth. In the history of the Earth, many more species have gone extinct than there are living today. These extinct species are the domestication process has hastened the occurrence of genetic changes in the population. It was not until early medieval times that the rabbit was domesticated. It was bred by French monks in the belief that newborn bunnies were fish, and therefore exempt from the prohibitions against eating meat on certain days in the church calendar. Coffee was not domesticated until the 15th century. The sugar beetroot was not domesticated until the 19th century, and the domestication of the mink is still in its earliest stages. Domestication has increased the weight of wool grown by sheep from less than 1 kilogram of coarse hairs to 10 or 20 kilograms of uniform, fine down in less than 10,000 years. Similarly, the volume of milk given by cattle during a lactation period has increased from a few hundred to 1 million cubic centimeters. Considering that artificial selection can quickly bring about such profound shifts, one can only imagine what natural selection, which operates over billions of years, is capable of. The answer is all the splendor and variety in the natural world. The theory of evolution has no basis in reality. The great discovery made by Charles Darwin and Alfred Russel Wallace is that the driving force behind evolution is natural selection. This discovery is associated with the names of Charles Darwin and Alfred Russel Wallace. More than a century ago, they emphasized that nature is prolific and that many more animals and plants are born than can survive. As a result, the environment selects those varieties that are, by accident, better suited for survival. Because of this, they believed that the environment selects those varieties that are better suited for survival. Mutations, defined as sudden changes in genetic inheritance, are heritable. They supply the essential building blocks for evolution. The environment picks out the few beneficial mutations to survival, leading to gradual changes from one life form into another and the birth of new species. In his book, On the Origin of Species, Charles Darwin wrote, "Variability is not caused by humans. Rather, humans unintentionally expose organic beings to new conditions of life, allowing nature to exert its influence on the organization, which results in variability. However, man can pick and choose among the variations that nature has provided him, and can, therefore, accumulate them in any way he pleases. In this way, he manipulates living things for his own benefit or pleasure, including animals and plants. He may do this on purpose, but it's also possible that he does it unintentionally by keeping the individuals who are the most useful to him at the time, without giving any thought to changing the breed. There is no obvious reason why the principles that have acted so efficiently under domestication should not have acted under natural circumstances. There are always more people born than there is room for them to survive. It only takes the tiniest advantage in one being, at any age or during any season, over those with which it comes into competition or a better adaptation to the surrounding physical conditions, no matter how slight, to tip the scales in one direction or the other. H. Huxley, the most influential 19th century defender and popularizer of evolution, wrote that the publications of Darwin and Wallace were a flash of light, which to a man who has lost himself in a dark night, suddenly reveals a road which, whether it takes him straight home or not, certainly goes his way. My reflection, when I first made myself master of the central idea of the origin of species, was, how extremely stupid not to have thought of that. Many people were shocked, some of them still are, by the concepts of evolution and natural selection. Our ancestors looked at the sophistication of life on Earth and noticed how well suited the structures of organisms are to the roles that they play, and they concluded that there must have been an intelligent designer behind all of this. Even the simplest organism, consisting of just one cell, is a far more complex machine than the most intricate pocket watch. However, pocket watches do not spontaneously self-assemble or evolve slowly and methodically from other clocks, such as grandfather clocks. A watch requires the services of a watchmaker. There did not appear to be any way that atoms and molecules could have somehow fallen together spontaneously to create organisms of such astounding complexity and delicate functioning, concept that great living thing had a unique purpose, and that one species could not evolve into another were perfectly consistent with what our ancestors knew about life, even though they only had access to limited historical records. The concept that every living thing was painstakingly assembled by an all-powerful designer lent significance and order to the natural world and importance to human beings that we continue to yearn for today. An explanation of the biological world that involves a designer is natural, appealing, and completely human. On the other hand, natural selection makes life's music more beautiful as the aeons pass, as Darwin and Wallace demonstrated. This method is just as appealing, humane, and far more compelling. The existence of a great designer may be consistent with the fossil evidence. Certain species are whipped out when the designer grows dissatisfied with them, and new experiments are attempted on an improved design. However, this idea gives me a slightly uneasy feeling. Each plant and animal is exquisitely crafted. However, a designer with such a high level of expertise ought to have been able to create the intended variety from the very beginning. The fossil record suggests that there was a process of trial and error and an inability to predict the future. These are characteristics that are inconsistent with a great designer who is efficient, but are consistent with a designer who has a temperament that is more remote and indirect. During the early 1950s, when I was a first-year student at a university, I had the incredible opportunity to work in the laboratory of H.J. Muller, a distinguished geneticist, who first hypothesized that exposure to radiation causes genetic mutations. Muller was the one who first brought the example of the Heike crab to my attention, as an illustration of how artificial selection works. I worked with fruit flies, also known as Drosophila melanogaster, which literally translates to the black-bodied dew lover, for a significant amount of time to gain experience in the applied aspects of genetics. Fruit flies are tiny, harmless beings with 2 wings and large eyes. We stored them in milk bottles with a pint capacity each. We would breed 2 different types to see what new forms would result from the reorganization of the genes in the parental organisms and from any natural or artificial mutations. The female fruit flies would lay their eggs on molasses that the laboratory technicians would place inside the bottles. The bottles would then be sealed, and we would wait for 2 weeks for the fertilized eggs to develop into larvae, for the larvae to develop into pupae, and for the pupae to develop into new adult fruit flies. One day, I was busy separating the various varieties of adult Drosophila using a camel's hairbrush while looking through a low-power binocular microscope at a freshly arrived batch of adult Drosophila immobilized with a little ether. To my astonishment, I came across something very different. It wasn't just a minor variation like the eyes being red instead of white or having neck bristles instead of having no neck bristles. This was a different kind of creature, and it was very well functioning. It had much more prominent wings and its long and feathery antennae. I concluded that fate had predetermined that an example of a major evolutionary change in a single generation should occur in Muller's laboratory, even though Muller had stated that such a thing could never happen. My unenviable responsibility was to break the news to him. I did so with a heavy heart, as I knocked on the door of his office. I had found a very different kind of fly. I was sure it had emerged from one of the pupae in the molasses. I didn't mean to disturb Muller, but does it look more like Lepidoptera than Diptera? Does it have big wings? He asked, his face lit up from below. I had no idea what he was talking about, so he had to explain it. Does it have feathery antennae? I gave a glum nod in agreement. Muller smiled benignly as he turned on the light in the overhead fixture. It had been told many times before. One moth species had become accustomed to the conditions found in Drosophila genetics labs. It was not comparable to a fruit fly, and I had no interest in having anything to do with it. Molasses was what it desired, specifically that of the fruit flies. While the laboratory technician was unstopping and stopping the milk bottle, for example, to add fruit flies, the mother moth made a dive-bombing pass, dropping her eggs into the delicious molasses while she was running. Before this, I was unaware of any macromutations. It turned out that I had merely stumbled upon yet another beautiful adaptation that had developed in the natural world due to micromutations. Keys to understanding evolution are death and time. The deaths of enormous numbers of life forms imperfectly adapted to the environment, time for a long succession of small mutations that were by accident adaptive, and time for the slow accumulation of patterns of advantageous mutations over long periods. These are the secrets of evolution. Our inability to conceptualize the passage of centuries, let alone aeons, contributes to our rejection of Darwin and Wallace's theory of evolution by natural selection. What does a lifespan of 1/1,000,000th of a second mean to beings that have been around for 70 million years? We are like butterflies that only live for a day but believe their existence will last forever. The events that occurred here on Earth may be more or less typical of the evolution of life on many worlds. However, the history of life on Earth may be unique across the entirety of the Milky Way galaxy in certain specifics, such as the chemistry of proteins or the neurology of brains. Around 4.6 billion years ago, gas and dust from interstellar space coalesced to form the planet Earth. As a result of the fossil record, we know that the beginning of life occurred not long after, possibly around 4.0 billion years ago, in the primitive oceans and ponds on Earth. There is no evidence that the first living things were nearly as complicated as a single-celled organism, already a highly developed form of life. The initial stirrings were of a much more subdued nature. In those early days, lightning and ultraviolet light from the sun broke apart the simple hydrogen-rich molecules that made up the primitive atmosphere. The fragments of these molecules then spontaneously recombined into more complex molecules. The products of this early chemistry were dissolved in the oceans, creating a kind of organic soup of gradually increasing complexity. This continued until one day, quite by accident, a molecule emerged that could make crude copies of itself by utilizing other molecules in the soup as building blocks. This event is considered to be the beginning of life on Earth. At a later time, we will discuss this topic once more. This was the progenitor of deoxyribonucleic acid, also known as DNA, which is the fundamental building block of all life on Earth. It looks like a ladder coiled into a helix, and each rung can be one of 4 distinct molecular parts. These parts correspond to the genetic code's first, second, third, and fourth letters. These steps, called nucleotides, contain the genetic instructions necessary to construct a particular organism. Every form of life that has ever existed on this planet has unique instructions written in the same language. The distinct instructions within each organism's nucleic acid are largely responsible for the observed diversity among living things. A nucleotide can undergo a change known as a mutation if that change is successfully copied into the next generation. Most mutations are harmful or fatal because they involve random changes to nucleotides. These mutations code for enzymes that are inactive and do not function properly. It takes a very long time for a mutation to improve the functioning of an organism. Despite this, the driving force behind evolution is an improbable occurrence known as a beneficial mutation in a nucleotide that is only 10 millionths of a centimeter across. Before 4 billion years, Earth was like a molecule-sized version of the Garden of Eden. There were no dangerous animals around just yet. Some molecules ineffectively reproduced themselves, competed with one another for building blocks, and left behind crude copies of themselves. Even on a molecular level, evolution was well underway due to reproduction, mutation, and the selective elimination of less effective varieties. They gradually became more proficient at reproduction as time went on. Eventually, molecules that had specialized functions came together to form what is now known as the first cell, which is a molecular collective. Photosynthesis is the process by which carbohydrates and oxygen are produced from glucose and carbon dioxide using light energy, water, and carbon dioxide. Modern plant cells contain molecular factories known as chloroplasts, which are responsible for this process. A different kind of molecular factory known as the mitochondrion can be found within the cells that make up a drop of blood. Mitochondria extract usable energy from food by combining it with oxygen. These factories are found in the cells of plants and animals, but they may have been free-living at one point in the past. By 3 billion years ago, several one-celled plants had fused into one organism. This may have occurred due to a mutation that prevented a single cell from dividing into 2 distinct cells. The first organisms with multiple cells came into existence. Every cell in your body can be considered a community, with its formerly independent components working together to benefit the whole. You, on the other hand, are comprised of 100 trillion cells. Each one of us is a part of a much larger whole. It is estimated that sexual activity began approximately 2 billion years ago. Before that time, the only way new varieties of organisms could emerge was by accumulating random mutations which consisted of the selection of changes made to the genetic instructions letter by letter. The process of evolution had to have been excruciatingly slow. Because of the development of sexual reproduction, 2 organisms can now exchange entire paragraphs, pages, and books of their DNA code, producing new varieties prepared for selection. It is advantageous for organisms to engage in sexual behavior, as those that do not find it interesting will quickly become extinct. In addition, this is true of the microbes that existed 2 billion years ago. Today, there is a palpable dedication among us humans to the process of exchanging different sections of our DNA. By 1 billion years ago, plants had, through concerted effort, brought about a revolutionary shift in the natural environment of the Earth, the production of molecule oxygen by green plants. as a result of the fact that the oceans were already teeming with simple green plants. Oxygen was starting to become a major component of the Earth's atmosphere. This irreversibly changed the atmosphere from its initial state of being rich in hydrogen, and ended the period in Earth's history when the building blocks of life were created by non-biological processes. On the other hand, oxygen has a tendency to cause organic molecules to disassemble. Although we have a soft spot for it, it is, at its core, a toxin for organic matter that is not protected. Due to their inability to function in an oxygen-rich environment, many organisms did not survive the transition to an oxidizing atmosphere and became extinct. Even in modern times, some archaic forms can only live in oxygen-free environments. Examples of these include the botulism and tetanus bacilli. Nitrogen is a much more chemically inert element than oxygen, and as a result it is found in much higher concentrations in the Earth's atmosphere. However, it is also maintained by biological processes. Therefore, biological processes are responsible for 99% of the atmosphere that surrounds the Earth. The atmosphere itself is alive. Since the beginning of life on Earth some 4 billion years ago, the most common organisms have been microscopic blue-green algae, which have covered and filled the oceans for most of that time. Then, approximately 600 million years ago, the algae's monopolizing grip was broken, and an enormous proliferation of new life forms emerged. This phenomenon is referred to as the Cambrian explosion. The fact that life appeared on Earth so soon after the planet's formation hints that it may have resulted from a chemical reaction that could not have been avoided on a planet with similar conditions. The fact that life only advanced a little beyond blue-green algae for 3 billion years suggests that large life forms with specialized organs are difficult to evolve. In fact, it is even more difficult to evolve than the origin of life itself. Many other planets may have abundant microbes, but no large animals or plants. In a short amount of time after the Cambrian explosion, the oceans were already home to a wide variety of life forms. There were vast herds of trilobites around 500 million years ago. These animals had a beautiful construction and were similar to large insects in appearance. Some of them hunted in packs on the ocean floor. Crystals were stored in their eyes so that they could detect polarized light. On the other hand, there are no living trilobites in the world today, and there haven't been any for the past 200 million years. The planet was home to many plants and animals, none of which can be found today in any living form. In addition, every living species now found on this planet was at once absent from it. There is no evidence of animals similar to us in the ancient rocks. The emergence of species is followed by a more or less fleeting presence and eventual extinction. Before the Cambrian explosion, species were succeeding one another in a relatively slow fashion. This may be the case partly because the quality of our information rapidly deteriorates the further back in time we look. During the early stages of the history of our planet, few organisms had hard parts, and soft beings left behind very few. Painstaking evolution of cell structure and biochemistry does not immediately reflect itself in the external forms revealed by the fossil record. However, the slow rate at which dramatic new forms appeared before the Cambrian explosion is partly because this rate was real. Following the Cambrian explosion, exquisite new adaptations emerged one after the other at a comparatively breathtaking rate. In rapid succession, the first fish and the first vertebrates appeared. Plants, which were previously restricted to the oceans, began the colonization of the land. The first insect evolved, and its descendants became the pioneers in the colonization of the land by animals. Winged insects arose together with the amphibians, creatures similar to the lungfish, able to survive both on land and in the water. The first trees and the first reptiles appeared. The dinosaurs evolved. The first mammals appeared. The first birds appeared. The primates thought to have given rise to humans, apes, and monkeys. The first creatures that closely resembled human beings evolved less than 10 million years ago, concurrently with a spectacular increase in brain size. These creatures lived less than 10 million years ago, and then just a few million years ago, the very first true humans appeared on the scene. Our species evolved in the woods, so we have a fundamental connection to these environments. Seeing a tree reaching for the clouds is a beautiful sight. Because their leaves must absorb sunlight to photosynthesize, trees compete with one another by casting shadows on adjacent plants. If you look carefully, you can frequently see two trees jostling gracefully and unhurriedly. Trees are magnificent and aesthetically pleasing machines that are driven by the sun. They can extract water from the soil and carbon dioxide from the air, then turn these elements into food for their own consumption and ours. To carry out its function as a plant, the organism relies on the energy provided by the carbohydrates that it produces. And we animals, who are ultimately just parasites on the plants, have to rob them of their carbohydrates so that we can carry on with our lives. By consuming plants, we can combine the carbohydrates with the oxygen already dissolved in our blood due to our need to breathe air. This allows us to extract the energy that allows us to move around. During this process, we release carbon dioxide into the atmosphere, which the plants can reuse to produce additional carbohydrates. A planet-wide mutual mouth-to-stoma resuscitation, the beautiful cycle is powered by a 150 million kilometers away star. What a marvelous cooperative arrangement. Plants and animals inhaling the other's exhalations. Tens of billions of different kinds of organic molecules have been discovered so far. However, only about 50 of them are used for the necessary activities for survival. The same patterns are used repeatedly, but this time more cleverly and economically, for various purposes. At the very core of life on Earth, the proteins that regulate the chemistry of the cell and the nucleic acids that carry the instructions for inheritance, we find that these molecules are essentially the same in all living things, including plants and animals. The same stuff that makes up an oak tree also makes up me. You'll find that we share an ancestor when you return far enough. A living cell is a system that is just as intricate and breathtaking as the universe, which is filled with galaxies and stars. Over 4 billion years, the complex machinery that makes up a cell has been painstakingly developed. Food is broken down into components and then used to make cellular machinery. The white blood cell of today is the equivalent of the creamed spinach of yesteryear. What is the mechanism that the cell uses? On the inside is a complex and intricate architecture responsible for the upkeep of its structure, the transformation of molecules, the storage of energy, and the preparation for self-replication. If we could enter a cell, the majority of the specks that we would see are protein molecules. Some of these molecules are engaged in frenetic activity while others wait. Enzymes, which are molecules that control the chemical reactions that take place within the cell, are the most important proteins. Enzymes are analogous to workers on an assembly line. Each enzyme is specialized for a particular molecular job, such as Step 4 in constructing the nucleotide guanosine phosphate, or Step 11 in dismantling a sugar molecule to extract energy. Energy is the currency that pays for getting the other cellular jobs done. Enzymes are like workers on an assembly line. However, enzymes are not in charge of the show. They get their instructions from those in charge, who are also responsible for their own construction due to the orders they receive. Nucleic acids are the cell's nucleus, located far within its interior and considered off-limits. If we were to enter the nucleus of a cell through a pore, we would find something that looks like an explosion in a spaghetti factory. We would find a disorderly multitude of coils and strands, which are the two different types of nucleic acids: DNA, which knows what to do, and RNA, which conveys the instructions issued by DNA to the rest of the cell. These are the best results that 4 billion years of evolution have been able to produce. They contain the complete set of information on how to make a cell, a tree, or a human being function properly. If written in regular language, the amount of information in human DNA would require 100 thick volumes. In addition, the DNA molecules can produce, with extremely limited exceptions, carbon copies that are indistinguishable from themselves. They have an incredible amount of knowledge. The structure of DNA is known as a double helix, and its two strands, which are intertwined, take the form of a spiral staircase. The language of life can be understood by looking at the specific order in which the nucleotides are arranged along either of the constituent strands. During the process of reproduction, the helices split apart with the help of a specialized protein that unwinds them, and then each slice synthesizes an identical copy of the other, using nucleotide building blocks that are nearby and floating in the viscous liquid that makes up the nucleus of the cell. Once the process of unwinding has begun, a remarkable enzyme known as DNA polymerase helps to ensure that the copying process will almost always be successful. If a mistake is made, some enzymes will cut out and replace the incorrect nucleotide with the correct one. These enzymes are atomically precise machines that are capable of phenomenal feats. In addition to producing exact copies of itself, which is the purpose of heredity, nuclear DNA directs the cell's activities, which is the purpose of metabolism, by synthesizing another nucleic acid called messenger RNA. Each of these messenger RNA molecules travels to the extranuclear regions of the cell, where it controls the construction of an enzyme at the appropriate time and location. After everything is said and done, a single enzyme molecule will have been produced. This molecule will then set about organizing a specific component of the chemistry that occurs within the cell. The ladder that makes up human DNA is 1 billion nucleotides in length. Most possible permutations of nucleotides are meaningless because they would synthesize proteins with no practical purpose. The number of nucleic acid molecules useful for complex life forms like ours is extremely low. Despite this, the number of useful ways to combine nucleic acids is mind-bogglingly large. It is probably much higher than the total number of electrons and protons in the universe. Consequently, the number of individual human beings who could exist is significantly higher than the number of humans who have ever existed. The unrealized potential of the human species is enormous. There must be ways of putting nucleic acids together that, according to any criterion we choose, will function significantly better than any human being that has ever lived. To our good fortune, we do not yet know how to combine different nucleotide sequences to produce different kinds of human beings. The possibility that, in the not-too-distant future, we can assemble nucleotides into any sequence we want to produce any characteristics we deem desirable is both a sobering and unsettling prospect. Mutation and selection are the two processes that drive evolution. If the enzyme DNA polymerase makes an error during replication, then mutations may occur. However, it is extremely prone to making errors. It is also possible for mutations to occur due to radioactivity, ultraviolet light from the sun, cosmic rays, or chemicals found in the environment. Each of these factors has the potential to alter the nucleotides or to tangle the nucleic acids. If the mutation rate is too high, we risk losing the inheritance of 4 billion years' worth of painstakingly gradual evolution. If it is too low, no new varieties will be available to adapt to potential environmental changes. Life's evolution must strike a more or less precise balance between random mutation and selective breeding. When that equilibrium is reached, remarkable adaptations begin to take place. A single change in a DNA nucleotide will result in a single change in an amino acid in the protein the DNA codes for. People of European descent tend to have red blood cells that are roughly globular in shape. Red blood cells in the bodies of some people of African descent appear as they carry less oxygen. Sickle cells are responsible for transmitting sickle cell anemia. They also offer a significant degree of protection against malaria. There is no room for debate regarding the fact that having anemia is preferable to being dead. This major influence on the function of the blood is the result of a change in a single nucleotide out of the 10 billion found in the DNA of a typical human cell. The effect is so striking that it is readily apparent in photographs of red blood cells. We still do not fully understand the ramifications of changes made to most other nucleotides. The appearance of humans is quite distinct from that of trees. There is no question that our way of perceiving the world is distinct from that of a tree. However, beneath the surface, at the molecular core of life, trees and humans are virtually indistinguishable. Both you and I pass on genetic information using nucleic acids, and the chemical processes inside our cells are orchestrated by proteins acting as enzymes. The fact that we both use the same codebook to translate information in nucleic acids into information about proteins is perhaps the single most important similarity between us and the vast majority of other living things on this planet. This molecular unity is typically explained by the idea that all living things, including trees and people, anglerfish, slime molds, and paramecia, are descended from a single and shared instance of the origin of life in the early history of our planet. Then, how did the essential molecules come into existence? My research group at Cornell University focuses, among other things, on biological organic chemistry. Through our efforts, we can make some notes on the composition of life. We combine and ignite the gases present on the early Earth, including hydrogen, water, ammonia, methane, and hydrogen sulfide. These elements can also be found on Jupiter and elsewhere in the cosmos. Lightning, which was also present on the ancient Earth and on modern Jupiter, corresponds to the sparks that can be seen. At the beginning of the reaction vessel is clear and the precursor gases are completely unobservable. After 10 minutes of sparking, however, we notice an odd brown pigment slowly spreading along the vessel's sides. The interior eventually turns out to be completely opaque and is coated in a viscous brown tar. If we had used ultraviolet light, we would have been simulating the early sun's rays, and the results would have been relatively unaltered. Tar is an extremely rich collection of complex organic molecules, including the components of proteins and nucleic acids. Tar can be found in various environments, including caves and swamps. It turns out that the essential components of life can be fabricated with relative ease. Stanley Miller, a graduate student of the chemist Harold Urey at the time, was the first person to conduct experiments in the early 1950s. Urey had argued convincingly that the early atmosphere of the Earth was rich in hydrogen, as is most of the rest of the universe. That the hydrogen has since leaked away into space from Earth, but not from massive Jupiter, and that the origin of life occurred before the hydrogen was lost. Someone questioned Urey about what he anticipated the outcome of such an experiment would be after he proposed the idea of sparking such gases. Urey replied, "Beilstein. Beilstein is a German compendium in 28 volumes, listing all the organic molecules known to chemists. We can produce the fundamental components of life by utilizing only the most abundant gases present on early Earth, and almost any energy source that breaks chemical bonds. However, the molecules we have in our vessel are only the notes of the music of life, not the music itself. For life to exist, the atomic components must be assembled properly. It isn't easy to conceive of a simpler organism that is, in any sense, livable. The smallest living things known, the viroids, comprise less than 10,000 atoms. They cause several diseases in cultivated plants and have probably most recently evolved from more complex organisms rather than simpler ones. No one has been able to perform an experiment in which the gases and waters of the early Earth were mixed together and had something crawl out of the test tube at the end of the experiment. The smallest known free-living organisms are the PPLO, pleuropneumonia-like organisms, and similar small beasts. They are composed of about 50 million atoms. Such organisms, which must be more self-reliant, are more complicated than viroids and viruses. But the environment of the Earth today is not extremely favorable for simple forms of life. You have to be careful about predators. In the early history of our planet, however, when enormous amounts of organic molecules were being produced by sunlight in a hydrogen-rich atmosphere, very simple, non-parasitic organisms had a fighting chance. The first living things may have been like free-living viroids, only a few hundred nucleotides long. Experimental work on making such creatures from scratch may begin by the end of the century. There is still much to be understood about the origin of life, including the origin of the genetic code. But we have been performing such experiments for only some 30 years. Nature has had a 4 billion-year head start. All in all, we have not done badly. The initial gases and the energy sources are ubiquitous throughout the cosmos. Chemical reactions similar to those in our laboratory vessels may be responsible for the organic matter in interstellar space, and the amino acids found in meteorites. The molecules of life are abundant throughout the cosmos. But even if life on another planet has the same molecular chemistry as here, there is no reason to expect it to resemble familiar organisms. Consider the enormous diversity of living things on Earth, all of which share the same planet and identical molecular biology. Those other beasts and vegetables are probably very different from any organism we know here. There may have been some convergent evolution because there may be only one best solution to a certain environment. I am only familiar with one form of life on Earth. As a result, I cannot describe what life elsewhere in the universe might be like. Some people, such as science fiction writers and artists, have tried to imagine what other beings might be like. However, I am skeptical about most of these extraterrestrial visions because they appear to be based too heavily on forms of life that we are already familiar with. On a giant gas planet like Jupiter, with an atmosphere rich in hydrogen, helium, methane, water, and ammonia, there is no easily accessible solid surface, but rather a dense, cloudy atmosphere in which organic molecules may be falling from the skies like manna from heaven, like the products of our laboratory experiments. However, there is a characteristic impediment to life on such a planet. The atmosphere is turbulent and hot down deep. An organism must be careful to avoid being. My colleague at Cornell, E. Salpeter, and I have performed calculations to demonstrate that life can exist on a different planet. Although we can't know exactly what life would be like in such a place, our goal was to determine whether or not, following the laws of physics and chemistry, a world of this kind could possibly be inhabited. One way to make a living under these conditions is to reproduce before you are fried and hope that convection will carry some of your offspring to the higher and cooler layers of the atmosphere. Such organisms could be very small. We call them sinkers. But you could also be a floater, some vast hydrogen balloon pumping helium and heavier gases out of its interior and leaving only the lightest gas, hydrogen, or a hot air balloon, staying buoyant by keeping your interior warm, using energy acquired from the food you eat. Like familiar terrestrial balloons, the deeper a floater is carried, the stronger the buoyant force, returning it to the atmosphere's higher, cooler, and safer regions. A floater might eat preformed organic molecules or make its own from sunlight and air, as plants do on Earth. Up to a point, the bigger a floater is, the more efficient it will be. I imagine floaters kilometers across, enormously larger than the greatest whale ever, being the size of cities. The floaters may propel themselves through the planetary atmosphere with gusts of gas, like a ramjet or a rocket. We imagine them arranged in great lazy herds for as far as the eye can see, with patterns on their skin, an adaptive camouflage implying that they have problems too. Because there is at least one other ecological niche in such an environment: hunting. Hunters are fast and maneuverable. They eat the floaters both for their organic molecules and for their store of pure hydrogen. Hollow sinkers could have evolved into the first floaters and self-propelled floaters into the first hunters. There cannot be many hunters because if they consume all the floaters, the hunters will perish. If there are billions of inhabited worlds in the Milky Way galaxy, perhaps there will be a few that are populated by the sinkers, floaters, and hunters that our imaginations, which have been tempered by the laws of physics and chemistry. Nature is not obligated to follow our speculations. Art bestows a certain charm upon such life forms. There is no predictive theory of biology, just as there is not yet a predictive theory of history. For the same reason, both subjects are still too complicated for us. However, we can know ourselves better by understanding other cases. The study of a single instance of extraterrestrial life, no matter how humble, W. There is no predictive theory of biology, just as there is not yet a predictive theory of history for the same reason. Both subjects are still too complicated for us. But we can know ourselves. Only the voice of life in one tiny world has been audible to us until this point. But we have recently started to pay attention to the other voices that may be present in the cosmic cacophony. The completion of all things. There would only be a little to do if we lived on a planet with a chance of changing anything. There would be nothing that required deduction or deduction. There would be no driving force behind the advancement of science. And if we lived in an unpredictably chaotic world, where things changed in completely arbitrary or extremely convoluted ways, we would not be able to figure out what was happening. Again, the concept of science would be completely non-existent. but we live in a universe somewhere in the middle, and everything around us shifts and changes according to certain patterns, rules, or the laws of nature. If I toss a stick into the air, it will inevitably land on the ground. If the sun goes down in the west, it will always rise in the opposite direction the following morning in the east. As a result, it is now possible to figure out what's going on. We can conduct scientific research, and by doing so, we can make our lives better. The capacity of human beings to comprehend their surroundings is impressive. We have been since the beginning. Only after we had solved a certain problem could we successfully hunt the game and build fires. There was once a time when there was no television, motion pictures, radio, or books. The majority of human history took place during this particular period. On a night with no moon, we sat around the dwindling embers of the campfire and gazed up at the stars. A lot is going on in the night sky. There are recurring themes present. You are capable, without making an effort, of imagining pictures. For instance, a pattern known as a constellation can be found in the northern sky with an Ursine appearance. Some cultures refer to it as the Great Bear. Some people have very different mental pictures. As a matter of course, these images are not projected onto the night sky, rather, we have placed them there ourselves. We were hunters by trade, so we encountered other hunters with their dogs, bears, and young women. These things piqued our interest. Toucans and peacocks, telescopes and microscopes, compasses, and the sterns of ships were some things that 17th century European sailors thought they saw in the southern skies when they first encountered them in the 17th century. If the constellations had been named in the 20th century, we would see things like refrigerators, bicycles, rock and roll stars, and mushroom clouds in the night sky. These things would represent a new set of human hopes and fears that would have been placed among the stars. Occasionally, our ancestors would glimpse a bright star with a tail hurtling across the sky for a moment. They called it a falling star, but this is not an accurate name because the old stars are still there after the falling star falls. There is a regularity here as well. Some seasons have a lot of falling stars, while others have very few. There is order, predictability, and permanence about the stars. In a way, they are almost comforting. Like the sun and moon, the stars always rise in the east and set in the west, taking the whole night to cross the sky if they pass overhead. There are different constellations in different seasons. The same constellations always rise at the beginning of autumn, for example. It never happens that a new constellation suddenly rises out of the east. Certain stars rise just before or set just after the sun, at times and positions that vary with the seasons. You could predict the seasons if you carefully observed and recorded the stars over many years. You could also measure the time of year by noting where the sun rose each day on the horizon. The sky was a great calendar, available to anyone who was dedicated and had the ability. Ancestors built devices to measure the passing of the seasons. Chaco Canyon, New Mexico, has a great roofless ceremonial kiva or temple dating from the 11th century. On June 21st, the longest day of the year, a shaft of sunlight enters a window at dawn and slowly moves so that it covers a special niche. But this happens only around June 21st. I imagine the proud Anasazi people who describe themselves as the Ancient Ones, gathered in their pews every June 21st, dressed in feathers, rattles, and turquoise to celebrate the sun's power. They also monitored the moon's apparent motion. The 28 higher niches in the kiva may represent the number of days for the moon to return to the same position among the constellations. These people paid close attention to the sun, the moon, and the stars. Other devices based on similar ideas are found at Angkor Wat in Cambodia, Stonehenge in England, Abu Simbel in Egypt, Chichen Itza in Mexico, and the Great Plains in North America. Some alleged calendrical devices may be due to chance, such as an accidental alignment of window and niche on June 21st. However, other devices are wonderfully unique. At one location in the American Southwest, 3 upright slabs moved from their original position about 1,000 years ago. On June 21st, the first day of summer, a dagger of sunlight pouring through an opening in one of the slabs aligns with a spiral carved in the rock. We hunted gazelles, antelope, and buffalo, whose migrations ebbed and flowed with the seasons. Fruits and nuts were ready to be picked at certain times, but not other times. We had to plant and harvest our crops at the right time when we invented agriculture. Annual meetings of far-flung nomadic tribes were set for prescribed times. Only we can hear the wind howling through the canyons of the American Southwest, which serves as a reminder of the 40,000 generations of intelligent men and women who came before us, about whom we know almost nothing, and who are the foundation of our civilization. As time went on, people gained knowledge from their ancestors. The more precisely one knew the position and movements of the sun, moon, and stars, the more reliably one could predict when to hunt, sow, reap, and gather the tribes. But then, much later, another rather curious idea emerged: an assault by mysticism and superstition on what had been primarily an empirical science. The sun and stars controlled the seasons, food and warmth. The moon controlled the tides, the life cycles of many animals, and perhaps the human menstrual period, of central importance for a passionate species dedicated to having children. There was another kind of object in the sky, the wandering or vagabond stars called planets. There are 10 times as many astrologers in the United States as there are astronomers. In modern Western society, it is easy to buy a magazine on astrology, for example, at a newsstand, while finding one on astronomy is much more difficult. Astrology columns appear in virtually every newspaper in the United States, whereas astronomy columns appear in almost none. Chances of success, 1 in 12. What sign are you? And much less frequently. Have you heard that gold is made in the explosions of supernovae? Or, when do you think Congress will decide whether or not to fund a Mars rover? Astrology contends that the constellation the planets are in at the moment of your birth profoundly influences your future. A few thousand years ago, the idea developed that the motions of the planets determined the fates of kings, dynasties, and empires. Astrologers studied the motions of the planets and asked themselves what had happened the last time that, say, Venus was rising in the constellation of the Goat. Something similar could happen this time as well. It was a subtle and risky business. Astrologers came to be employed only by the state. In many countries, it was a capital offense for anyone, but the official astrologer to read the portents in the skies. A good way to overthrow a regime was to predict its downfall. Chinese court astrologers who made inaccurate predictions were executed. Others doctored the records so that, afterwards, they were in perfect conformity with events. Astrology developed into a strange combination of observations, mathematics, careful record-keeping, fuzzy thinking, and pious fraud. Personal astrology originated in Alexandrian Egypt and spread throughout the Greek and Roman worlds approximately 2,000 years ago. Today, we can recognize the antiquity of astrology in words such as disaster, which is Greek for bad star, influenza, Italian for astral influence, Mazel Tov, and Hebrew, and ultimately Babylonia. There were rover goods who were considered sideratio, which means planet-struck. Planets were widely thought to be a direct cause of death. Or consider, it means with the planets, evidently a prerequisite for serious reflection. Consider the mortality statistics in the City of London in 1632. Among the terrible losses from infant and childhood diseases and such exotic illnesses as the rising of lights and the King's Evil, we find that, out of 9,535 deaths. Consider 2 different astrology columns published in the same city on the same day. For example, we can look at the New York Post and the New York Daily News on September 21, 1979. Assume that you are a Libra, which means you were born between September 23 and October 22. The astrologer for the Post predicted that a compromise will help ease tension. This prediction was useful, but vague. You should demand more of yourself, the astrologer for the Daily News advised, providing similarly hazy and distinctive advice. These predictions are not actually predictions. They are advice. They tell what should be done rather than what will occur. They are worded to apply to anyone on purpose, making them extremely general. In addition to this, they exhibit a significant degree of mutual inconsistency, Why are they published with the same lack of remorse as reports on the stock market and sports statistics? The lives of twins can be used to test the validity of astrology. There are many instances in which one of two identical twins passes away during childhood, for example, as a result of a riding accident or being struck by lightning, while the other twin enjoys a long and fruitful life. They were delivered at the same hospital only a few minutes apart. When they were born, precisely the same planets were coming into view. How is it possible for two identical twins to have lives that are so radically different according to astrology? It has also been discovered that astrologers cannot even reach a consensus with one another regarding the interpretation of a specific horoscope. They cannot make accurate predictions about the personalities and destinies of individuals with no information other than their birth time and location, as demonstrated by rigorous testing. A peculiar quality is shared by all of the flags that represent the nations of Earth. The United States flag has 50 stars representing the following: the Soviet Union and Israel with 1 each, Burma with 14, Grenada and Venezuela with 7, China with 5, Iraq with 3, São Tomé and Príncipe with 2, Japan, Uruguay, Malawi, Bangladesh and Taiwan representing the sun, Brazil representing a celestial sphere, Australia, Western Samoa, New Zealand and Papua New Guinea representing the constellation of the Southern Cross. Bhutan, representing stars, are prominently displayed in many socialist nations. Crescent moons are commonly displayed on the flags of many Islamic countries. Almost half of our nation's flags feature astronomical or celestial imagery in some form. The phenomenon crosses cultural boundaries, is secular, and can be found worldwide. It is also not limited to the time that we live in. Seals made in the shape of cylinders that date back to the 3rd millennium BC in Sumer. During the time before the Chinese Revolution, Taoist flags featured various constellations. There is no question in my mind that nations aspire to appropriate a portion of the authority and credibility of the heavens. We are looking to establish a rapport with the universe. When making decisions, we want to keep the big picture in mind. And as it turns out, we are connected, not in the personal, small-scale and unimaginative fashion that the astrologers pretend, but in the deepest ways, involving the origin of matter, the habitability of the earth, and the evolution and destiny of the human species. Claudius Ptolemy, whom we call Ptolemy today, was not related to any of the kings of the same name, despite sharing the same name. Modern popular astrology can be traced directly back to him. He was employed at the Library of Alexandria in Alexandria, Egypt, in the 2nd century. Ptolemy is credited with codifying the Babylonian astrological tradition, where all of the esoteric information about planets ascendant in this or that solar or lunar house, or the age of Aquarius, comes from. The following is an example of a horoscope written in Greek on papyrus during the time of Ptolemy, and pertains to a young girl named Philo, born in 150. It is inscribed with the following information: the birth of Philoe, the 10th year of Antoninus Caesar the Lord, Faminoth 15 to 16, the 1st hour of the night, Sun in Pisces, Jupiter and Mercury in Aries, Saturn in Cancer, Mars in Leo. Ptolemy believed that not only were behavior patterns influenced by the planets and the stars, but that questions regarding stature, complexion, national character, and even congenital physical abnormalities were determined by the stars. Ptolemy also believed that the stars determined whether or not a person would have congenital physical abnormalities. On this particular issue, modern astrologers have taken a more cautious position. However, contemporary astrologers still need to consider Ptolemy's understanding of the precession of the equinoxes. They don't consider the phenomenon of atmospheric refraction, which Ptolemy wrote about. They give a negligible amount of consideration to the numerous moons and planets, asteroids and comets, quasars and pulsars, exploding galaxies, symbiotic stars, cataclysmic variables, and X-ray sources that have been discovered since the time of Ptolemy. The study of the universe in its present state constitutes the scientific discipline known as astronomy. Astrology is a form of pseudoscience that asserts, without providing sufficient evidence, that the movements of other planets have an effect on our day-to-day lives. When Ptolemy lived, there was a lot of confusion about the difference between astronomy and astrology. Today is the day. As an astronomer, Ptolemy was responsible for naming the stars, compiling a list of their relative brightness, providing compelling evidence to support the notion that the Earth is spherical, formulating guidelines for accurately predicting eclipses, and, perhaps most importantly, attempting to comprehend the reason behind the peculiar meandering motion that planets display against the backdrop of far-off constellations. He devised a predictive model to comprehend the movements of the planets and decipher the hidden message in the skies. Ptolemy experienced something akin to ecstasy due to his research into the cosmos. "Mortal as I am," he wrote, "I know that I was born for a day. But when I follow at my pleasure the serried multitude of the stars in their circular course, my feet no longer touch the earth. Mortal as I am," he wrote, "I know that I was born for a day." This is the most natural idea in the world. The earth seems steady, solid, and immobile, while we can see the heavenly bodies rising and setting each day. Every culture has jumped to the geocentric hypothesis. Johannes Kepler wrote, "It is therefore impossible that reason not previously instructed should imagine anything other than that the Earth is the center of the universe." Ptolemy believed that the Earth was the center of the universe. He believed the sun, moon, planets, and stars went around the Earth. However, how can we explain the apparent motion of the planets, such as Mars, which had been known for thousands of years before Ptolemy? One of the epithets given to Mars by the ancient Egyptians was Sekded F.M. Ketket, which means who travels backwards, a clear reference to the apparent motion of Mars in a retrograde model of planetary motion can be represented by a small machine similar to those that existed in Ptolemy's time and served a purpose similar to what Ptolemy's model predicts. It was necessary to determine the real motion of the planets, as seen from up there on the outside, to accurately reproduce the apparent motion of the planets, as seen from down here, on the inside. The challenge was figuring out the real motion of the planets from up there, on the outside. It was thought that perfect transparent spheres on which the planets were mounted would revolve around the Earth. However, instead of being fastened to the spheres directly, they were indirectly connected to them utilizing an asymmetrical wheel. The sphere rotates, the little wheel spins, and Mars appears to perform a loop-the-loop maneuver from our vantage point on Earth. This model allowed for reasonably accurate planetary motion predictions, and they were certainly good enough for the precision of measurement that was available in Ptolemy's day and even many centuries later. There was a heaven or sphere for the Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn, and one more for the stars. Ptolemy's ethereal spheres were imagined in medieval times to be made of crystal. This is why we still talk about the music of the spheres and the seventh heaven. Since it was believed that the Earth was the center of the universe, that creation was based on events that took place on Earth, and that the heavens were imagined to be constructed on utterly unearthly principles, people were not motivated to observe the heavens through astronomy. Ptolemy's model, supported by the Church throughout the Dark Ages, was a major factor in preventing the advancement of astronomy for 1,000 years. Nicholas Copernicus, a Polish Catholic cleric, published a quite different hypothesis to explain the apparent motion of the planets in the year 1543. This hypothesis was able to explain the apparent motion of the planets. The idea that the Sun, not the Earth, was at the center of the universe was by far the most audacious aspect of this theory. The Earth was demoted to the status of just one of the planets, moving in a perfectly circular orbit third in distance from the Sun. Ptolemy had considered such a heliocentric model, but he rejected it immediately because, according to the physics of Aristotle, the implied violent rotation of the Earth seemed contrary to observation. When explaining the movement of the planets as seen from Earth, it worked at least as well as Ptolemy's spheres did. On the other hand, it irritated a lot of people. The Catholic Church placed the work of Copernicus on its list of books that were forbidden until corrected by local ecclesiastical censors in 1616, and it remained on that list until 1835. Even some of Copernicus's admirers argued that he had not really believed in a sun-centered universe, but had proposed it as a convenience for calculating the motions of the planets. Martin Luther referred to him as an upstart astrologer. This fool wishes to reverse the entire science of astronomy. But sacred scripture tells us that Joshua commanded the sun to stand still, not the earth. He lived in a time when the human spirit was fettered and the mind chained. The ecclesiastical pronouncements of a millennium or two earlier on scientific matters were considered more reliable than contemporary findings made with technology. This epochal confrontation between the two views of the cosmos, earth-centered and sun-centered, reached a climax in the 16th and 17th centuries in the person of a man who was both an astrologer and an Johannes Kepler was born in Germany in 1571 and was sent to the Protestant seminary school in the provincial town of Maulbronn to be educated by the clergy. It was a kind of boot camp training young minds in using theological weaponry against the fortress of Roman Catholicism. Kepler, who was stubborn, intelligent, and fiercely independent, suffered 2 friendless years in bleak Maulbronn, becoming isolated and withdrawn. His thoughts were devoted to his imagined unworthiness.
Mars was not always a dusty and desolate world. There is ample evidence that the planet was once warm, had lakes of liquid water, and was habitable for a brief period in its history. Researchers now hope to find traces of this era inside the planet and answers to the question of why Mars changed so drastically. What they then actually discovered shows that Mars is still alive. What does this mean now exactly, also in view of the future settlement of the planet? And could Mars become a living world again through clever terraforming? Stay tuned, because we will now show you Mars from a completely unknown side. In 2018, the InSight Mars lander launched toward the red planet. InSight is short for Interior Exploration Using Seismic Investigations, Geodesy, and Heat Transport. The lander was developed specifically to find out what exactly is going on inside the planet and how the core of Mars is structured. Now, you may think that this is not as exciting as exploring the surface and searching for traces of life or water. But the core has it in itself. It is only in the hitherto completely unknown center of Mars that researchers are finding the missing answers as to why Mars has developed into what it is today and why it has gone from being a possibly inhabited world to a dry wasteland. Using drills and special analysis equipment, the probe penetrates deep inside, taking seismic measurements and recording both the number and intensity of Martian quakes. In the strength of the quakes, researchers currently encountered a big surprise. How does the core of Mars differ from that of the Earth? To understand the explosive nature of InSight's findings, we must first look at the structure of our Earth's core. About 100 years ago, researchers first had the technology to scan Earth's interior in a very unique way. Scientists analyze seismic waves that travel through the Earth's interior. These waves are triggered by natural events, such as the movement of continental plates and even phenomena like earthquakes. As they travel through the Earth's interior, these waves encounter various materials. During the contact between material and wave, the wave takes on a very particular signature that scientists can later distinguish. Layers of rock alter the waves in a very different way than underground cavities or watercourses. Seismic waves occur mainly as P and S waves. P waves, or primary waves, are pressure waves that cause rocks to vibrate parallel to the direction of wave propagation. Because they are the fastest seismic waves, they are the first to arrive from the epicenter of the earthquake. S waves, or secondary waves, are shear waves that vibrate rocks perpendicular to the direction of wave propagation. They travel about 60% of the speed of P waves and arrive after the P wave has passed. In 1906, seismologists discovered that seismic waves travel much slower in the Earth's core than in other sections. Even more interesting was the observation that S waves did not penetrate the core, while P waves passed through it easily. Only at the boundary of the core did an interesting deflection occur. From these observations, the scientists were able to conclude that the inner core is solid, while the layer above it is liquid. The core of iron and nickel in the innermost becomes solid due to the high pressure. In 1936, researchers again found that seismic waves reflected off the inner core, indicating a transition from a liquid to a solid state. Thanks to these discoveries, we now know that Earth's core is composed of complex layers, and geologists have an advanced understanding of Earth's evolution. The connection between the Martian core and the magnetic field. Research on the structure of the Martian core revealed shocking connections between the planet's interior and the magnetosphere. Based on seismic data, the Martian core was found to have a liquid consistency throughout. In contrast, Earth's core consists of a solid inner core and a liquid outer core. The research suggests that the composition of the Martian core, particularly the presence of lighter elements, contributes to this phenomenon. While Earth has a strong magnetic field generated by geodynamo activity in the outer liquid core, Mars has a much weaker magnetic field. This relatively weak magnetic field of Mars has implications for the planet's ability to protect its atmosphere and minimize the harmful effects of charged particles from space. Earth is almost perfectly protected from the constant particle bombardment from the Sun by its strong field, but Mars was hit with much greater harshness by solar winds over epochs. Unprotected, the particle streams from the Sun were able to affect the outer atmosphere of Mars and even eroded over millions of years. Together with cosmic rays, the Martian atmosphere was so significantly depleted that the planet is now virtually unprotected. Mars's lower gravitational pull and lack of a sufficiently strong magnetic field has also allowed charged particles to penetrate the upper atmosphere and trigger chemical processes there. This led to the release of gas molecules, including lighter elements such as hydrogen and helium, into space. The changes in the atmosphere in turn had an impact on the surface of Mars. While liquid water may have existed on Mars in the past, it largely evaporated or escaped into space due to the loss of the atmosphere and protection from solar winds. Computer simulations show that erosion by particle flows very likely contributed to the formation of Mars's distinctive geologic features. Today, the surface of Mars is characterized by dusty and rocky expanses, dried-up riverbeds, and vast volcanic areas. In short, we could say that Mars slowly dried up, and if there ever was life on it, it disappeared with the water and with the increase in radiation. Our Earth, on the other hand, was able to support life to this day because of its robust magnetic field and dense atmosphere. Yet today, in the face of climate catastrophe, we naturally wonder if such a fate also awaits our planet. The parallels between the effects of solar winds on Mars and current changes on Earth are unmistakable. Our human activity has resulted in more and more greenhouse gases being released into the Earth's atmosphere. If nothing changes, we will destroy our atmosphere ourselves, and our homeland will also be more and more exposed to the influences of the Sun and the cosmos. Already today, the fragile ecosystems and the general basis of life are threatened. The comparison with Mars shows how delicate planetary balances are and how important it is to protect the Earth and find sustainable solutions. So, far from just opening up a potential new home for humans, the exploration of Mars also serves to better understand what is going on our planet and what consequences we should expect. But let's move away from the dramas currently unfolding on our home planet and look further afield to Mars. Mars is not as lifeless as previously assumed. On the contrary, a force is currently awakening inside the planet that scientists do not yet really know what it means for the future of the planet. Unusual Mars quakes alarm scientists. During its 4-year active phase, InSight detected hundreds of Mars quakes. But it wasn't until 2021 that things got really interesting. That year, InSight documented 2 unusual quakes on the opposite side of the planet. One was a massive Mars quake, larger and more powerful than ever recorded before, while the other was the result of a meteorite impact. These events, on the opposite side of InSight, were a windfall for science. The lander was now able to analyze waves that not only traveled around Mars, but also passed through it, once again providing researchers with new data and details about the structure of the core. Exactly this data completed the picture in a way that we now know Mars has a liquid core. But the findings go much further. Thanks to the new data, scientists were able to analyze the elements inside in great detail for the first time. It turned out that the core of Mars has a high proportion of lighter elements. Large amounts of sulfur, followed by smaller amounts of oxygen, carbon, and hydrogen, make up nearly 1/5 of the planet's weight. Exploration of the interior of Mars continued to be exciting. On May 4th, 2022, InSight recorded the strongest Mars quake ever measured. The seismic shaking of the Martian subsurface reached magnitude 5 for the first time. A quake of this magnitude would also be clearly noticeable on Earth, but for Mars, this event is a true megaquake compared to all previous shaking. Strictly speaking, researchers did not even consider quakes of this magnitude possible on our planetary neighbor. Why Mars is now suddenly shaking with this strength is a mystery that scientists will continue to investigate. The activities in the interior and the flare-up of the quakes show that Mars is far from dead, even if it appears so at first glance. In fact, it's quite possible that the planet will continue to change as it evolves, possibly due to the influence of us humans as well. A revitalized world thanks to terraforming? Elon Musk, the visionary CEO of SpaceX, has the ambitious goal of making Mars a second Earth for humanity. Among the most fantastic plans of key technologies to make this goal possible is terraforming. Terraforming stands for a process by which the environmental conditions of a planet are altered to make them more Earth-like and thus habitable to humans. Musk's plans for terraforming on Mars include an artificial greenhouse effect that could be ushered in by 2 nuclear rockets detonated over the Martian poles. The carbon dioxide then released would, by pure calculation, create a greenhouse effect and raise temperatures on Mars. A warmer environment would release frozen water and further compress the atmosphere, which in turn could further drive temperatures. In addition to the nuclear option, Musk has proposed placing advanced solar sails or mirrors in orbit around Mars to direct more sunlight to the surface and accelerate warming. Terraforming, despite these already detailed prospects, is a complicated process that could take centuries and involves many unknowns. The latest findings about Mars's weak magnetic field and liquid core may now present more unexpected obstacles to Elon Musk's plans. Experts fear that despite all efforts, Mars would lose liquefied water so quickly that no significant atmosphere and climate with a closed water cycle can develop. But how do you see the current developments on Mars? Do you think goals like terraforming are feasible and even important for us humans? Or do you rather think we should leave Mars as it is and take care of our own planet?
Mars and Venus are our closest neighbors in the solar system. If Mars is in a particularly favorable position, it's only 55.6 million kilometers away from us on its elliptical orbit. Then we see it as bright red with the naked eye standing in the night sky. Astronomers observed strange processes on Mars as early as the 17th century. Due to the change in color and Earth-like surface structures, it was soon assumed that life existed on Mars. Mars is a rocky planet, just like the Earth, Venus, and Mercury. Only the outer planets that follow Mars are gas giants. With an equatorial diameter of 6,800 kilometers, Mars is only about half the size of Earth, which has a diameter of 12,800 kilometers. In terms of composition, Mars actually resembles Earth. However, the gases on Mars are currently distributed quite differently. The atmosphere of the red planet is very thin, and oxygen is only present in small amounts. The thin atmosphere allows a great deal of unfiltered cosmic radiation to reach Mars. Nevertheless, Mars has other amazing similarities to our planet. A Martian day is 24 hours, 39 minutes, and 35.244 seconds long, almost the same as an Earth day. On Mars, there are seasons in which the climate and the thickness of the poles change. However, the seasons on Mars last twice as long. This is simply because the Martian year is 687 days, almost twice as long as an Earth year. Mars therefore needs twice as long to complete its orbit around the Sun once. Space probes that have visited Mars. Only the Moon has been better explored than Mars. International space projects have already sent about 50 space probes to Mars. The first successful probes were Viking 1 and 2 of NASA. This double probe was launched in 1976. Viking 1 was successfully operated until 1982. Viking 2 transmitted data from Mars to Earth until 1980. The first Mars robot to land on the surface was the Mars Pathfinder in the 1990s. Most recently, the Mars Rover Opportunity from 2004 to 2019 and the Mars Rover Curiosity from 2004 to 2010 were on a research mission to our neighbor. First indications of life on Mars. Since Mars is very easy to observe when it is close to the Earth, the earliest astrologers noticed the Martian spots. Today, we know that these are seasonal changes in the environment of the Mars poles. When the sun warms the ice layers of the polar caps with the onset of spring on Mars, geysers of carbon dioxide and dark, coarse-grained dust are formed there. These clouds first shoot up into the sky and soon afterwards settle again on the surface of Mars. This results in altered spots and fan-like structures. When the telescopes were considerably improved in the 19th century, astronomers saw the phenomenon even more clearly. At that time, the color structures were thought to be signs of changing vegetation zones. In people's minds, the growing idea arose that life on Mars was Earth-like. In 1854, the astronomer William Whewell published theories according to which there were oceans, land, and possible life forms on Mars. In 1877, the Italian astronomer Giovanni Schiaparelli recognized the Martian troughs, or canali, Italian for trough. Schiaparelli assumed that these were structures formed by water. Due to a translation error, the gullies became the Martian channels. As a result, the idea of humans on Mars continued to grow among the population. Some people were also inspired by the idea of living on Mars. Others became afraid of so-called Martians. The hysteria increased when the British author H.G. Wells published the world bestseller The War of the Worlds in 1897. The story tells of an invasion of Martians invading the Earth. Since then, the beliefs and superstitions surrounding life on Mars and the Martians themselves have become engraved in our minds. Reconnaissance through space probes. About 80 years later, mankind was already able to send the first unknown space probes to Mars. Of course, the people on Earth were curious if any of the ideas about the living Mars would come true. Before that, scientists had already tried to establish radio contact with possible relatives on Mars. However, no answer ever came. Finally, in July 1976, the Viking 1 mission transmitted the first images from the orbit of Mars. Over the course of the exploration, the image of a dry desert planet became more apparent than a world full of water and life. However, the probe also sent pictures back to Earth, which provided food for thought. Highlight number 1 was the face of Mars. The rock structure in the Cydonia region of Mars actually resembled a human face. Other bizarre shapes that the orbiter was able to photograph were pyramids and rectangular structures that scientists compared to the appearance of an Inca city. The evidence of artificially created buildings and monuments on Mars was reason enough for NASA to send the Mars Global Surveyor to Mars for closer examination in 1996. Almost 2 years later came the big disillusionment for all ufologists and alien friends. The new high-resolution photographs showed the Mars face from different perspectives. It was clearly recognizable that the face is in reality a shapeless rock formation. Only the angle of the view and the incidence of light created the optical illusion of a face in the first images. The other phenomena could also be explained by similar effects and the consequences of natural erosion. Nevertheless, the Mars Global Surveyor was the first space probe ever sent into space to investigate extraterrestrial life. The search for the Martian continues. Although images such as the face of Mars have repeatedly proved to be optical illusions, ufologists never tire of trying to detect signs of aliens on Mars. The internet is full of images that also come from the newer space probes. Sometimes paraforcers claim to have recognized the bones of a giant on Mars, and from time to time, new Martians and Martian faces appear. Is there water on Mars? But let's get back to results from renowned science. The question of whether or not there is water on Mars occupied researchers, as did the question of clarifying the apparent structures. It seemed to be clear that the Martian atmosphere is too thin to allow surface water to form. The air pressure is too low, but it was suspected that water could exist in deeper layers of rock in the form of underground lakes or oceans. In 2010, a student accidentally found evidence of seasonally occurring trickles of liquid salt water in the Hale crater of Mars. Where this came from and why it only appears at certain times remains a mystery. It's possible that Mars pushes liquid from the interior upwards when its surface is heated. So, you could also say that Mars is sweating. Thanks to the European Mars mission Mars Express, the existence of liquid water on Mars could finally be proven in 2018. Using georadar, a lake of about 20 kilometers wide at the south pole of Mars was discovered. The liquid and probably salty water is hidden under a 0.5 kilometer thick layer of ice. Using the data provided by Mars Express, astronomers constructed a completely new picture of Mars's past. At least 3.6 billion years ago, the red planet is said to have had a warm and humid climate with numerous lakes and waterways. This could explain the leaching of the Martian troughs and other surface structures. Only later did the atmosphere disappear and Mars finally dried up. Indications of organic life. Already, Viking 1 delivered pictures in the 1970s that pointed to residues of organic structures. However, laboratory tests showed that such structures can also be produced purely chemically. Of course, it has long been clear that neither humanoid beings nor other more complex life forms can exist on Mars. Currently, researchers are looking for microorganisms, such as unicellular organisms, primitive algae, or bacteria. After all, these life forms once formed the basis for life we know today on Earth. New hope was provided by a rock from Mars. This reached the Earth in the form of a Mars meteorite. The rock with the name ALH 84001 was found in Antarctica in 1984. It was not until 1996 that U.S. researchers thought they had found traces of fossil bacteria on the boulder. Later, however, it could be proven that similar structures can also be created chemically. During its 6-year mission, the Mars rover Curiosity proved the existence of so-called thiophenes on Mars. These are complex organic hydrocarbons, which are almost always of organic origin, at least on Earth. On Earth, the ring-shaped compounds are found in coal tar and petroleum. Both are clearly degradation products of organic substances. A team from the Technical University of Berlin worked for years on researching possible pathways for the formation of thiophenes. To date, the researchers can still only make assumptions. The organic formation is admittedly more probable because it's much more frequent and easier. So the traces could really have been remnants of the earlier, more life-friendly conditions on Mars. However, a single chemical path of origin is also conceivable. Thiophenes are also formed when substances containing sulfate are heated to over 120 degrees. Another possibility would be the contamination of the Martian surface with thiophenes by a meteorite impact. So in the end, we can only proclaim again, we don't know anything specific. However, there is growing evidence that Mars may once have been an overgrown and inhabited planet. It is conceivable that several million years later, nothing more than rock, sand, and deserts have remained on the surface. If we look at the forecast for our Earth, scientists draw a very similar picture in the distant future. Apart from stones and desert, not much will be left of our former culture. Will we by then have moved to another planet? Who knows? If the sun has heated up the Earth so much that it becomes uninhabitable, Mars or another planet could be an alternative for us. While the exploration of the Martian surface has already revealed some breathtaking discoveries, the exact composition of the planet's interior has long been an unsolved mystery. Thanks to cutting-edge technology, NASA recently succeeded in getting one step closer to deciphering this galactic mystery. Equipped with a seismometer and a heat flow probe, the InSight lander has been investigating the deeper rock layers of the red planet for almost 3 years. InSight is not only intended to keep an eye on the current composition of Mars, but also to investigate the earliest development processes that gave the celestial body its characteristic shape. Just what information the InSight lander has already been able to provide in this regard, and what questions still need to be answered in the future, we'll reveal to you now. The InSight lander. In May 2014, NASA presented the public with its ambitious plans. At that time, the renowned space agency announced that it was working on building the InSight lander. This Mars mission was meant to answer a number of burning controversies that had been dividing experts into different camps for many years. The data transmitted by the technical equipment should not only help to fathom the nature of Mars, but also decipher the mysteries of all rocky planets of the solar system. That categorization of celestial bodies, to which our Earth also belongs, shares a common origin. Specifically, the origin of the planets is based on a process called accretion in the ranks of astronomers. During this process, a cosmic object collects matter by its gravity and the effects of tidal forces. As the terrestrial body grows in size, its interior begins to heat up. This process, in turn, is accompanied by a drastic reshaping, at the end of which a core, a mantle, and a crust are formed. The remaining rocky planets in our solar system, in contrast to the Earth, were reshaped later by a process called differentiation. This process, which describes the formation of different materials from a once homogeneous mass, is still one of the great mysteries of modern research. Experts hope that InSight's in-depth investigation of Mars will provide new clues about the earliest evolutionary processes of such celestial bodies. After the originally planned launch was postponed by more than 2 years due to a leak in the seismometer, the time finally came on May 5th, 2018. InSight left our blue home planet and set off for the fabled red planet. On November 26th of the same year, InSight touched down as planned on the surface of the celestial body, which is covered in iron oxide dust. In order to perform its work profitably, the lander was equipped with various measuring instruments. The so-called seismic experiment for interior structure is used to make precise seismic measurements on the red planet. By investigating such activities, important insights into the history of the planet can also be gained. The heat flow and physical properties package instrument serve the purpose of determining the heat flow in the Martian sediment. A 15-inch long and approximately 2-inch thick RAM probe was used for this purpose. In the run-up to the mission, the Warsaw-built device had the goal of penetrating about 16 feet into the Martian soil. The plan was for the RAM probe to stop about every 2.5 feet in order to then carry out special heat measurements. This was to be done by calling up a preset heat output in each case. With the aid of the temperature sensors located on the head of the probe, the heating of the drill head and the rate at which the heat was spreading would then be measured. In the course of this procedure, the experts hoped to learn more about the physical properties of the Martian soil. However, the deployment of the equipment was not to be. In the spring of 2019, the RAM probe got stuck in the ground at a depth of about 1 foot. In fact, the friction between the heat flow probe and the Martian soil was much lower than the scientists had expected. After the RAM probe was freed by a robotic arm and able to resume its task, it was not long before the next problems arose. The instrument had once again become wedged in the ground. However, since this time it was not possible to free the RAM probe from its awkward position, the earthly scientists had no choice but to end the experiment at the beginning of the year 2021. However, this doesn't mean that the InSight mission has been a failure. In truth, the seismometer has already provided some important information that gives us a previously unknown insight into the interior of the celestial body. The interior of the red planet. Thanks to the successful InSight mission, terrestrial scientists were privileged to record another galactic milestone. With its complex measuring instruments, the lander succeeded in registering more than 700 Mars quakes. With the help of the recorded data, researchers managed to make the first direct measurement of an alien planet's interior. Although more in-depth research is needed in the future to fully understand the tectonic makeup of the red planet, the information gathered so far provides important clues as to what lies beneath the red, rust-covered surface of Mars. On the one hand, the knowledge gathered in this regard helps us to better understand the current structure of the red planet. In addition, this information can also be used to reconstruct how the celestial body was formed in the past. The seismological measurements carried out at the landing site of the InSight lander made it possible for the first time to constrain the thickness of the Martian crust in the corresponding region. Furthermore, taking gravity and topography into account, it's even possible to map the crust thickness of the entire celestial body. Since experts have been waiting for several decades to unravel this cosmic mystery, the successful completion of this endeavor was tantamount to a galactic blockbuster. The data that InSight has so far transmitted to terrestrial scientists supports two different models. On the one hand, it's conceivable that the Martian crust is relatively thin and composed of two layers. The higher, porous layer may have been chemically altered over the millennia. According to researchers, however, the underlying layer is likely to still have its almost unchanged original composition. In contrast to this is the thesis that the crust of the red planet is not composed of two, but rather 3 layers. If the first case is correct, the top layer would have a thickness of about 12 miles. This would make it much thinner than the experts had expected. If the Martian crust has 3 layers, the first layer would be twice as thick. The planetary core. Currently, researchers assume that the planet's entire crust is between 15 and 45 miles thick. In addition, some evidence suggests that Mars' natural shell is enriched with radioactive elements. These would strongly heat the crust layers at the expense of the planet's interior. Another interesting fact is that Mars has an extremely thick lithosphere. This outermost crustal layer is about twice as thick as the lithosphere of our blue home planet. This natural composition could ultimately explain why there have been no plate tectonic processes on Mars. If we go further into the interior of the celestial body, we come across the mantle. This structure, which encloses the planet's core, consists of silicates and is composed of a single layer. The core of the red planet is apparently much larger than the experts predicted. For example, the data collected by InSight brought the realization that the heart of Mars has a radius of about 1,100 miles. In addition, the information also confirmed a thesis that had long been considered probable among scientists. The Martian core is liquid. Furthermore, the information obtained indicates that the chemical composition of the innermost region of the planet holds some surprises. Since the corresponding areas are less massive than expected, it's reasonable to conclude that lighter elements are also present within the molten nickel and iron, which ultimately reduce the density. On the basis of these circumstances, insightful conclusions can be drawn about the development of the planet itself. For example, so that the red planet could accumulate the appropriate light elements, for example hydrogen, oxygen, carbon, and sulfur in its core, it must have formed very early on. It's possible that Mars was already formed when the solar nebula still existed, the interstellar molecular cloud from which our solar system ultimately formed. Consequently, Mars was possibly formed much earlier than our blue home planet. However, the important findings already recorded during the InSight mission are only the prelude to an even more detailed investigation of the planet's interior. One of the tasks that the lander will have to complete by the end of its mission in December 2022 is to answer an overriding question. What is the cause of the numerous Mars quakes that have been recorded in the Cerberus Fossae trenches? In order to plumb this topic, experts hope that further quakes will occur on the red planet in the future, which will be different from the previous ones. The hope of the scientists lies not least in an increased intensity of tremors. The Mars quakes registered so far were so weak that we would probably not even have felt them on Earth. Stronger quakes and the accompanying measurement of the seismic waves would help the researchers to fathom the interior of our galactic neighbor even more comprehensively.
The InSight Mars lander touched the surface of Mars for the first time on November 26, 2018. In the course of the nearly 4-year mission, NASA finally discovered what scientists had been looking for on Mars for so long. But what is it that researchers have wanted to know about Mars for so long? And what will this discovery change now? Are you curious? Then follow us now on this journey to the last secrets of the Red Planet. InSight's launch to a mission of the century. Mars probes and rovers have been many in the history of planetary exploration to date, but InSight was different. The unusual lander was designed and equipped like no probe before it. Scientists involved in the project eagerly watched the launch of the Atlas V rocket that would carry InSight into space. On May 5, 2018, the time had come, and the spacecraft lifted off from the Vandenberg Air Force Base and set out on its journey. At NASA, the launch of the mission was viewed with mixed emotions. At that point, more than half of the planned Mars missions had failed. Either they had never launched, or they had failed when they arrived on Mars. Millions were lost as a result, and no one knew what InSight's fate would be. InSight also began with a problem. A previous launch attempt was delayed for several months due to a vacuum leak in the size instrument. But all went well. In Earth orbit, InSight slowly detached from the rocket stages and then floated freely in space. The lander was in space for 6.5 months. The technical device covered 484 million kilometers until it entered the thin atmosphere of Mars, 125 kilometers above the surface on November 26, 2018. The probe, which weighed just 700 kilograms, hurtled through the atmosphere at almost 20,000 kilometers per hour, having to withstand temperatures of around 1,500 degrees Celsius. To ensure that the fine measuring instruments on board the probe and all the other expensive gimmicks could withstand this extreme stress, InSight was securely packed in a kind of protective cover. The probe covered the last few meters hanging from a parachute, and its own small rocket engines provided the necessary counter-thrust to let the probe land safely and softly on the Martian soil. As soon as it arrived, InSight began deploying its solar panels and taking initial measurements. Thus began some 4 years of exciting Mars exploration. Past Mars missions. InSight was the first high-power seismic measurement station on Mars. NASA had previously sent 2 other main missions to Mars equipped with seismometers. However, the technology of Viking 1 and Viking 2, which were launched in the 1970s, cannot be compared to the technical capabilities of InSight. Moreover, the Viking missions were quite a bust. The seismometer of Viking 1 did not work properly during the landing and could not be used at all. Viking 2 was able to take measurements, but the instruments were so poorly calibrated after landing that it has always remained unclear whether the probe's measurements were due to seismic activity